right, previously we've seen some new syntax, so now we're going to take a quick detour and essentially learn what each of these things are to make sure that when we go on, we actually understand, what each of these things are doing, what their purpose is, and how they work. So the first thing that we're going to start with is this thing here, where we import this fast API class and then we initialize it. So let's take a look at classes. A class is something that we can define with the class keyword. And a class is really interesting because previously the only thing that we've seen like this that was kind of similar is the function, where we could define something and we could have some sort of function name and some variables that we pass to it, and then some content or some code that it executes. And every time we called this function, we would repeat the same piece of code, which was extremely convenient if we want to, shorten our code or make it less messy, or just, we have to do the same thing several times, so we don't want to run into copy paste errors or something like that. So now a class is also extremely cool because rather than just having a function, it allows us to create a whole collection of variables and functions that work together as an entity. And the entity can be whatever it is that we define. So let's take a look at a very simple class, and let's create an animal class. Now, something that you'll notice about the syntax is previously when I've been declaring variables, for example, like test value, I always used an underscore, and the same thing with functions. When you're declaring class names, you always start with a uppercase. And so this convention here is called camel case. So let's say we have here snow animals. Every new word is going to be started with an uppercase. Whereas for variables, we'll have snow animals where they're separated by an underscore, which is called snake case. Just kind of as a side note, these are the conventions that we're going to be using. But anyway, so we have the animal class, and then we can have just a colon here for now. And now inside, we can have several different things. The first thing that we actually don't need, but it would be really nice to have, and generally you'll have this in almost every single class that you'll see, is something that looks like this. You have underscore underscore, init underscore underscore, open and close parentheses, and then there's a self inside, and we'll fill this out in a second. So what is going on here? So this method here is what is being called when we initialize the class. So what does initialize the class mean? Well, just like a function, if we have something like test print hello, this doesn't get executed until we call this function. And similarly, when we create a class, the class just sits there, but we need to create an instance of it to be able to use it. So this instance is what we can have in a variable. So for example, to create two animals, we'll have animal1 is equal to animal, and we'll have animal2 is equal to animal. Now we're going to be going kind of back and forth and learning as we're doing because I think we need the references to be able to understand, but we also need to expand on this a little bit to actually be able to fully understand what is going on here. So essentially right now, just like for functions that we've seen, for classes also, we need to initialize them, which is what we'll do by calling their name like this and then open and close parentheses afterwards. And this will take our class and it will give us an instance of it. And these two will behave differently. These can be two different animals, and if we change one, if we act upon one, it's not going to affect the other one. But we'll kind of see that as we continue on here. Now, the other thing that we have here is this self keyword. This self keyword is what allows us to reference properties of the class itself. So we can have both variables and functions, which in classes are called methods. So we'll also see that in a second, but you'll see how the self keyword is used in a second. So let's just continue on with this init method for now. So let's say we want to give the animal a default or a height and a weight, and we want to be able to define these parameters upon initialization of the class. And so the animal has a height and a weight, so we're going to say self.height, is equal to height, and self dot weight is equal to weight. And you'll recognize this syntax here from functions. We're essentially passing in two variables. So we can see here now, we can pass in the height and set this maybe to, I don't know, 120, and we'll use the weight to 80 arbitrary units. And similarly here, we'll set the height equal to 70, and here the weight equal to 150, like this. And let's also just go ahead and run this. So we'll go Python main, and well, nothing happens yet because I'm not printing anything out, but at least it's running and we're not getting any errors. Now you'll notice if I create an animal 3 and I initialize this to be an animal and I don't put in any parameters, now we're going to get an error because as part of the initialization, as part of this creation of the class, so we take the class and to create an instance of it and save that into, in this case, a variable, we need to pass the initialization parameters, just like for a function. If we have parameters or variables in a function, we can't just not pass them. We need to pass them unless they have default values, which we can also do here for classes. We can set the weight by default equal to 100 and the height by default also equal to 100. And the same rules apply here as for functions. If we start setting default variables or default values, we have to kind of do that for all variables to follow. So if we do it like this, everything is going to be fine again. All right. Still though, we're not really seeing much, right? So we have this self keyword, which we kind of right now use, but we're not exactly sure yet why. And we have this instance of the class, which may or may not make sense yet. So let's go ahead and create something else. So now we're going to create a method that just prints out the height. So we'll call this def print height. And here we're going to use the self keyword again, and we're just going to do nothing for now. And it's complaining about something here. Let me see what that error is. On an indentation mismatch. All right, let's see. What is complaining about with the indent here somewhere? There we go. So something weird happened with the formatting and one of the indents was wrong here. All right. So here again, we have this self, and let's just use it for now. And then in a second, we'll see what happens when we don't use it. So we're going to print out the height, and all that we're going to do is do print, and we're going to have a formatted string. This animal's height is, and then we'll call here self.height. And then we're going to, we have our animal. So now this is a method that we've created. So a function that is part of the class. We can't just call print height by itself. This is not going to work because this isn't a function in and of itself that we can call. This function, and because it's part of a class, it's called a method, is attached to the class. So we can do, for example, animal1 dot print height. And now we're using the print height method that belongs to the animal class. So if I run this, we can see here animal1 dot print height. So using the print height method of the animal class, this animal's height is 120, and we can see here we set the height to 120 when we initialize the class, and that's what we're printing out here. So what happens if we, instead of using self.height here, just used height? I can already see this is going to fail because my code editor is kind of hinting this for us. But if I run this, it's telling us height is not defined, although it's right here. But the thing is, height is not a local variable. Height is an attribute of our class. And to be able to access these shared attributes of our class, we have to reference the self. So the class itself, this instance of the class itself, we want to take its height. So we don't just have full access to these variables across everything within our class here. And so if we do want to use anything that is part of the class, we have to reference the self dot. Otherwise we can't. And it's just kind of this standard syntax that then to even have access to this self variable, which is for referencing the class itself, we need to have that as the first parameter in our method declaration. So if we don't have this here, then again, I won't be able to access the class itself because this self parameter is not available to us. And you can actually see here, when I'm trying to call it, it says it takes 0 arguments, but 1 was given because the class instance itself is kind of used for this purpose, because that's just the default behavior that we have. And so that's the importance of the self. But we don't just need this for variables or for the attributes here, the values, but we also need this to access the class methods. So for example, let's say we have a different method here called getHeight. And all that this does is return the classes or the animal's height. So we can print out, for example, animal2.getHeight. And we'll have here the output from animal1's height is 120, which is here. Animal2's height is 70, which is also what we initialized it with. And so we can see we're just getting the value. So if we want to update our print height method here to use this getHeight method that is also part of the class, again, we can't just do this because it's not seeing that this is the class method. To be able to reference other methods of our class, we have to use this self keyword. So we can see here, now the response is the same, but rather than accessing the variable here, or the value, the attribute that we've defined here, we're using the method which just happens to return the value in this case. Now obviously these are very simple cases, but I hope you get the idea that as we're creating attributes of the animal or of the classes in general and methods of the class, we have to just keep this self keyword in mind to be able to use the parts of it that are defined. Now the interesting thing is we don't actually need to use a method like this to get access to the attributes. So for example, we could take animal3 and we could just access the height variable like this. And here we go. So we get the same result as from a getHeight. We can just access this attribute like this. It's not hidden to us or anything like that. It's fully available for us to use. Now there are some other ways or other cool things that we can do for classes. One of them is, and you probably may or may not have actively noticed this, but obviously the height across these 3 different animals is different, right? But actually there are shared variables that we can create too. So let's say the fur color, and let's set this to gray. Now this is outside of the initialization, and actually when we define a property like this, the first thing you'll notice is I'm not using the self. But if I want to access it somewhere, so for example def get fur color, I still have to return self dot fur color like this. Again, just using fur color, you can already see here it's not going to work. Now let's also create another variable here that we're going to call them friends. And this one we're going to have be a list, right? And you can also create a get friends. We're just going to return self dot friends if we want to. All right. So, and one thing that you'll also always notice me doing, just as a side note, is always keep 2 new lines between a class definition and something else, just because that's kind of standard Python formatting syntax, and you'll see my IDE already complaining if there's not enough spaces here. So just as a side note there. All right, so let's go ahead and we're going to print out animal1 dot fur color and animal2 dot get fur color, which will give us the same result. And let's just run this for now. So it's gray and gray, as expected. All right, and interestingly and cool is they all share this value. So this is going to be shared across all instances of the class. Now we can try to overwrite it if we want by just going into here, accessing the variable, and setting this to pink, for example. And if we print this out, you're probably going to get we're going to get exactly what you probably expected, which is it hasn't changed. But now let's try the same thing for our friends here. So we're going to change this out with friends, and here we'll do get friends. Then we're going to take our friends here, and to this we're going to append Jerry, and then we're going to print this out again. So the interesting thing now is previously when we used our strings here, this didn't change, but when we're using the list here, this did change. Now this is really interesting and something that you may or may not want to be using sooner or later. And we have these variables that are shared across all instances of the class, and the main difference here is that strings are actually immutable, so we can't actually change them, and when we create new ones, when we change it, we're actually creating new ones, whereas lists, for example, are mutable objects, which means we can change them. And so we can see that this shared variable of the list is actually being changed across all instances because it is something that is changeable. So just be aware of that we have these shared variables here, and in the case of strings, for example, with strings being immutable, we're not going to see this reflected across our other classes, but in the case of our list here, which is a mutable object, which is something that we can change without creating a new instance of it, we are going to be seeing these changes across all the classes because these are shared variables. So this is something that's pretty cool. Of course, depending on the circumstance, you may want to use something like this, or you may not want to use something like this, and then just being aware that this is how that works can help you ensure you're not running into some weird problems that may take a little bit of time to debug. So finally, I just want to also show you some other methods. So generally here we've seen like these getter methods, which just get the value, which you may or may not want to use, because as you can see, we can also just directly access the attributes, but sometimes it's nice to have like this interface for it that kind of does the work for us. In this case, obviously it's not much, but sometimes, things are a little bit more complicated. For example, forming a URL or something like that, which has different components to it, and then having like a get, URL method or something like that that just puts it all together for you can be nice. And similarly, something that you may sometimes see is this set whatever. So we can say, for example, set height, we have the self, and we have the new height or the height, whatever we want to have, and then we can set self.height equal to height, which lets us update this. Now, obviously, what we can do is if we take animal3's height here again, and we print that out at the bottom, what we can do is we can take this and just do this and just printing that out again. Obviously this is going to work, but what we can also do is we can do set height, use the class method, and then also here it's going to update the class property, and so we can see the same change occurring here. So this is something that you may or may not be seeing, or sometimes you may want to provide options for it, because maybe when you change one thing, there actually have to be changes in other places too to kind of like make everything consistent. And so sometimes having this interface method, which lets you change something and just make sure that everything around it is also properly updated, then that can be a really nice thing. One example that I can think of, for example, is if you want to set a new URL for an object to use. Maybe internally you don't store the whole URL, but you kind of have like the base part of the URL, then you have like the endpoint extension, which is the thing after the slash, and then maybe you also have a port. And so what you can do is you can have a set URL, but actually what it does is it takes that URL and it splits it into the 3 components and updates the 3 attributes so that your base component, your endpoint, and your port are all correct in your properties here. Just kind of a basic example. So yeah, we've learned a lot about classes now, and hopefully what we did previously when we called that fast API and we created an instance of it, it makes a little bit more sense now. There's one more cool thing about classes before we move on to the next lesson about class inheritance, which is we can also have private variables. So, oh, here the indentation is weird again. Not exactly sure why this is happening. So here we'll have some private weight, and this we're going to set to 50. Now the only difference I have here is that I've set a underscore in front of it, so we have the private weight here. So the interesting thing is, if we go into animal 3 and we look at its attributes here, you're not actually going to see it pop up. If you just scroll through, you'll see all the other things that we've created, but you won't see that pop up. But we can still access it. It's just not recommended in our IDE. So essentially this acts as a private variable, but it's not actually private. We can still access it. And sometimes, you know, if you have things that you don't want to be used outside, obviously we can't fully protect them in Python, but we can at least use this to kind of indicate that this is a private class variable. And in that way, you know, it at least doesn't show up in the IDE recommendations here. There's also something else. If we use a double underscore, then actually this one is a little bit interesting because this is a class specific private variable. And if we try to access this, now we're going to run into a problem because the actual class name here is not just this, but it actually takes into the name comes something from the initialized class itself. So every class with this variable actually has a different kind of prefix here that has information from the class. So every name here is actually going to be different. So just be aware of that this is, oh, well, obviously this isn't going to work because I made a typo here, but thankfully it still works. But yeah, so just be aware of that with the double underscore, this is something that we can't access. So this is our normal kind of private, doesn't show up in IDE recommendations, indicates to other developers that this is something that should be used internally in the class and isn't something that you should touch. Like we can touch the friends here, for example, or the height. And this one is actually not even going to work like that because the name is, when the class is initialized, is not just this. It actually has a prefix for each that is different for each initialized version of the class. All right, so we've seen classes, but we're going to take this a little bit further because sometimes we don't just use classes like this. We actually use a sense or this thing called class inheritance, where we have a sort of base class and then we have other classes that are extensions from that class. So what does this mean? Well, first of all, let's remove all of this, but keep our animal class here. That could mean, for example, all right, we have an animal which describes something general. And I'm actually going to change this in a second because this isn't really going to fit that much anymore, but we'll see that in a second. So we have a general animal, but then there are many different types of animals, right? We can have dogs, cats, wolves, birds, I don't know, you name it. Lots of different animals, and each of these may be different. So for example, if we had a toad, then, you know, fur color wouldn't necessarily be a thing. So maybe we'll see in a second, we'll change this up. Whereas, you know, for a wolf, we would have something like that. So yeah, let's go ahead and create a class that we're going to call dog. And essentially what we want this dog to be is, well, we want this dog to have all of the features here, all of the methods, as well as all of the attributes of the animal, but it also has some other things that are unique to the dog. And so the way that we can achieve that is by using class inheritance. So what we do when we define this dog class, we're going to open and close parentheses after him. And then in here, we're going to put the class or classes that it inherits from. So right now, it's only going to inherit from one class, which is the animal. But if we have more classes, for example, class B and class C, just some other classes,
we can inherit from multiple classes. And we'll again see in a second what exactly this does, but just so that you're aware of the syntax, this is how we can go about it. All right, so now also here we want to have some sort of initialization method, right? And we know that because a dog comes or is a general type of animal, the animal needs a height and a weight. So we at least need to have some sort of height and weight parameter here. Now, we can technically choose not to and set it by default inside, but that's generally not a good idea because then you're removing some of that, explicit declaration power that you do have. So, all right, we have our dog here and we're going to initialize, or we're writing the method for the initialization that we have here. So what we need to do is, well, we also need to initialize the animal because it's a subpart of the animal, and so we need to make sure that we call the initialization method of the animal too, so that all of these properties here get set too, because we don't want to reset them in the dog because they're already being done in the animal. So how can we do that? Well, it's relatively simple. All that we're going to do is just do super, open close parentheses, dot underscore underscore init, like this, and then we can just set the attributes. So for example, we'll set the height to height, and we'll set the weight equal to the weight like this. And now what this is going to do is it's going to initialize everything for us. So it's just going to take care of all of the above initializations and just make sure all of that gets set up properly. Now in this case, we only have one kind of parent class in our child class, which is the dog. Our parent class here is the animal. But in the case where we have several parent classes, and even here our animal could have, an even higher arching class than that, this super will take care of all of the initializations for us. So that's the only thing we really need to keep in mind, is that when we are using inheritance, we need to make sure that all of the initialization is done properly. And the super method will, it's very super, it will take care of all of that for us. Everything that is above this class will be initialized. So again, we'll see what that means in a second. So what we want to have here is we want to have some sort of additional fur color, and essentially what I want to do, I can do this before or after the initialization. This doesn't really matter. This just kind of defines when all of these properties become available. So right now, the self.height here wouldn't be available because the parent class animal in this case hasn't been initialized. But in this case, it would be available. So that's just, something to be aware of here. So I'm going to take this fur color out, and yeah. So we're going to set our fur color here because this is specific to a dog, and then we're going to perform the initialization of the parent classes and all of their potential parent classes. And right now it's just the animal, but if we even have here like class B and class C, this will take care of all of that. So that's really nice. All right, so now we have this initialization, and let's just see what happens just with this. Let's create a sample dog. Oop. And this is going to be a dog class. We're going to initialize it with a height of 50 and a weight of, let's say, 25 and a fur color of brown. And now let's go ahead and look at our sample dog, and obviously we'll have access to the fur color, but we'll also have access, for example, to the height. So if we do here python sample, oh no, main.py, and I'm in my virtual environment here, we'll see this gets printed out. So we can see that even though we didn't need to redefine all of this here, it still gets printed out for us. All of these properties, in this case, these ones here still get created, and actually all of these methods here are also available to us. So for example, we could also do here sample dog.get height, and maybe we'll do print height, because then it will print it out for us directly. And let's run that again, and so we can see here, this animal's height is 50, and we have that method available because everything in here we now have available in the dog. So all of these properties are inherited, plus we get a bunch of extra ones. Now, this is definitely extremely powerful because when you're developing, sometimes you want to have some sort of base and then you want to have variations on it, but a lot of things are going to stay the same. And so there's a lot of code that you can reuse that you don't need to redo that should be shared across everything that inherits from it. But then, you make extra additions that those pieces can be separated, can be treated separately. So, for example, something else that we can do is we can define a general greeting. We can say greet, and here we can print out this animal makes no sound. That's going to be our default. So what happens, for example, when we go into sample_dog.greet, like this, right now we're going to print out this animal makes no sound. But we can actually overload the behavior or override the behavior of this method by redefining it in the class downstream. We can say greet. Here we're going to say woof woof. All right, so if we run the same thing now, we can see here now instead we write woof woof because this is specific to our dog class. And so now we've seen that not only are all of the methods and attributes that we have before available to us, but actually if we want to, we can also change their behavior. And so again, this can be extremely useful because most of the time, you want to have like a set of methods that you repeat to do a specific process, but maybe in one case, one of these steps needs to be treated a little differently. And so then, you can overwrite that one method, but everything else that doesn't need to be changed will still be the same. And it's extremely useful because a lot of your code is reused. And if you ever need to make any changes, you can make it in one place and it will be done everywhere. And if you make a mistake, it's only in that one place and you don't run into like copy paste errors, or if you get to update something somewhere and all of these weird things that, or just human errors that can happen when code is repeated in multiple places, and you just need to make sure everything stays up to date. And if you have a mistake in one of these places, it can get a little weird and complicated. And so ideally we don't want to repeat ourselves, and that way our code becomes clean. And if there is a change that needs to be made, or if there is an error, it's one place that needs to be changed, it's one place that needs to be fixed, and it's not spread all over the place, which just makes developing a lot easier and a lot cleaner. All right, some other cool things that I want to show you with classes that you may see is right now, every time we've created a method here, we've also had to pass the class itself so that it has access to the class parameters and everything. But sometimes you don't necessarily want that. Sometimes, you can do something without needing to use anything from the class. For example, in this case, we don't need to access any of the class attributes. It doesn't matter what the dog's fur color is. It doesn't matter what their height, their weight is. We don't need to access any other methods. We don't need anything from the class. All we're printing out is woof woof. And so what we can do in this case, we could have an @ symbol here, and we'll look at what this @ symbol means in a later lesson, and we can define this as a static method. And in this case, we now no longer need this self, or whatever it is, but the first parameter that indicates to us that this is, or that provides us the access to the class instance. And now this method here is, as you can see, a static method that does not depend on anything within the class. And so we also don't need that parameter here. And we can still have our greeting here. And we can also add other variables. This is almost reading like a normal function at this point. We can have some other, variables in here. For example, we can say greeting. And what we can do instead here is, instead of having woof woof, we can have our greeting. So we can say greet woof. And so we can still take input parameters like this, but we don't need any properties from class or anything like that. Now, previously we've also seen these class attributes. We also have access to class methods. So, for example, let's continue with our greet here, but let's turn this, instead of a static method, we're going to turn this into a class method. Now in this case, we do again need the self parameter, and I'm actually going to remove this greeting although we can still have the extra parameters if we want to. I'm just choosing not to, like this. All right, so a class method, if we just rerun this, everything is still going to work as it did before. But a class method is interesting because right now here we have an initialized version of our dog, right? We have the dog class, and then we've initialized it by providing some sort of parameters, and we have a specific instance of our dog. And we can create a separate dog by initializing it with either the same or different parameters, but that would be a separate instance of our dog. But what we can do with class methods is we can actually use the uninitialized class and, for example, call the class method on it, and it will still work, as we can see here. Now this is interesting because these other components, they kind of require parts of the class. They require an initialized version of the class. But our class method here does not. And an interesting thing, actually, is this works similarly here for our class attributes. So for example, we can print out a dog's starting friends are dog.friends, and now we're just taking the uninitialized version of the class and accessing the friends attribute. And we can see here that this is already defined. But if we try to access the height, for example, then this is not going to work because the uninitialized class dog does not have a height set. It doesn't even have the property until we call the initialization. This doesn't exist until we initialize it, which we do through this syntax here. And so that's kind of interesting because sometimes you'll see this actually being used when you have configuration files, and essentially you can have something like, and we'll get to this later, so don't worry about it, but we can have something like a configuration file, and here we'll have, maybe like a rate limit parameter that we can set, and we'll have like a host URL and stuff like that. And in this case, you don't even need to initialize the configuration. You can just access the rate limit directly by going, for example, into config.rate limit or something like that. So sometimes you'll see this sort of syntax where you actually only have class variables and class methods, because in the case of a configuration file, for example, all of that is going to just be predefined. It's going to be shared across all instances of the class. And in this case, we actually don't even need to initialize it. We can just use the class object directly instead, which just saves us a little bit of syntax. So now that we've seen classes, we're going to go to the other thing that we've kind of hinted at, but haven't looked at quite yet, which is this at syntax that we've seen previously. So yeah, in this lesson, we're going to cover decorators, and we'll see exactly what those are in just a couple of minutes. Now we're going to start off with a very simple function here, and we're just going to call this bark. And all that this function is going to do is it's just going to print out woof. And as you may expect, if we run the function here and then run our code, again, I'm in our virtual environment, I'm going to run our main function here, bam, it says woof. All right, great. So now I'm going to write a second function, and this is going to be called respond to mailman. And essentially what I want to do here is I want to be able to pass some sort of sound, right? It could be bark. We could have something like meow. Not even sure how to spell this, but something like this. We'll say cat response. And I'll have this maybe like this. Not exactly. This looks better. All right. So something like this. So we want to be able to have some sort of like general response that we can give. And then in here, we want to be able to say something like, oh, a mailman is coming. And then we're going to call, depending on if we want to do like a cat response or a bark response here, we'll do one of those. And so this is actually our first look at decorators, because what we're going to do here is we're going to actually pass a function. Now I'm using this func here as the variable name, but this can be anything else. This is just the variable name that we're using, and we're using func because it indicates that this is a function. It makes it easier to read that we're passing in here a function. And then we're going to create another function inside. And for simplicity, I'm going to call this wrapper because this essentially, as you'll see in a second, will wrap the function that we're going to provide as input. And so what we're going to do is we're going to print here a mailman is coming. Then we're going to execute our function that we've passed as input. And then on the outside function, we're going to return our wrapper, but we're not going to call it. All right. So now we have a function which takes as input a function. And inside of this function, we can define another function. And this function definition is only local within this function. And within this function, we first print a mailman is coming, and then we execute the function that we took as input. But we're not executing this function, we're just defining it, and then we're actually returning this function here from this function. So what this can do, for example, is let's say we have the response, and so we're going to say respond to mailman, and I'll put this at the bottom here, respond to mailman, and our response is going to be bark, like this. And if I run this now, we should see no output because nothing is being called. But if we call our response now, then we're going to see a mailman is coming, woof. And you'll notice here, the function that I passed in, I didn't actually call the function like this. I just passed in the pure function callable without it being called. So yeah, let's take another look at that and let's kind of break down what exactly is going on here. So we've defined a function which takes as input a function. Now this here, again, it doesn't have to be func. This could be anything. We're just calling it func because that kind of indicates to us that this is a function. It's just, just like we name our variables properly, we also want to name our input parameters properly. And so in this case, the func is a good name because it indicates to the reader that this is a function. All right, so we're calling this function. We provide our function as input. Inside of this function, we're defining another function. And within this function, we first print this, and then we execute our input function. But because this is a function, this doesn't get executed until we call the function, and we're returning the function that we've defined. And so what we have here, if I can highlight this, if we print out our response here, we can see that this is actually a function. It's not anything, like we usually print out. It's not some sort of variable that, well, it is a variable, but it's not something that contains like readable content, It's just a function like we've defined. For example, if we would print out bark, we would also see that this is a function. And so that's what we've done here. We've created a function that takes as input a function, has an inner function which, adds to it. It wraps something around this function. It wraps some sort of behavior around this function. And then we return essentially this modified function. And that's what we get when we call it. Now, obviously, this syntax here is not super nice. So what we can do instead with Python syntax is we can use this @ symbol, and we can have here respond to mailman. And now, if we call bark, we'll see this gets executed. If we don't have this, then it's just going to be woof. But if we do have this, then we can see it calls both. And so what this @ symbol here does is it modifies this function by essentially providing it as input to this to whatever function we're calling here. And so the response that we have here is actually this function here, which is defined inside here, which is why we see this modified behavior. Similarly, we can also wrap it around our cat response, and we can call the cat response. And here we'll see a mailman is coming woof, and a mailman is coming meow. And that, in its most basic sense, is this decorator that we've previously seen. Now, there's a lot more cool stuff that we can do with this rather than just, you know, this simple thing. So for example, let's say that we want to have a separate function and we're going to call that make sound. And we're going to provide some sort of sound as input. And then what we want to do is we want to print out this sound twice. All right, so if we try to do this, and if we try to say, okay, make sound woof, then what we would expect technically is we provide our function as input here, and we call our function here, and we'll say a mailman is coming. We're going to execute the function, which is going to execute the function that we provided as input, which in this case is going to be this one. We have the sound here, so in this case it should print out woof woof, right? Unfortunately, no, because right now we're not able to properly deal with input arguments. But there's actually a really easy fix that we can do for this, which is we can take this star args and star star keyword arguments that we've seen previously, and this basically allows us to provide any number of input arguments as well as keyword input arguments, and we can pass all of these on to our function. And now we can run it and we can see things are once again working properly. And this is really nice because if we didn't have it like this, if we instead had just, for example, the sound here, we provided the sound as input here, like this, if we now have a second function, bark, and here we would just have a single woof, and we would try to execute bark. Unfortunately, bark would no longer work because it now expects an input, but we're not providing an input. And so to fix that, we can just use the general star args and star star keyword arguments that we've seen earlier on. And now both of these cases are going to be working as expected. And I'm just adding some formatting here because you can see every time in my editor when the formatting is off, there's going to be these greenish yellow ugly lines, which if you hover over, it will also tell you exactly what the formatting issue is. So you can see here, expect 2 blank lines after a class of function definition. So that's why you always see me adding all this extra formatting, just so that everything looks proper. All right, so far so good, but still not every case, right? There's still some other things that we could want to do. For example, imagine we had a function here that says, instead of make sound, it's conjure sound or something weird. And essentially the only difference is it returns this value instead of, printing it out. So, what happens now? Well, now we're in a little bit of a weird space because if we call conjure sound here, we get printed out a mailman is coming, and if we try to say here our return value, and we try to print out our return value, unfortunately, we're not getting anything returned, although from our inside function call here, we should be getting something, right? We were executing. Well, the only thing here is we're not returning it. So we could either return this directly, or we could put this into a variable that right now I'll just call response, but obviously, you can make the name applicable to whatever it is you're using it for, and you can return the response as part of the wrapper. And now, once again, it will work properly. Our return value will be this thing that we're seeing here, which we can also make more clear by maybe updating our print syntax like this. Now, all right, pretty good, but there's even more that we would like to do that we still can't do. And that is, what about if we provide input to our wrapper function here? Being able to provide some sort of input here, some sort of extra defining behavior. So how can we do that? Now I know it's very likely that at this point, we've covered a lot of material in a short amount of time. So if you feel like you just need to, revisit it, I would encourage you either, if you want to watch it through once and then go through it again if you feel like you need to do it one more time, or if you want to, before moving on to this final part, take some time to digest it and come back. Totally fine, totally acceptable. I know this is definitely one of those more complicated topics to wrap your head around, and it's definitely something you need to see a couple of times. So if you need to take that, I highly encourage you to do it, and don't worry about it, because it's better, to take the time to digest this, because I know seeing this the first time, especially if this is your first programming language, can be a little bit confusing and intimidating, and it may just take some time to digest until you properly understand. So I would also just recommend, taking the time and really going through all of this step by step. What is being called? What is the input? How are we moving things around? And maybe even adding some extra print statements just to really see what is being executed where. Try to change things around just a little bit to see if you can modify the behavior so that you properly understand the syntax that we have here. But yeah, on that side note, let's say we want to provide some sort of, extra input arguments. And let's say that rather than, assuming a mailman is coming, we want to say respond to approacher. And in here we can have anything, right? We can have any sort of general name. And in here we want to say respond to approacher, and we can say, for example, mailman, but we could just as well say milkman, maybe. So how can we do this? Well, you can see I've already started kind of modifying our function, but we can have some sort of input variable here, which is, for example, can be our name. Then we need to define our second function, so that's going to be our inner response. And this takes as input the function. I'm going to indent this. We're still going to return our wrapper here, and outside we're going to return our inner response, but we're not going to call it. And I'm just going to update this, making it a formatted string. All right, so what we've done now is rather than having the fixed respond to milkman, where this component here is fixed, we now add another variable here, respond to approacher. And here we can define the name of the type of person that is approaching, which is what we have here. And then in our inner function, we take the function as input, which is going to be this one here. And then inside, we wrap this function inside. So we have the function that we're using inside, but we add some additional behavior to it. And then we return our response from this function. In this case, we want to. In some cases, we may not have to. But in this case, we do want to. We return our wrapper function, and then we return our inner function here. So essentially what we're doing is we have this, the respond to milkman function that we had earlier, and we're kind of generating this, right? We're generating a fixed function here, and we're creating it once. So yeah, still a little bit more flexibility that kind of goes on top of this. I know the syntax looks pretty weird that we have like a function within a function within a function, and each of these are taking different input parameters. So that's again why I'm saying, this can be a little bit overwhelming if this is your first time. So really don't, feel bad about like just taking the time, stepping away, coming back, and just taking the time to digest it, and just going through it step by step, and making sure you understand it, adding variables in some places. So if you wanted to have some sort of extra input, which we can do in a second, just as an example, where we can modify that. All right, so we have here respond to approacher. We're going to do conjure sound. So we've wrapped our conjure sound. And right now we're responding to the milkman instead of the mailman. So if everything is done correctly, we should now see milkman, which is exactly what we have. And here we can say, all right, so let's add an extra parameter here. So maybe we'll have another parameter called approaching. And what we're going to do here is if approaching is true, so we're going to assume it's Boolean, then we'll say a whatever is coming. Otherwise, we're going to say a whatever is leaving. So we can say here now, respond to approacher. We'll have the milkman and we'll say true, so it's approaching. So we should get the same response as previously. Milkman is coming. Put in here false. We'll have a milkman is leaving. And even here we can define default values. So for example, we can provide here true as the default, which means if we don't provide any input, it will default to this behavior, but obviously we can overwrite it, just like we've learned with functions previously. And yeah, this is decorators. Now, it's pretty likely that when you're just starting out, you're probably not going to be building a lot of decorators, but it's important to have taken the look inside to understand how they work and what they do, because as you can see, when we already started just with the pure skeleton for writing our API, we already had to use decorators. So now hopefully with this, you understand more what exactly decorators are and what it means when we're using this at syntax here. Essentially, this here is going to be the same as just calling the function here with this function as the input parameters. So yeah, a big lesson, a lot to take in. I know it may take some time to digest. Again, don't worry about it, and properly take the time to digest it. And I would again recommend just playing around with maybe adding some print statements, adding another variable here, and just seeing what will happen if you use different functions. Now, one other thing to note is that you can actually wrap several functions. Or we can decorate with several functions. For example, we can have a very simple second decorator function that's just going to say print hello. This is going to take a function as input. We're going to have our inside wrapper, and we'll just say here no arguments for now, and we're just going to print hello, and then we're going to execute our function, or maybe, yeah, we'll execute our function, and then we're going to return our wrapper. Now this is not super great for this. I guess we can provide here the arguments and the keyword arguments so that we can pass this on to our function here. So now we could say, for example, okay, respond to the approacher, and we're going to also have another decorator here that says print hello. And now what we should see is we have the respond to approacher, and that only gets called when the innermost function gets called. And so before that, we should also see a hello statement. So let's take a look at this. And missed an input parameter here somewhere. Whoops, I called the function here. So, all right. And in this case, I also forgot to return the result here. So let's do that again. And okay, there we go. So we have a milkman is leaving, and then we execute this inner function. Now this inner function is this. So we have the print hello as input. It took the function. So the function input that we have here is actually this. And so then we go into here, we print hello, and then we execute the function input here, which is now this. So we can see the way that we're executing is going from top to bottom. And we can see that we can see the order here where we go through, we have this component, we execute this function here. And this function that is the input to this here is this here. And in this here, we first print hello, and then we execute the input function here. And the input function here is this one here. All right. So yeah, a lot of powerful stuff that we can do with decorators, and the at symbol here is mainly just around simplifying syntax so that we don't have to write super complicated stuff, because that would look really weird if we just call, function, calling function, calling function, calling function. Like, that would be really long. And so the decorator syntax here with this at syntax allows us to simplify this and make it just a lot more readable, a lot more obviously developer friendly, while still getting all of that great functionality. Now, before we jump back into our API development, There are two more cool things that are very common and useful in Python that I also want to go through to make sure that we, tackle these right off the bat as we're still kind of in our introductory Python part so that we have everything we need as we're going into the whole development phase. So the first of these, which is what this lesson is going to be about, is generators. Now, previously when we looked at functions and just data structures in general, everything was stored in memory instantly. And when we talked about files, we already kind of alluded to this problem that if the file is too large, for example, and we just try to read the whole thing, we're going to run into memory issues. And there we started, iterating through the file itself, but kind of going line by line. Unfortunately, if we try to actually put that into a function, it's going to become a little weird for us because, and let's just write this out. So let's create a function that has, say, populate file. And here we'll have a file name like this. Oops. And here we're just going to say, okay, values to write. And we'll make this be a list. And we'll just say, hello, line 2, line 3, and so on. And then we're going to say with open file name and writing mode as out. We can do out.write. And here we'll say for value to write in values to write, we're going to write out this value, and then we're going to put out a new line. So if we call here populate file, we'll say here sample file.txt, and we go ahead and run this, then here we have our sample file created and get exactly what we expect. So now if we try to create a function to read this, read file, and we'll have a file name, or at least the file reading is part of this, and we'll say, okay, with open file name and reading mode as in file. And now it's a little bit weird because how do we read this line by line and still being able to return from the function? Because what you may do is you have some sort of like data variable, and then you can say for we'll say for line in file, and then we can say here data.append line or something like that, and we can return our data at the end here, but now we're reading our whole file into memory. And so this is not ideal, because if our files are really large, then this is obviously going to cause a problem for us. Now, Python has a very cool thing called generators, and it's specifically used for these types of use cases where essentially you want to do streaming sort of workload. So you don't want to do everything at once, but you want to kind of do it one bit at a time, and you can do it in smaller chunks. And so generators are interesting because rather than having to execute the whole function first and then having our results returned to us at the very end, generators allow us to actually return only partial results, and they save the state of the function for us instead. And the way that we can achieve this is by using this yield keyword. And here we can say yield line. And so now what we can do, for example, let's say file contents. If we just say here read file, we'll put in the file name. Maybe we'll make this a variable so we can reuse it. We'll say here file name is equal to this. Put in here. All right, so now we can reuse our file name to make sure that we don't have any copy paste errors here. And actually, before we do this, let's just do it the way we had previously. So we'll say data.append line, and then we'll return the data list at the end here, and we can print out our file contents. So running this, we can see here, this is our file contents. We have each component in each line. All right, so now if we change this up instead using this yield syntax. If we look at our output now, we see we have a generator object here. All right, so how do we use this? Well, we can use this in a for loop, for example. We can say for file line and file contents, print file line. And if we run this, we can see here we have line by line, and we have the double space because the print also adds one. But we can see here we're reading in the contents line by line. Now the really nice thing about this is we're not reading everything into memory at once, but we're kind of processing it chunk by chunk. We're reading in a line, and then we're returning that value, and we're saving the state of the function at that point. So then when we call the function again, we reload the function from its previous state, and we continue on. And this is extremely nice, as you can probably imagine, because it allows us to save a lot of memory. There's still obviously some memory overhead to kind of keep track of the local state of the function that was called in each specific case, but this makes things a lot easier for us because we can deal with files that are larger than we can actually handle in memory, and we're able to process things chunk by chunk. So this yield syntax, you may not use it all the time, but in some cases, where you're running into like memory issues, or these things can be really large, and it doesn't make sense to load everything beforehand and then return it. You can actually look to use this yield syntax so that you can do things chunk by chunk rather than having to load everything first and then process everything afterward, because this yield really allows you to save a lot of memory since we're only doing one small thing at a time. Now, a cool thing that we can do is we can actually reduce this syntax too. But obviously, of course, we kind of have to only do this if our inner function here would be small, and actually just realize we don't need this data thing here. But rather than having this read file function, we can make this even shorter by using something called a generator expression. And, generator comprehension, or a generator expression, actually, yes. So what we can do, just like we had for list comprehension, where we were able to create a list in a single line, we can do something similar for generators. So we can say here, row for row in, and then we can say open file name in reading mode, for example, in this case. So we're iterating here row by row, or probably rather say line by line, iterating over our file line by line, and this again actually produces a generator for us that is going to give us the exact same results from what we had here. We can see that here, and again we have a generator object, or a generator expression generated from here. And so this is kind of a shorthand that we can have if our function would be small enough. Rather than having to write a function, we could also just write a simple one-liner. Obviously, then, we can't reuse it as much as we can with the function, but, sometimes having a simple one-liner actually makes it a little bit easier and cleaner. Of course, it depends on the situation, but we can get the same result here as we do here, and this, with the parentheses around, actually also creates a generator for us. So we've seen two ways of having generators, but in some cases, we may want to read or return results from a generator in a separate function. And so there's another specific keyword that we can do. And let's say we have another function that says read if exists, and we have the file name here. And we're just going to use a new library at this point that we're not going to worry about too much now. We'll take a look at this later, but we're just going to use it for now so that we can have this example. We're going to use our OS library, which allows us access to some of the operating system checks that we can do essentially. And so what we're going to do is we basically want to check if this file exists, we want to read from it. We want to yield the results from it because we still want to do yielding rather than returning the whole thing. And if it doesn't exist, then we're just going to, return it empty. So what we're going to say is if os.path.is file, the file name here, and again, don't worry about this too much. We're going to look at the OS library a little bit later. We're going to use it for some other things. So right now we're just checking if the file exists with this path. And if so, now we need to return the results from the read file here. But since we're yielding, rather than just returning it, we can actually use the yield from syntax, and then we'll say read file, file name. And if it doesn't, then we're just going to return, and we can just return an empty list. And so here we can say read if exists file name, and if we run this, we'll still get the same results. But if we modify this to something that doesn't exist, then obviously we're not going to get anything because the file contents weren't read. And so we can see there are kind of two accompanying syntaxes. We have the one yield, which kind of allows us to do the step-by-step procedure, and then we have the yield from, where we can actually yield the results from a separate function, which allows us to nicely nest these things, because otherwise we would have problems if we use the return syntax or something like that. Finally, there's also one more very common and cool method that you can use. I mean, there are many more things, but obviously we're not going to dive into everything in extreme detail here for this, just enough that we can use all of the common things and that you can understand all the common things that you'll see. And one of those is this next keyword. So if we have our generator here, and let's make our file name proper here and rerun this. So one way of going over this is with a for loop. But something else that we can actually do is we can say line, and let's say we just want to read one line. That's all we want to do. So what we can do is we can say line, and then we're going to say next, and we're just going to get the next value from our generator. So then if we print out the line, we're just going to get one line. You can see here, hello. If we do this again, we create another line, then we're going to continue reading from our generator. And so we can see we're still going in the order that we would have previously, but instead, rather than going over it in a loop, for example, we can kind of here have more control over when exactly we're taking elements, and we can go one by one and kind of read these in one at a time, and in specific cases, rather than maybe iterating over a loop. Again, situational usage that mainly when you're writing it and you're like, oh, I want to do this right now. Oh, great, I can use the next keyword and generators for this. Perfect. Those are kind of the times when you'll think about it and you'll be like, yeah, this is a great time to use generators. All right, so now that we finished with our Python detour, we're going to come back to our API development. And we're going to essentially redo what we did just a couple lessons ago and go into a little bit more detail into, again, creating our API and interacting with it a little bit. Now, if you haven't heard the term API before, or you're not really sure, what this is all about, don't worry. Over the coming lessons and really throughout the rest of the course, we're going to be using it and diving into a lot more detail. And over that time, you're going to understand much more what we're exactly doing with APIs and, why we're using them. But essentially, you can think about it in a way that you can write some code, some sort of functionality, and then you can expose it for others to use. So you're basically making your code available to others in a very structured and formatted way. But again, as we kind of progress with the course, that will probably make more and more sense as you're kind of building it out yourself and you're really seeing what exactly all of this can do and what we can do with all of it. So yeah, let's go ahead and from FastAPI, we're going to import the FastAPI class. And we're going to create an instance of our FastAPI class by initializing it. And we're going to save that instance in a variable called app. And now we're going to create our first endpoint for this application. So we're going to define a function here, and let's call this our test endpoint, just because. And all that this endpoint is going to do is it's going to return, hello, this is a test. All right. Now to make this endpoint part of our application, we're going to use a decorator. We're going to go into our app, which contains an instance of the FastAPI. So we're going to use the app.get method, so the get method from the FastAPI class, and we're going to have our endpoint path be /test. And to run our application, we're going to use Uvicorn, which, checking our pip file, we still have installed. But if you don't have this installed, if you kind of uninstalled it while we were doing our virtual environment lessons, just make sure you go ahead and type pipenv install, and then you want Uvicorn, and then also FastAPI. Make sure you're doing that when you don't have your environment activated. So deactivated, pipenv install the packages, and then you can go back into your environment. All right. So let's go ahead and run this. We're going to go Uvicorn, and then we're going to tell it where our application is. So our application is in the main.py file. So I'm writing here main because our file here is called main.py, but I'm not writing the .py extension. So this is the location, and the application that we want to run is in this app variable here. Now I'm also going to use --, reload, because this is going to enable a testing feature essentially for us that as we're developing and we save, our application will restart. So that way we don't have to shut it down and restart it every time we want to make changes to the code, but rather we can code, and every time we hit save, it'll just reload it for us. And Uvicorn is really nice because it does all of the essentially the lightweight but really heavy lifting stuff for us, that it kind of spins everything up and just makes it interactable in like a web browser environment, for example, or just generally being able to accept HTTP requests and being able to properly route them and execute blocks of code in our application. So if we just hit enter here, we can see here it's telling us, all right, so this is where our Uvicorn is running, and it's running at the address http://127.0.0.1 on port 8000. So if I pull up my Chrome here, you can see I've already typed in the address once. If I just hit refresh here, then now our server is live, and we can use this, or we can also do localhost here on port 8000. Either of these are going to work. So right now we're getting detail not found, but that's because our endpoint here is implemented at /test. So let's go ahead and go to the /test endpoint, and there we go. This is the exact response that we're returning here. Now another really cool thing about FastAPI is we can go to this /docs page, and it actually auto-generates this for us. And this is going to create OpenAPI documentation for us, which as we'll progress, you can see will become extremely useful because it will show us every single one of our endpoints. And when we go into it, we can get more information about the input as well as output expected responses. And we can even test things out. Right now, we can click try out here. Right now, we can't send any data, but when we do get to the points where we can send data, we can even provide sample data here. We can hit execute, and we'll see the response. We'll see the response status code, header information about the response, the curl that was used to execute it, and yeah, just a lot of really useful stuff that makes it very nice for testing, as well as also for others. If they want to, inspect the API, they can just very easily go to the docs page and they can see the whole documentation. All right, so let's implement another endpoint. So we're going to go and implement, if we just go to this address here, that this is going to work. To do that, we're going to create a function. I'm going to call it home. The names of the functions here are not particularly important, obviously, except for that you want to make them descriptive enough as to the purpose that they're serving. But aside from that, I don't need to call this home for this to work. So to implement that address or that endpoint, we're going to do another get endpoint, and we're going to look at different endpoints later and what exactly each of these can be used for. But right now we're just going to use get, and we'll have just a / address here, and here we're going to return the string welcome. And you can see here, as I'm kind of typing and saving, the application is automatically shutting itself down and restarting itself. So I don't have to, take it down and restart it. But if you ever do want to take it down, you can just hit Control C, and that'll take it down for you. All right, so if I refresh this with now the endpoint implemented, we can see the response exactly like we have it here. And if we go to the docs page or to the docs endpoint, we can see here the documentation generated for us. Again, very, very useful. All right, so this is a pretty good start, but there's still a little bit of work even now that we can do. One of the things we'll notice when we go in here is it's telling us the response here is a JSON response, but that's actually not true. What we have here is just a plain text response, right? Like right now we're just returning text. And so maybe we want to make that a little bit more accurate. And if you don't know what a JSON response is, don't worry, we'll look at that in just a second. We're going to look at kind of two basic responses now, and we're going to start, like I mentioned, with a plain text response. Then we'll also look at a JSON response, and then later on in the following lessons, we're going to go into more detail about how we can properly define an input and an output schema going past these general definitions. But let's first start with the basics. So we're going to say from fastapi.responses, we're going to import a plain text or the plain text response class. And now to indicate that this is a plain text response rather than the default JSON response in this case, we're going to say the response class is equal to this plain text response class. And now if I refresh, we can see here the media type has changed to text/plain. And if I go to our test endpoint here, we can see the quotation marks around it have actually been removed because now it properly identifies this as a plain text response. If I take this away, we'll see they come back. And now they're gone again. And also testing it in our documentation page, trying it out, hitting execute, we can see again here the response that we have, as well as that it's just a plain text response. But in the case for our home, it's still an application/JSON response because here we haven't set it to a plain text response yet. So we can also do that real quick, copy this, and just put this over here. And we can just re-execute this, and there already everything is fixed for us. It's now a plain text response. Oh, I have to refresh that. There we go, plain text response. And also just going either to the / or just automatically getting redirected to the kind of hidden / page. We have our plain text response here. All right, so pretty good. That's the one thing, but generally you're not going to be returning plain text very often. Most of the time it's probably going to be something like JSON, and even there you're going to get into it's going to be a lot better if you really properly define what exactly is being returned and what exactly the input should be, because that obviously makes development a lot nicer, because people can look at the documentation, they know exactly what to put in, and they know exactly what they're going to get out in the sense of the information that they need to provide and the information that they're going to get out. But again, we'll look at that later. So we're going to now have a JSON response. And if you don't know what a JSON response is, don't worry about it. Essentially, the way that you can think about JSON is it's very similar to a Python dictionary. And we'll see that in a second. So let's just create some example values here. So we can see here we have some test key and then some value. And let's create a second key, another key, and here another value. And let's have an integer key with some more values and another integer key with some integer value. And we've changed our response class here to a JSON response. All right. I have a typo here somewhere. Oh yeah, this is supposed to be a comma. All right, now we're good. And oh, it's complaining that it can't find the definition for this because I'd removed the import. So I had made to make sure the import is still there. Previously I deleted it, but then this is no longer defined. So I want to make sure that import here is still there. And also with this, if you're a little bit confused about this structure here, don't worry. Also, this is something we'll get into in just a little bit as we'll learn about project layout and directories and paths and all that good stuff. So right now we're just kind of importing stuff from some sort of library, But as we go on, these things will also become a lot more clear. All right, so we've updated our test endpoint. So let's go ahead and go to /test, and we can see here, this is now the response that we get. So some interesting things to note, all of the keys have been converted to strings. And when we use a single quotation mark here, we instead have a double quotation mark. So JSON has a very particular kind of format that it has to abide to, but really the way that it looks and feels, and really the way that you can use it, is very, very similar to a Python dictionary. And so you can kind of just think about it in that way in your mind, although just being aware that the JSON formatting is in this particular way of having double quotes and having strings as your keys and those sorts of things. But aside from that, when you have JSON data, you can essentially treat it like a Python dictionary. And actually, if you're using it in Python, it will be loaded into a dictionary too. So yeah, very, very big similarities here. Now, if we go back to our documentation page by going to /docs, we can see here our media type has been updated to show that this is a JSON response. And if we try this out, we can also see here our formatted JSON response actually. We can see for every key the associated value for it. And we can definitely make this more complicated by having something like nested key sum internal key sum internal value. So there's definitely a nice, and I need to refresh this first, definitely a lot of flexibility with all of this. But again, here we're still not exactly sure if we were an outsider and we want to use this API. Until we try things out, we're not exactly sure what we're going to get, and even then we're not sure if it's consistent or if it's just for this particular case. But again, those are things that we'll look at later. So yeah, with this we've kind of looked at or have taken a second look at building out the kind of very, very basics of our application. Right now, there's almost no functionality attached to it except that we can go to two addresses that we've defined, and we can pull those addresses up, and we can get some sort of information from it. Currently, we don't know how to send data. Currently, we don't know how to properly have some sort of response model, but all of those things are things to come. And hopefully, after having covered the classes as well as the decorators, the things that we're doing here also make a little bit more sense. And probably as time goes on and as we continue to develop with them and we build up experience, they will become more and more intuitive and really make a lot more sense. But yeah, all of that stuff is still stuff to come. And with that, I'll see you in the next lesson. All right, so previously we've looked at the different response classes we can have, and we've already mentioned that we can more explicitly define this to have a output schema that we explicitly define what the outputs are going to be, as well as also an input schema too. Before we go onto that, we're going to take a quick detour and basically do some prerequisites for this, which is going to be taking a look at typing. Now, you may or may not have noticed that as we're writing our Python code, we don't really define the types of anything, right? So if I have a variable that I can call, my test val, and this could be, for example, 5. Later on, if I want to, I can set this to be some random string, right? And this can kind of go across a bunch of different things. And there isn't a real consistency here. It can be, essentially whatever we want. And obviously, this makes it pretty easy to, start programming, but sometimes when your projects get big, this can also cause some problems because, there isn't this strict checking. And you may be using integers in one place where you actually want to have strings, or vice versa, or you have a dictionary where you want to have a list, or, whatever. And so we're going to take a look at this typing, and we're going to see exactly how this can help us and what the principles behind this are. And we're going to also start regularly doing this for our things, because yeah, it's just going to be good practice to implement this. And really, Typing and type checking has helped me personally a lot because it really helps find a lot of issues that you may not have actually caught because you're putting in one input that is actually supposed to be in a different format and you may just not have realized it. And you will have only realized it when your Python code in that section actually gets executed, and by then it's probably too late because you want to stop it before you reach that point. So yeah, we're going to delete this, and we're going to actually create a new file here. I'm going to call this our typing test.py, and here we're just going to do some typing stuff. So the first thing we're going to do is we're just going to create some sort of function, and this can just be some general test function. And what our function here is going to do is it's going to, well, just print test for now. Very, very basic. And if we execute this and have it hovered over here, the interesting thing that you can actually see from our environment already is that there's this arrow here that, as we'll see in a second, already indicates to us if we actually get something back. Because in this case, the test function actually does not return anything. So if we execute it, Python typing test.py, we can see here we print out test, and obviously nothing gets returned. But what if instead this function returned test? So now if we execute it, nothing really is going to happen because we have some sort of value returned here from it, right? So in this case, we'd have to have, return value. We can save this in here. And then, for example, we can print out our return value. And again, if we hover over it with our mouse, our interpreter actually understands it. Look, it's showing to us, and we'll look at this arrow in a second, but what it's telling us here is this function actually returns a string. And if we hover over this, we can see here this value is a string. And, well, this is the same value, so we're already getting some indication of what value we can expect from here, which is really nice because rather than having to look up everything and understand, okay, what exactly is being returned from here, we can already just make a quick check when we're developing. Is the way that we're using it compatible? Like, are we getting what we expect to be getting? So if we run it now, obviously we get the same result. Now the interesting thing becomes when we have some sort of random undefined input variable here, a, and let's just keep it as simple as possible, and we just return the same thing. Now when we hover over our test function, we can see here obviously our interpreter doesn't, or our coding environment doesn't know what's going to be returned from it. And so the types that we see here are any. A can be anything, which is true, right? I could have in here the character A. I could have in here the integer 1. I could have in here the list containing the element integer 1, right? I can put in here anything, and I can get anything returned from it. Now, obviously, this kind of makes Python very easy to use, very powerful because it's so dynamic, or well, because it is a dynamic programming language. But this can also cause problems when things get really big because maybe I do want to treat these things a certain way, and maybe I want to know exactly what I'm getting returned from here, and I want to explicitly know, and I don't want this freedom to choose. I want things to be determined beforehand. And that's really where type hints and typing can, come to the rescue for us. So one thing that we can do to indicate the type of something is we can put a colon next to it, and then we can put the type that we want to have. So for example, in this case, we want to have an integer type. And so when we hover over this, we can already see that it takes as input an integer, and it actually returns our function here is simple enough, and our programming environment is actually smart enough to determine that we're also returning an integer here from it. So this is already pretty good. And from this, just hovering over it, we can probably see, okay, so what we're putting in here is probably not correct because it's expecting just an integer, but we're actually putting in here a list that contains an integer. But the thing is, if we run this, everything's going to be fine. This is just a hint for us, for the developers, but it's not actually strictly enforced by Python. But continuing on, and we'll look in a second about how this can help us or what we can do against it to basically type check our program so that we can at least guarantee that things are working as they should be when we have type hints for them. But we'll look at that in a second. Now we're also going to look at what values are being returned from it. So in this case, we have an integer returned. And again, the syntax that we're going to use for this is this arrow that we've seen several times now from this hover over feature. So we're going to have an integer returned from it. So we're taking in some variable a, which is an integer, and we're returning an integer from this function. Now again, our program is still going to work, but hovering over it, we have a clear description of what exactly goes in and what exactly goes out. And now in this case, our functions were very, very simple, and our our coding IDE here had a relatively easy time kind of trying to guess what exactly goes in and out. But as our functions become more complex, this no longer becomes the case. And most of the time, you'll just see the any annotation. So anything can go in, anything can come out. And type hints obviously can be very useful for that because it helps you understand, okay, in what format does my input need to be so that when I call this function with this input, it's actually going to work properly. All right, so we have our type annotation here for this. And let's just look at some other type annotations that we can do. So one thing that we've seen before, we can have some sort of test print where a, for example, let's have this be a string. And then our function is going to print a, and it's not going to return anything. And so the return type for this is going to be none. So if we have here test print, and we just put in here the string test string to print, hovering over this, we can see here our input type is the string a, and our return type here is none. Nothing is getting returned from this function, which is exactly true. Nothing is being returned from here. And if we took this away and replaced it by integer, for example, then we can see here our type hint here would be an integer. And for some coding environments, and PyCharm in this case does a great job with this, I think, we can see here it already kind of indicates to us where potential problems may be, and just hovering over this, it says it's expecting an integer, but we have provided a string here instead, which is just extremely useful when you're coding. You can very quickly find these sorts of issues where you may have made a mistake and correct it before it actually runs into this problem while the code is running. But changing this back to a string, we can run it and everything is fine. And even if we change this to an integer, it's still going to work. But at least it's helping us out as we're developing things. So these are kind of the basic types, and there are other ones that we can do too. So float is another one that we can see, or just having in a general list or a general dictionary type as input. All of these basic ones that we've seen before, or even just a tuple as input. So we can have in here, for example, turning this into a one tuple, and our typing here is now going to be correct because, well, it expects a tuple. So these are kind of the basic types that we've seen, but actually we can also get a little bit more specific because unfortunately, or fortunately, depending on your perspective, our types are not always going to be this basic, and they can get more complicated. And sometimes a specific type is not defined. So for example, let's take our test function here, and let's say we want to do some sort of division, and we have a as our integer. And we're going to have in here a second value b, which is going to be another integer. And so what this function is going to do is it's going to just divide a by b. But we have to be careful because if b is 0, this is going to give us an error. So what we can say is if b is not equal to 0, then we're going to return a divided by b. However, if it is equal to 0, we can either do an else, but we actually don't need it because this is our only statement that we're checking. And so if this doesn't, pass, then we will automatically go to here. If it's not equal to 0, then maybe in this case we just don't want to return anything. Rather than returning, 1 or 0, maybe we just want to return none. So we can either have an empty return statement, or we can explicitly say return none, or we can even leave it like this. All of these will be fine. So now we can return two things. We can return a floating point number, which is what we'll get from here, or we can return a none value. But currently we can't, we have to choose. So how can we do that? Well, we can use the union. We can say from typing, which is a standard Python package, we can import union. And now we're going to say we're going to return either an integer or the none value. And sorry, it's actually a float value or the none value. And if we have our division here, we'll say 1 and 2, and we can also try this with 1 and 0, and we run this, then, for our typing hinting case, things are going to work properly. And an interesting thing is you can see here we're kind of unifying the types, and this mainly works well if, for example, instead of here returning a none value, we would have just returned 1, because in this case we'd be returning either a float or an integer. But the interesting thing about none is there's a specific way that we can also provide syntax for this, rather than using the union like we did here, and we could already see it with the type hints. There's actually a specific keyword, optional. So we can import that from typing, and we can say we're going to return an optional value that is of type float, which means if it is a value, it will be of type float. But if it's not, then it's going to be none. So we optionally return this value. And that's kind of the same syntax that was already hinted to us, or even actually corrected for us when we use this union. So in this case, we're either returning a float by this float division, or we're returning none. So we have an optional response here, an optional value, which is of type float, but the optional means it can also be none. And again, this is pretty useful for our type checking, because we know now we can actually get a none value returned from this, and we need to be prepared to deal with this accordingly if it does ever happen. Similarly, maybe we want to have an optional input. So we want to say we want to provide A and B, but B is optional. So in this case, we need to check, or we need to have a separate check. If B is none, maybe we want to just return A. And if B is not equal 0, then we want to return A divided by B, and otherwise we're going to return none. So now we have an even more complicated return type. Basically, we can return an integer, or float, or none. So now we can use our union again, and we can say we're going to return an integer, or an optional value, which would be a float. So either of these two, and we're defining this with this union clause here. So either of these values are a return value, and this one here could even mean that, it's optional. So yeah, there's a lot of intricate typing that we can do with this, and yeah, I was already thinking the syntax here looks a little bit weird, and we can see our program environment has again kind of corrected us to the proper syntax, because really either of these could be optional. And rather than wrapping optional around both of these, in this case we can actually explicitly say we're going to return either an integer, a float, or the none value, rather than saying we're optionally going to return an integer, or we're optionally going to return a floating point value, because now we're repeating ourselves. This just becomes a lot easier to read. All right. Other types that we may want to use. So we've seen the dictionary before, but maybe we have some here, something like test unpack. And here we're going to take some sort of input val, and this is going to be a dictionary. And from here, we want to return maybe an integer. And we know that our dictionary has the format of keys being strings and values being integers. So maybe we want to have some dict key, and maybe this is just the key from the dictionary that we want to select. Not a very great function, but nevertheless, we can still have it. So we're going to have our input value here. We're going to select the dictionary key from it, and this is what we're going to return. So if we take this away, we have our test unpack here, and we have some input such as val1 is 1, and the dict key that we want to use is val1. So hovering over, we can see, okay, we have an input dictionary, the dictionary key that we want to take here, which is what the variable is called as a type string, and we're returning an integer, exactly the types that we have defined for it. But we can actually be more explicit about this. If we know that this dictionary needs to have a certain structure, then we can define this further by using this square parentheses and saying the keys are going to be strings and the output values, or sorry, the keys are strings and the values are integers. So now we're even more explicit about our input. So we're going to provide a dictionary as input where the keys are strings and the values are integers. And in that way, again, as we're developing, we know the proper format that we should use for all of this. And we can do similar things if, well, we can run this and we're not even printing this out, but we can say here, return val, and obviously we can print this out too. And then quickly going through some of the other types that we can have. So we've seen the list before, but maybe, it's going to be a list of strings. And here we want to have some index, which is going to be an integer. And we're going to return a string because we're going to take this index position from this one here. So let me just update this. So in this case, we're just going to return the 0th element from our list here. So the first element is the one with index 0. And again, we have proper type hints. We're getting in here a list of strings. Our index is an integer, and we're returning a string from this, which again just makes it nice and readable, both over here when you're developing it, as well as also when you're using it. And we can also return a tuple. In this case, we can import tuple from typing, and maybe we want to return both the value as well as the index like such. And so we can create a tuple, and it's going to return a tuple of string and integer. And we can run this, and we can see here we have a tuple returned that is both a string and an integer. So yeah, properly defining for us, that a tuple has a specific size and as well as the type of each element in there. So yeah, a lot of good stuff that will become useful as your code base grows because, again, you can mitigate a lot of errors by just running type checks. And now there are also other types that we haven't seen yet. One of the other ones that I think is pretty important or can become pretty important is the callable, which allows you to annotate functions. So if you have a function as an input, then you can use a callable for that. And yeah, I think those are going to probably be the basic ones that are going to take you kind of the furthest. That being said, if there are any other types that you're like, what kind of type can I use for this? You can always also do a quick Google search or something. How do I type annotate this? Or if everyone else is using type checking too, you can hover over the return type. You can see what is being returned from it, and then you can use that return type. So in this case, for example, I know that a tuple is being returned from it, and the tuple has the first element being a string, and the second element being an integer. And so I know, in this case, oh, okay, well, that's the type that I have available, so I can continue using that for it. And I think something I actually also just noticed from the type in, we can even use the lowercase tuple here. I think it was before Python, I think 3.8 or something, that we had to use purely the uppercase ones. It may have been before that too, but at some point also being able to use these ones has just become a compatible option. All right, finally, before we end this lesson that has gotten relatively long, we're going to install one more thing that's going to help us with type checking. So I'm just going to deactivate my environment. I'm going to do pipenv install mypy, and mypy is something that we can run which will do type checking for us, and we'll kind of continue using this just very, very basic right now, but as we continue to grow our code repository code repository here, we will expand the functionality to make sure that we're doing the proper type checking that we want to do. So yeah, I'll just let this install real quick here. And now that it's done, I'm going to go back. Oop, not sure what that's about. Going to go back into our virtual environment. And we're going to say mypy, and we're going to give our target file here. So we're going to run type checking on this file. We're going to hit enter, and it's going to do the type checking for us. And we can actually see here, it's already giving us some errors for certain things. So let's take a look. Going here, return value expected. So it's expecting us to put something here. This should fix that. And here we have incompatible types in assignment. In this case, it's actually telling us, because we've been reusing our return value here, which can take on many different values now, right? So from our division here, it can actually take on these values. So maybe we can take a second return value. It's actually kind of indicating to us that this value was previously used with this type. And now we're overriding it with a new type, which is an extremely useful thing to know that may never bother you, but maybe it will, and maybe it will break your code. So important things to know that, as we're like developing, you may not even think about, and then, these things are pointed out to you. So let's run our type checking again. Yeah, bam, there we go. We fixed all these issues, and now our type checking has passed, which is, of course, extremely nice, and also, again, can give us just a little bit of, like safety, and just make us feel, a little bit more comfortable, because we just have, some more assurance that at least the way that we're passing variables around, the way that we're using this information should become consistent, or should be proper, as long as we did our typing properly. And here it keeps complaining about this, so I'll remove this. We don't actually need the parentheses around here for the return. If we return multiple values, it will automatically return it as a tuple. So we can remove this, we can rerun our typing, everything will be fine. And we can also just re-execute our script here, and again, everything will work as proper. Oh, except we should probably print this out now so that we get the new updated value. And yeah, there we go. So this is the basics of typing, and we'll continue to use typing and the rest of our projects, adding type annotation for everything, just so that any silly issues that we could run into because we're using one variable that has one type and then overwriting it into a different type, and then later on that could cause an issue somewhere, or we're putting in or returning the wrong values. All of those are issues that we don't want to run into. The one thing I do want to mention, though, is if we don't do any typing in our declarations here. So in this case, our functions are statically typed because we started giving definitions. But if we have some untyped function, which just takes some input A and returns, I don't know, also A, then in this case, it's actually not going to care about the type checking for us. So it's not going to have any issues for this. And this is something that, although in this case, it's obviously very simple, but just being aware that with the current configuration of MyPy, there isn't going to be any type checking that's going to be done on this function here, just because it has no typing associated to it. And there are things that we can change, and there are things that we will change down the line just to make our type checking very rigorous. But just as a quick side note, something to be aware of for that. All right, so coming back to our API here, we're now going to use the knowledge of typing that we have, and we're going to update our responses here to be a little bit more descriptive. So the first thing I'm going to do is I'm going to deactivate our virtual environment. I'm going to pipenv install pydantic. We're going to let that installation run. Now pydantic is going to be really nice because we're, as you can see in a second, going to be able to create certain base classes that we can use where type validation is actually performed for us, and so that way when we're moving data around, we are actually sure that the types of the data are correct. So I'm going to go into our virtual environment again, and we can also check our pip file here. We now have pydantic included here. And now what I'm going to do is I'm going to say from pydantic, we're going to import base model. And what I'm going to do now is, and I'm going to update the functionality of this here just a little bit so that we actually have something interesting. But what we want to do is we want to return some sort of information from some user. So for example, what we want to do is have something like this, user/me maybe, and this will just return the information about the user themselves. Now obviously this will only properly work if we're actually already authenticated so that the server knows who we are, but we're just going to ignore all of that for now because we're going to get also two parameters here in the next lessons. So we're just going to keep this simple and keep it like that. And what we want to do is, just to have it a little bit cleaner, we're going to have some general function that is get user info, and we're just going to leave this empty for now. And essentially what we want to return from here is a username probably, and we can just do with a short description right now. So we're just going to hard code these values. So we're going to have a username that's going to be test user, and we have like a short description. Maybe this is something you'll see on their bio or something, my bio description, like this. And from here we can then return the username and the short description. Obviously we can update our return parameters if we want to, but for now we'll just keep it like this, and we're also going to add proper typing into our function here. All right, so a pretty simple function, just essentially returns fixed parameters, but in this way, we can update our function, reuse it. We could change the implementation logic here to, for example, get data from a database, and probably have to add some sort of ID here, but really we just have some sort of, whatever the functionality may be, that's kind of the concern of this, and we can just use this function. Right now we're just going to keep it like this, but obviously as time goes on, we're going to make this more integrated with databases. But obviously we need to start with something simple first. So we're going to get from here the username and the short description like this. And now what we want to do is we want to have some sort of return where we have some format like this, the username, and then whatever the name may be here, and then the short description or something like that, and then whatever description maybe here. So something like this, right? But we want to be able to see this sort of annotation because we're always going to return this. And so the consumers of our API here should be able to see this sort of configuration, or that this is the data that we're going to return. So what we're going to do is we're going to create a new class, and we'll call this user, or we can just call it user for now. It's going to call it user info, but we can just stick with user, and as time goes on, maybe we need to change our names. And this class is going to inherit from base model. And then what we're going to do is we're going to define the attributes that we want. So for example, we want a username, and this is going to be a string. And let's say we want a short description, and this is also going to be a string. I just need to check here if there's a description. It looks spelled properly, so just to make sure we hopefully don't have any typos. We can also take these responses away because we're no longer going to be needing them, so we can remove these imports. All right, so now we have this class here defined, and now we can update our response class here instead to a response model, and we can reference this class. And we'll see the effects of this in a second. And then what we're going to do is we're going to create our user, and we're going to initialize our user with the parameters here. So we're going to have our username attribute be equal to the username variable we defined here. If these spellings are different, this is how it would look. So this here references the attribute inside, and this here is the variable we're using for initialization. But just keep them consistent, and we're going to have our short description equal to the short description like this, and then we're just going to return this user class. And now let's just go ahead and spin up our service and take a look at this, and then we're going to re-look at what we just did here to understand, the effects of each of these and how this relates to how our output has changed. So we're going to go ahead and say Uvicorn, and we're going to go into our main app, and we're going to do -- reload so that we can make changes. And start this up and opening this up here. All right, so obviously nothing found here, but when you go to /user/me, which is the path or the endpoint that we've implemented here, hit enter. So now we get this response here, which is again a JSON response, but if we look at the documentation, we now get something very cool. So going to this endpoint, we can now see that from here we're going to get a username returned as well as a short description. So this is the information about the responses already included for us, which is pretty cool because previously when we just had some sort of JSON response, all we could, figure out here is that we have some sort of JSON that gets returned, but we don't know what. But now we know exactly what fields as well as what types they are. So in this case, we have a username and we have a short description. And we'll see in a second, we can update this. So for example, let's update this to also include something like liked posts. I probably won't do it like this, but just to show. And we're going to return here a list of integers. And we'll see later why it's going to be integers, but primarily it's just going to be, we always want to reference IDs because IDs, numerical IDs, are much easier to keep consistent and to reference than having sort of string names, because names can change. There may be weird characters in names or other sorts of like anomalies that can occur in strings. And so integers is always going to be cleaner for us to use, plus they take up less space. But we're also going to touch on these subjects later on again. So for now, we're just going to have the liked posts, which is going to be a list of integers. And now we're going to include here like posts, and I'm just going to leave this empty for now. We're going to return it like this, and then we're going to also add this to our class initialization. Since our application is using the reload setting, we don't need to start and stop. We can just hit refresh here, and we're going to see already the information, or the schema here has been updated for us. And now we can try it out too, and we can see this is the response that we get, obviously because we've hard-coded the values here. But the really nice thing is for others who are using this endpoint, they can just look at the response model, they know exactly what they're going to get, which is very, very cool and very useful because now there's no longer guessing, but you know exactly what's coming out of here. And we can actually even see here the user schema is created for us. So, you can get more information into specifically, what the schema contains. But we can actually see like a sample output essentially here. So this is a good start, but we probably still want to make some changes. So first of all, maybe we don't always want to include a liked post. Maybe we optionally want to include this. So like we've seen previously, we can actually use this optional parameter here. We just need to say from typing import optional. And in this way, we now have this optional liked posts that we can include. And by default, this is going to take on the none value. So that way, if we don't include it in our initialization here, and, oh, I did. Let's restart that. I think it crashed because I started using optional before it was imported, and so it threw some sort of error. So yeah, restarting that, refreshing our documentation, and now we can try it out. We can see here when we hit execute, we're actually going to get a null value now, obviously because we're not passing this parameter. And if we look at our response schema here, we can see that this parameter is no longer required, but instead it is optional. Cool. All right, so pretty good so far. There are some other changes that I think we should be making. So first of all, rather than defining our user out here, it would probably be better if we just update our function here instead to return the user to us directly. So that way, we just know that we're going to get the user from here. Oops, we want to return the class, not the variable. And we don't have to worry about some sort of conversion out here, because whenever anything changes in here, we want to update it essentially closer to the source and not make it higher and higher and higher, because if we need to reuse this, then we need to essentially update this everywhere, right? If we're returning what we returned previously and we use this in several locations, then we need to go to those several locations and always update the way we're initializing, versus if we just return the proper model that we want from here, which is this user object, then essentially we need to do less updates, which less updates means less mistakes. So what I'm going to do is I'm just going to return the initialized class, because we don't even need a variable for this. And I'm also going to update this a little bit. I'm just going to create a content dictionary, or I'm going to call the variable content, and it's going to be a dictionary that contains these values like this. So I'm just putting all of this in a dictionary. The variable name is going to be the key, and the value here is going to be the value. And also, well, we'll leave our like post out for now. And so what I'm going to do here is we're going to use this dictionary unpacking star star that we've seen previously, and we're just going to, pass the contents of our dictionary here. And let me just format this properly here real quick. We're going to pass the contents of our dictionary using this key value structure that we've seen a couple lessons ago now. And in this way, whenever our response here updates, we don't need to add any extra initialization parameters here. Whatever in this case is in our dictionary is just going to be passed into our user object and initialized for us. So this is just making this a little bit cleaner. And now obviously we can change this to be like this. So we're getting the user object returned from here, which we can also see hovering over. Yeah, we get the user object returned, and we're storing it in the user variable, and we are now returning this. So uploading or starting this one more time, because it probably crashed when I was making some changes, hitting refresh, everything should be the same, hopefully. And yeah, it looks like that. Now, some other changes that we can do, or something that I want to show you, is if we don't have this optional parameter around here. Now I want to get a little bit into what we did here, because we kind of skipped over this, although I hope you're already able to appreciate the effect that this has by seeing the response schema, as well as an example value of how this can look like when it's returned, obviously making this a lot more clear, but also to show you now the typing component of this, if, for example, this parameter is not optional. So now let's go ahead and refresh. We can see in our schema this parameter is now required. Trying this out, we can see now we have an internal server error. So something went wrong. We have a 500 response, and we'll also get into response codes a little bit later, but essentially it didn't work. Why? Let's go ahead and take a look at our logs. And we can see here there was one validation error for user when we tried to initialize it. And it will tell us here, okay, this error came from here, so line 20 and get user info. We can actually click on this. It will take us to the direct line. This is where the problem occurred. And looking at this, we can now know, and looking at the error message below, okay, so there was the liked posts field required and the value was missing. So we didn't include the liked posts. And even if we try to set this to none, and refreshing this again, refreshing this, let's try it out. We're still going to get an error because our field does not accept optional values here. It has to be some sort of value. If we add optional here, even without setting a default value and refresh, we could technically already hit execute. But if we hit refresh, the whole documentation generation is obviously updated for us. If we hit execute, we can see now it's working. Because now we, again, accept optional values, so we accept null values. But in those cases, it's probably good to set some sort of default like this. We can also set defaults for non-optional. For example, the short description here can be test short description. And that way, if we don't provide the short description in here and only the username, for example, and if we just hit execute here, we can see it's still going to succeed because we have a default value provided for here. Even though we didn't provide it, we still have a default value provided here. The only thing that the optional does here is allows it to be none. Now let's also take a look at some other typing things here. So we've set this to be a string, our short description as well as our username. Because we have the optional and the default value here, we no longer need to provide this data. So let's now try to provide an integer here for a username. So if we hit execute, we can see in our response that our value is actually updated directly to a string. Now this works because a string is essentially extremely general, and it's easy to convert a integer to a string because we can just, put quotation marks around it essentially. But let's see what happens when we do this the other way around. Let's have our liked posts, and let's first return something proper here. Pressing a bunch of buttons that are pulling up weird things. So let's first just return a list with the element 1, and here we're going to return our standard username. Hitting execute on here again. Okay, so this is our response, right? The list contains the element 1. Now, if we instead include in here the post title, so whatever title that may be, this is gonna be a great post. We require this to be a list of integers. So let's try this again. Now we're failing. And that's because this cannot be converted to an integer. So you can see here, the value is not a valid integer that we're passing in here. So previously when we had the numerical value here, we were able to convert it to a string because this obviously gives us the string 1. But this here, we're not able to convert to an integer, and so we have a type validation error here. And so that's what we were able to see. I broke our application again, so it crashed, but that's what we were able to see here. The like post value, so again, we're getting a validation error. We can see where it happened. It happened here. Getting some more information. There's a validation error for the user class, the like posts object. The value is not a valid integer. So essentially exactly the problem we were trying to produce, the value that we're passing here is not a valid integer. So the cool thing here is that unlike the type annotation that we have here, which doesn't necessarily need to be abided by our program, the pedantic models that we create here do actually conform to these types, which means it's really nice because if there ever is a mistake, then we're going to catch that, and our program is actually going to return some sort of invalid response when we try to return, for example, a post title here because there was some sort of mistake in the implementation somewhere. So rather than just returning this and the downstream application then has to deal with the problem, our application is essentially going to fail, which we can see is going to return a 500 response, and it's going to just say that generally there was something went wrong in the server internally. And we can see the actual response, the actual error here, but we know what happened is that we try to pass a string value into a field that should take on integer values like this. So in that way, if we make mistakes, our pedantic models in essence, they help us protect and ensure that the values that we are returning are of the proper types, which is a very, very, very nice thing to have because it's an extra layer of protection. And essentially, if something breaks, it doesn't get just continue to go through everything, but rather it stops, where the breaking point or where the error occurred. So, yeah. Now, one more thing I want to show you, because we can take this even further, is let's say we have some profile info class, which also inherits from base model. And in here we have the short description, which is going to be a string, and we have the long bio, which is also going to be a string. And really what we want is our user has some sort of username, it has their liked posts, and then it has profile information. So what we can do, rather than just referencing the kind of default types, is we can actually reference different pydantic models here, like this. And so we can say, oh, okay, so our profile info that we're going to return here is actually going to be of the type profile info, like this. And that itself contains the short description and the long bio. And so what we'll have to do here is create some sort of profile info like this. And this is going to initialize this profile info class. We're going to have some short description. Maybe we'll create a separate dictionary object for this, profile info. And it's going to be a short description, bio, long bio. We want the names here to match so that we can use this dictionary unpacking. This is our longer bio. We're going to initialize our profile info with this, and then we're going to create the user content, updating the name now to be more specific, is going to have the username, the like posts, as well as the profile info that we've initialized here for the class. So restarting this, let's take a look at how our response here changed, refreshing our documentation to now have the new schema generated. We can see here we have our profile info, which is a nested structure, which essentially contains more information. We have our liked objects, which is a list of integers, or username, which is just a pure string. We can also see this here. And we also have a new object created for us. So we can definitely make more complicated schemas like this. And if we hit try it out, if we did everything properly, oh, no, did not. Let's see what happened. Oh yeah, this error again. Well, let's fix this. And our username, let's make this something better. Refresh, try it out, execute. So there we go. We have our username, and we have the profile info, which itself contains more information, and the like posts component, which again also itself contains more information. So we're able to use Pydantic and essentially reference other like Pydantic classes in this case, for example, and just make all of this a little bit nicer, and really be able to provide a really nice, large, if we want to, and a properly structured response schema. And again, the really cool thing that we have all of this is, one, all of our types are enforced. So if it says here that we're returning a string, then we're actually going to return a string here. And if type conversion can be done, then it will be done. And if it can't be done, like we've seen previously for the like posts, then rather than returning something that doesn't conform to our schema, instead we're going to break. And so that obviously is nice because then these errors don't get passed further down our system. But we can tie this back to something here broke, and we can take a look at why it broke and hopefully fix the problem. And with this, I hope you can see that using this sort of response model is a lot nicer than just having a general text or JSON response, because now if I were to send this documentation page to someone else, they could look at it and they could see, oh, okay, I know exactly what information I'm going to get from here. Versus if you just told them you're going to get some JSON response, they're like, okay, what are the field names? What is the structure? What are all the values? I can get, and they're essentially going to try to get this information from you so that they can properly use the values that they're going to get. And then you also need to make sure that all of this information is always contained so that a user of your API who wants to use the username, for example, if you forget to include the username, then their thing might break because it assumes it's there, whereas in fact it's not. But using these schemas gives a lot more transparency, and it will also ensure that the schema that we have, so the responses that we're providing, are always going to be consistent, and they're going to be abiding by the schema that we're providing here as output. So we've seen some stuff about creating our response models, but there's actually some more cool stuff that I want to show you now that, situationally you may encounter and find useful. So essentially, we're going to look at how we can expand some of the properties of each of our fields and how we can make those more specific, maybe adding in extra constraints or components like that. And the way that we're going to do that is from Pydantic, we're also going to import this field class here. And so what I'm going to do now is I'm going to take our username variable, and instead what we're going to do is we're going to rename it so that in our output, for example, we will see the name component, or rather this username here will actually be called a name instead of username. And we'll also look at how we can set some default values, enforce kind of like a minimum length, and yeah, just kind of see some extra properties that we can set on, in this case, a field by field basis. So you can see as I already use this field parameter, there's a ton of initialization options here, and just by the name, you can probably already guess what most of them will do. But let's take a look at how we can use this. So what we're going to do here is we're going to assign our value here to this field class. The first thing I'm going to start with is setting an alias. So I'm going to set our alias here to be name. So this means that although internally this field here is called username, everywhere else I'm going to be referring to it and it's going to be seen as name. And we'll see what effect that has in a second. And then I'm also going to add a title here, and we'll see what the title does when we look at our output schema. But here we're going to have the username. Just, I don't know, something like this. We can also add in a description. This is the username of the user. And we can also add in some constraints. For example, maybe we want to ensure that the username is not an empty string. And rather than having to have some sort of extra validation check somewhere, we can add this parameter here called min length, and here we can put 1. So that means it has to be at least 1 character long to be able to set this. And if we want to, we can also set a maximum length. So for example, if there's some sort of maximum defined in maybe our database, and we can say, okay, our username can be between like 1 and 20 characters or something like that, we can also define that here. So for example, we could put in here a 20 like this. And now to make this work, I have to update this reference here because currently we're calling this username, but because we've given it an alias, this property is now actually called name. And we'll see in a second the reflection of this in our output. So I'm going to refresh here, and I'm going to look at our schema, and now we can see several things. So first of all, we can see here, our output field is now called name, whereas before it was called username. We can also see in our response example, we now see name instead of the username that we'd seen previously. In addition, we have our title here. So this title here matches the title that we've defined here. We have a minimum and a maximum length for this, and here we can also see the description. So this can be nice because you're essentially just adding to your schema and making it more usable if there are some questions around it. And then these are parameters that will actually be enforced, and we can see that in a second. So with everything like this, let's go ahead and try to execute that, and we can see we get a proper response as expected. But now let's try to set this to something like this, just empty. And if we re-execute this, now we're going to get an error. And if we look at it, we can see here that this value needs to have at least 1 character, because we have here a constraint that we've added to our username field here. And similarly, if we take this away and make this longer, for example, by multiplying the string by 5, so we're repeating it 5 times, this will likely be over 20 characters in length. And so let's retry that. We're going to get a eternal server error again, but this time we can see that the error is ensure this value has at most 20 characters. So you can see there's actually some really nice validation built in for us using this field. And then obviously we can also set, looking at this, for example, a default value. So we can set here the default, for example, to be either user if we'd like to. So that way if it's not provided, like this, we'll still have the default value. So we can refresh this. We can see here the default is provided. Or we could also set a default to none, for example, which will just essentially make this an optional field. And we can see here default is none. And in this case, actually, just kind of coming back to our like posts, because we use the optional here, since we set the default to none, this kind of inherently becomes an optional field. So this is actually no longer required. And this will still work. And even if we don't provide this information, this will still work. It's just when we don't provide a default value, but we want to allow null values or none values like this, that we need to wrap the optional around it. Just as like a kind of quick side note, since we're since we're on the topic. All right, so yeah, this is pretty useful, and we can do similar things for other components. For example, if we look at our like posts, maybe we update it like this, and also set it here. So we're not going to set an alias, which means we're going to leave it as is. And here we're going to add a description, which is going to be array of post IDs the user liked, and we're going to set the minimum number of items that we want to have here to, I don't know, we can also try 1 here and see, or we can do it to 2 because we're providing 1 here, so we can just see it fail. And we can also set the maximum number of items that we want to provide here to something like 10. And just seeing this in action, now we should fail, yeah, because we're only providing 1 value. We can see it needs to have at least 2 items. And similarly, if we make this array or this list longer than the maximum number of items allowed, which is 10, so this is going to be 11. So just repeating this 11 times, executing this, we can see here now we are going over the maximum number of allowed items. And then, we can do similar things like setting on an alias or description if we want to, title if we want to. We can see here if we didn't set the alias, and if we do this proper, we can see here the output name that we get is still the exact same one that we've defined here. It's only when we define an alias that the way that we're referring to it actually has to change. And if we don't define an alias, then it doesn't have to change, and it's just going to stay to be exactly what it is. So yeah, there's a lot of cool stuff that we can do with our pydantic models here to really make them enforce certain components. So yeah, this way, again, we really just want to make sure that the data that we're giving out is of proper format and that we're not giving out any bad values that somehow manage to slip through. And so because of that, it's very important to just make sure when you do have some sort of constraints or something, if they can be part of the actual like pydantic constraints here, that obviously makes your job a lot easier because pydantic will take care of the validation for you, and you don't have to implement all of these extra checks. As long as you're implementing them in here, in these cases, for example, then all of that will be taken care of for you, and you can feel good that at least all of the constraints that you've provided here and the schema that you have will be consistent for the end user of that. Now, one other thing that I also wanted to show you is on the topic of inheritance that we looked at previously. Right now we have this profile info that we've defined as a separate field here. And again, just taking a look at our output, I think I didn't change anything. Yeah, so this should still work. We can see here the profile info kind of contains its own little dictionary of values here, but sometimes we don't want this. Like sometimes you'll actually come across situations where you have some components, defined that are separate, and you maybe want to use a smaller class. For example, we just want to have like the short description, the long bio for whatever reason. And actually, this probably makes more sense if we flip it around, and we have the full user profile like this, which also includes the short description and the long bio. And then we have the user, which will just be, for example, the username and the like posts. And so maybe this is something that will be like a quick overview, but then if you actually go through to the user profile, you want to see the username and the like posts, as well as now also the short description and the long bio. And the way that we can do that is using our class inheritance, and I need to move this down because of the order that we're defining our classes in. So yeah, because of the class inheritance, you'll see in a second, we can now add these fields rather than having them nested like we have here when we set the profile info as like a separate entity in here and set it equal to the profile info class, base model class that we've defined here. We can instead use inheritance to get all of those additional properties. So now obviously we have to change some stuff around here. And let's see, so we have the user content. This needs to get initialized first. And then we have the user like this. And then we have the full user profile, which is going to inherit from the profile info. And we also need to unpack in here our user. So right now our user is a pydantic model, so we need to convert it to JSON. So I think the way that I'm going to go about this is probably to create a new variable. So it's going to be our full user profile. This is going to be a dictionary, which is going to be initialized by the parameters of the profile info. So we're going to unpack that. And now we also in here want to put our user. So we want to unpack the username and the like posts. So I'm going to take this, but this is actually a user object, so we need to convert it to a dictionary or a JSON format. So we can do that using either the dict or JSON. I'm going to use dict for this to convert it to a dictionary, and then I'm also going to unpack it, and then I'm going to provide this as input using the keys and values. And just to show you, and obviously I would encourage you also, if you're not exactly sure what is going on here, to print out the different steps to see like the steps that we're taking and what each partial result looks like, and what we're actually providing as input and what we're also getting here as output. And now we'll look at the printout in a second. Now we can return, oops, we actually want to return this, the initialized full user profile, and we also need to update this because now we're no longer returning the user, but we're returning a full user profile. And our response model also needs to be updated because we're returning the full user profile here, not just the user. And here we should probably update our name, just, because it's technically not the user, it's the full user profile, so we want to just update our name here too, even though obviously this will still work with the previous one, but now we're more descriptive. All right, so starting our server again. Oh, it's complaining about something here. Let's take a look at that. Actually, I can take this out because our user already has the base model as a parent, so we actually don't need it in the initialization here anymore. So let's try that one more time. There we go. Refreshing our documentation to get like the updated schema, and now we can see here everything is on the same level. We can see here there's no more nested components, and try it out, execute, and here we can see our sample output, which is now no longer nested but has actually everything on the same level, which we were able to achieve by inheriting our full user profile from the user. And so we get all these extra properties that are contained in here, also included in here, in addition to the ones that we're defining here. So the stuff that we learned about class inheritance still holds here, and we can see that we're able to make really nice use of it, because sometimes you have some small components that you want to use by itself, but when you have different responses that maybe want to include different amounts of information, or you have different processes that need to use different amounts of information, you can then essentially use inherited classes from your base classes, and that way, again, we're talking about consistency and not really repeating ourselves. And so if a change occurs somewhere, it only occurs in one place, and we don't accidentally miss updates because we have to update things in multiple locations, and everything should be controlled in one place and should be reflected everywhere, which just makes it so much cleaner, and there's less chance for error just because you're forgetting that a thing is actually defined in multiple places and you need to make sure to update it in multiple places. So one more thing I want to show you here is how we can actually set model-wide configurations. So imagine we have 10 different fields here, and 8 of them are strings, and we want all of them to have a maximum length of 20 characters. Rather than copying and creating this field everywhere and setting the max length to 20, or even having a separate max length variable and just, setting that using something like str max, oops, something like this, so that, if we ever want to change it, it's all reproducible. Rather than like using something like this and then having this across, like 10 different fields and just initializing the field with just this value, and let's just make sure that this is all working properly. But yeah, rather than doing something like that, what is going to be much nicer is defining this configuration across the whole model, across our whole class here. So what we can do instead is, if we, inside of our Pydantic class here, if we define class config like this, we can actually set model-wide configurations. Now the vocabulary that we're going to use here, the parameter names are going to be slightly different than what we see here in the field property, but essentially, for example, if we want to set the maximum length of strings, then what we would use is max any str length like this, and if we want the maximum length for any string in our model to be 20, then we can set the configuration like this, and we can see if we run it now, refreshing here, we're actually not going to see it in the schema if we take a look here, which obviously isn't super nice, and so that's one of the advantages of maybe doing that on a field level. But we'll see if we try it out, we're still going to have this validation, because now in this case our long bio is too long. It has more than 20 characters. And so because we have this configuration defined across the whole model, then everything is going to be affected by this. So this has obviously its pros and its cons, but it can be very useful, just to kind of avoid some other unnecessary repetition. Just to, again, save a little bit of space so that you don't have to make many changes in many places, even if you have one field value. Just having to like copy paste that across, like 8 different string fields in itself can already be not super nice because you're repeating the same things. Now, obviously, the names here are a little bit different, so the way that you can probably go, if you ever need to deal with something like this, the best way to probably go about this is just to do a quick Google Python Pydantic set. Maybe if you want to do the minimum length, you would Google Python Pydantic set minimum length of any string in config, and then if you do a quick Google, you'll probably just the first link will give you exactly what parameter you need to set here, or if you want to set other configurations, then that will probably be the easiest way. But later on, towards later in this course, we'll also look at how we can read documentation, and so then you can also look up the documentation to see, okay, what parameters can I actually set? For example, in this case, in the config class, which ones can I overwrite to have model-wide configurations here? I'm going to take this out again for now, though, and just have it the way that we had it before. Oops. But just as kind of like an informational thing, that all these things are still available to us. I'm also going to remove this import because we're no longer using it. And something I also noticed here, we actually printed this out, but we never took a look at the output. So let's execute this. And now we can see here, if we just go back to our environment in our terminal, we can see here the output. And if you ever miss it, this output gets too long, you can always scroll back up to, catch any output that you may have missed. But also this I'm going to remove because I don't just want to be printing a bunch of things, because that will be spamming our console here, and we'll just unnecessarily provide spam in the output that we're seeing here, which if we're looking for other things may make it harder to find the error messages or whatever else we're looking for. So we've spent essentially all of our time now talking about retrieving data, which we've done using this get endpoint that we've created. However, obviously, there are probably different functionalities that we want because, I mean, generally also thinking about how you use the internet, it's not just retrieving data, but sometimes you also want to send data or update data or remove data. So generally you want to be able to create, read, update, delete, those sorts of things, which you'll generally also see abbreviated as CRUD for create, read, update, and delete. And yeah, now we're going to expand away from the reading, which is what we have here. And we're also going to take a look at those other components. And with that, we're also going to learn how we can actually accept variable input parameters inside of our endpoints here, inside of our URLs. So yeah, let's go ahead and first just start with accepting variable inputs here. And then we're going to, once we actually go to accepting data, also expand to the other versions because that's where we'll likely accept data as input. So I'm going to make a copy of this endpoint here. And I'm going to update this, and instead what we want to have now is we want to be able to accept some sort of user ID, and for now we can have this be a string, but later on we'll probably change this to an integer. And what I'm going to do is I want our endpoint here to be updated so that rather than, looking at this data, user/me, I want to have a user ID that can be defined upon request, or kind of with the request that is being sent here. And so to accept this variable input, I'm going to use curly braces, and then I'm going to put the variable name in here, like this. So we're accepting a user ID in here, and then we also need to add this parameter inside of our function definition here to accept this. Now we have access to this. And so what we can do, for example, if we have the get user info, we can actually update our function here to include a parameter. So we can say, for example, user ID string, and we'll set the default to be none. And because we're kind of simulating our behavior, I'll update this function in a second here, but first I want to also pass this parameter in here. So now we have two different versions. Essentially, we have our test endpoint, and I need to rename this actually, get user. I'm going to call this for now because that's exactly maybe get user by ID to be more specific. So we're going to get a user by their ID. This is going to be the endpoint that we're going to use for it. And now in our get user info, which is going to return the full user profile, we have the option of providing a user ID as input parameter, which is what we have here. Now we're not making use of this yet, so let's expand this a little bit and make use of this. So we're going to have the profile info, and then we're going to have two different options here. And maybe let's create some sort of default, which has these values. And then let's create one for like a specific user. For example, user1, the short description here is going to be user1's bio, and then this is going to be user1's longer bio. All right, so I'm probably going to, because I use the default parameter here, I'm just going to set the default here to this exact value. Obviously, this is not ideal, but we're kind of simulating getting data from a database because we haven't done any of that stuff yet. So once we get there, we'll also look at updating all of this. And I'm just going to do some formatting here. I'm actually going to hit Command-Alt-L, which is going to do auto formatting for me. And yeah, so we've got the profile info, which we can now choose from depending on our input parameter, and we're going to do the same thing for the user content. So I'm just going to make this a nested dictionary, so a dictionary within a dictionary, and then we're going to have our default here, and then I'm also going to have here the user1 case, which is just going to be We'll just leave this empty for now. Oh, actually, I think we have a minimum length requirement here. So I'll probably take these out because we're not really making use of this. Oh, we'll have the minimum length in here, but the other stuff I'll take out. All right, so something like this. So we're returning very similar information. All right, so our user has our user content, our profile info that we want to have here. We'll call this profile infos, and our profile info is going to be taking from our profile infos and accessing the key of the user ID. So if we have no input here, it's going to take the default case. If we have user ID equals 1, we're going to take the user 1 case. And in case we actually don't have the value in here, this is going to fail. So we'll see that in a second. And we'll have user's content, and we'll say our user content, and then doing a similar thing, just accessing that specific key here. All right, so we've kind of updated the data that we're getting, and oh no, we do need that there. All right, so it's not ideal, but it does the trick right now for just kind of looking how the other components are going to work. So we have two endpoints now. One is the user/me, and one is the user/user ID. They return the same data, but one of them accepts the user ID as input. So let's just go ahead and take a look at that now. And I'm going to go ahead and refresh our documentation page here. And so now we can see we have two endpoints. One of them is this /user/ and then the user ID, and one of them is the /user/me, which is also the ones that we've defined here that we can see. So this one we've had previously, and let's just check to make sure this one's still working. It doesn't fail. So yeah, it still works. And it returns all of the information that we expect from when we have no input parameter here. So that's going to be the default case here and the default value here, like this. And now maybe let's try our other endpoint, which is going to be the user ID. So I'm going to click here, try it out. The user ID that I'm going to put in here is going to be user1, like this. We're going to execute, and let's see, we're running into a problem. Oh, it's supposed to be user1 here. So refresh. I don't even need to refresh, but I'm going to do it anyway. And let's try that again. And there we go. So also here we've returned the user1 case. So right now, if we look at our short description in our long bio, this is the one from the user1 case, and also our like posts are empty, which is also the case here. Now we've also just seen what happens when the values that I put in here don't exist, and we're going to fail. So if we take a look at our output here, we can see the failure is occurring here, and the problem is that the user2 here is not there. It doesn't exist. So in this case, we're kind of, if the data isn't there, doesn't exist, and it's failing, but at least we have the option now of choosing between the different components here. So either we have like a default or user1, and obviously we could expand this to include multiple users. We're not going to do that because it's not very practical, and it's not really the correct way to go about it, because right now we're just, we're reading data from a database, we're just kind of simulating it, but we can see here now we have the option of providing this user ID as a parameter here, as a path parameter is what this is called, because it's part of our path here in the URL. And yeah, so the interesting thing now is there are also other things that we can do. So we have our path parameter, which is what is inside of these curly brackets. And when we look at the requests that we're sending, we can see here this actually gets filled in. So this gets filled into user2, for example. If we have in here user1, this user ID gets replaced by whatever we have here, some user ID. So you can see it getting filled in here. Whereas here, we can just see, there it is. It just says /me. Now, one interesting thing to note about this is that it's very important that if we want to have this special case, that we do it before we define this general variable input parameter here. Because if we had defined our endpoints in this order, then everything would go in here. So we can try this out now, even though we still have it defined. If I try this out, it's not going to work because it's going to go into this one here. So we can see it's running into a problem because me is not defined in here. So in these special cases, you want to make sure that you define these before you have the general path version of the same endpoint, because otherwise it's just going to be taken in here first and it's never actually going to get to this case. Whereas in this case, if our user ID here is me, then we're going to go into this specific case, which we can also see. So now it's going to work again. And if we try this out with the user ID being me, we're actually going to go into our special case here, and we're not going to be in here. So just kind of as a side note, being aware that order definition here actually does matter. If you do have variable components, then, make sure that they're in the correct order. Now we're not just limited to one path parameter, we can actually have multiple. So for example, we can do /user ID, and then here we can have something like maybe like company ID or something like that, and we can say that company ID here is going to be an integer, and we're not really going to do anything with company ID, but we can just say like received user ID, and company ID, just to show that it works. So refreshing our documentation, we can see now we have two input parameters in our path here. So the user ID, we can have, for example, user1, the company ID is going to be company123, and this is supposed to be an integer, so we'll do 123, and there we go. It still works for the user1 values, and we can see in our output here we've received the user ID and the correct company ID as we have it here. So the point of this being that we have the option of having more than just one path parameter, and we can expand it in this format by essentially just, having extra variables here and also just having them up here in the accepted input for our function. And all the type validation actually is done with Pydantic, which is also why you saw already when I tried to have some non-integer value here, it already complained to me because it's going to fail because it's only accepting integers, whereas in fact I'm trying to send a string. So if that ever happens, then the server is going to send back a response that essentially the input was invalid because it's expecting an integer here, but instead you sent a string. So that type conversion, having that type conversion is really nice because now we know company ID is going to be an integer and user ID is going to be a string. All right, so this is kind of what we have now for the getting components. I'm going to remove the company ID here because I'm not really going to make much use of it. And just going to take this out. And in the next lesson, we're now going to look at sending data to our server. All right, so now let's take a look at actually sending data to our server. Decided to split these videos up because I didn't want them to get unbearably long. So we're going to look at each of these in components. So we've looked at the variable path parameter here. Now we're going to look at, like I said, sending data to our server. And we're going to do that by having another endpoint. We'll call this add user, which for now is just not going to accept anything, and we'll expand on this in a second. And here we're going to do an app.post, and the path here is going to be /users. So what's going to happen here in this post method compared to the get method that we have here, which we'll also see if we open up the documentation, and I've already refreshed, but going in here, we can see now the post method is added here. So we have the get before, which essentially reads data, retrieves data, but now we have the posting here, which is essentially sort of a creation. So we're sending data and it's going to create for us. All right. So we have our users, and now what I want to do is I want to actually change this function up a little bit, and I'm going to create a separate function, which I'm going to call def create user, and I'm just going to make sure, it's not conflicting with this one. And this here is going to take in a full profile info, the full user profile. And what it's going to do is it's going to, well, essentially what it should do is probably insert this data into a database somewhere, because we're not dealing with databases right now. What we're going to do for now is we're just going to take these dictionaries that we've defined, we're going to take them outside so that we can access them globally rather than having them within a function, and we're just going to update these. Now, our user content here is a little bit peculiar because we're defining our profile info in here too, but we'll first update this. Have to make some small changes here, but yeah, so let's do that now. So we have our profile info. This is going to be, and we can actually just stick with the default because everything else we're going to want to create. So we have our profile infos. Our profile info is going to take the profile infos, look up the user ID. Our user content is going to look at the user contents, and it's going to take the user ID, and then we just need to supplement it by, rather than having this value in here fixed now, we're going to do basically insert it as a new key, like such. All right, so let's take a look at our user input, which has the username and the liked posts. Username and liked posts. It's going to be your user content here, which has the liked posts, and the username is not actually in there, but yeah. Actually, I don't even think we need this in here because we're also putting in here a profile info, so I think we just didn't change that previously, but we don't actually need this because we have our profile info and our user contents here, and yeah, we're just providing that as input into our full user profile here. All right, so I'm just going to make sure this works before we're doing anything else, just to make sure that there are not any mistakes anywhere here yet. So refresh this and try this out. Okay, it's still working, great. And this one's not going to work anymore if we do here user1 because we've obviously removed that. But this, I mean, it will execute the previous one, yeah. So, still working. All right, great. So now we have our add user. And one more change I'm actually going to make is I'm going to update our user ID from a string instead to an integer. And I'm going to make sure that I update it here too. And if you're wondering how I just did that, if you have the function here, if you command click on Mac, and I think on Windows it's Control, but you can also try Alt, but on Mac, command clicking on this will actually take you to the function definition. So you can see here, I clicked on it and I immediately got scrolled to the proper component. So our default user ID here, I'm just going to put as 0. Now the reason I'm using an integer over a string is because in databases, as we'll see later, most of the time you'll have some sort of integer key, so it's going to be like 0, 1, 2, 3, 4, 5, whatever. And if you do have string IDs, then they're not going to be in the text form that we've seen them, but they're usually going to be some sort of like hash value, which just looks really weird and ugly. And so we're just going to stick with integers, although string IDs do exist and are used. We'll just stick with integers just because it's easier to kind of conceptualize. All right, so that means we have to update our default values here instead to be numerical because all of our user IDs are numerical. And again, the only reason we need to do this is because we're kind of simulating our database right now. So yeah, we've made our change here to go from a string to an integer, and I'm going to refresh our documentation. We should see that change here. So yeah, this is going to be an integer, but the me endpoint should actually still work, even though this is a string, because we've defined it first. And so we'll reach this one first and we'll check it first. And even if I put in here an integer now, this is still going to fail because we don't actually have any data defined anywhere for it. Oh, well, 0 works, ironically, because it's our default value that we have here. But if we try anything else except for 0, yeah, okay. Good, as expected. All right, so now we've kind of changed our stuff around so that we can access this, which are now these shared dictionaries, which currently hold our data. And we're going to now have our new post, which is going to add a user. So what we're going to do here is we're going to take a full profile info as input. So the first thing we want to do is we need to create a new user ID. So our new user ID for now is just going to be very simple. What we're going to do is we're going to look at the length of our profile infos dictionary, which is going to tell us the number of keys, and that's going to be our new user ID. So in this case, our profile infos has one element in it, one key, so our user ID, the new user ID is going to be 1. Once we've inserted that, there are 2 users, so the new user ID is going to be 2. This works because I started here at 0. If I started here at 1, in this case, I would need to add a +1 here, just to make sure that we're not, clashing with existing keys. So I'm just going to create a new user ID here, and now I just need to insert the data. So in our user content, I need to get the liked posts. So I'm going to say our liked posts is going to be our full profile info dot liked posts. Then we have the short description, which is going to be the full profile info dot short description, and we have the long bio, which is going to be the full profile info dot long bio. All right, so these are the components that we need. So first I'm going to update our user content. So I'm going to do this by creating a new key like this and setting this value just to be the like posts, like we have this format here. So our key here is going to be our user ID, and then our value here is going to be a dictionary with just the key like posts, which contains this list of integers. And for our profile info, I'm just going to copy this, and we're going to say our profile infos is for the new user ID is going to be, and we're going to take this, oops, and the short description is going to be our short description here, and the long bio is going to be the long bio here. So essentially we're just kind of putting these in these 2 dictionaries, and just to show you, we're going to print out our user content afterwards, as well as our profile info, and we'll say here after, and we'll also print out the values before, just so that you can see. Again, usually we'd be using databases for this, but since we don't know how to deal with that yet, we're just going to stick with our hard-coded values here. All right, so we have this create user method, which accepts this full profile info. Now we want to use this here. Essentially what we want to do is when we add user, we want to call this create user method. But to do this, we need to accept, or we need to somehow get this full user profile information, which if you think about it, this will probably be some sort of sign up form where the user will input, like their bio, their username, and whatever. And so we need to receive this data. Now to do that, if we actually put in here, in our function definition, a pydantic model, then now we can accept this data as a request body, and we'll see in a second what exactly that means. But for now, if we just put it in here, we actually directly have access to it. Again, the variable names here don't need to match, so I could call this, for example, FPI for full profile info and use it here. I'm not going to because this is not very descriptive, and so I'm just going to use the same variable name because it's the most descriptive to what it actually is. Or we could also call this something like new user full profile info, but I'm not really going to use this because the function name already says that this is adding a user, and so it's kind of, you're repeating intentions and you're not really adding any value. All right, so let's take a look at this now. And before I refresh the documentation, let's take a look at how it looked before. So we have parameters, and this is kind of the response that we get. Refreshing, we can now see we have a request body defined here. And if we actually click try it out, and just looking at our console, we have nothing yet. Try it out. Now we can actually define the information. So the same name, we can have some random user, although I just realized we're actually not saving the name, so that's a bug in our application. The like posts is going to be post 1, 2, and 3. The short description is going to be some short description for this user, and then here we'll have the long bio be the user's long bio. So using the documentation page again here, this is really convenient because I can just format all of this directly in here, and I don't really need to go anywhere else. Now if I hit execute, we can see here, this is the request that was sent. So we've sent a post request to our user's endpoint. This is the data that was sent with it. And we can see here we get a no response, so nothing was returned to us, but we do have a 200, which means okay, but we'll look at status codes later on. Taking a look at our output here, we can see before we have this and profile infos. Oh, I think I printed out the wrong thing here. Yep. All right, but we can already see it in the user content, and the next time we run it, we should be able to see it for the profile infos too, but we can see this field now got added in here. And all right, so yeah, we're not saving the name yet. I'm not really going to fuss about that though, because it's not that important. Because again, we're just kind of, simulating this behavior for now. All right, so we were able to kind of update. Now that means we now have a user ID with user ID 1. We now know this because we can see this data. And so if we now use our get here and provide the user ID 1, we should see the data that we just sent. Now we received an error, so let's see what happened here. It's saying it's not defined. So let's take a look at what happened. Scrolling down to our definitions, we have our profile infos. Oh, since we're updating them, I accidentally forgot to import them as global variables, which, thinking back to our global variable lesson, is something we need to do. All right, so again, importing these as global variables because we want to update them. Let's try this one more time. So I'm going to see if our data, yep, our data is still here. So I'm going to copy this. I'm just going to refresh, try it out, paste the same data that we had previously, and execute. Let's take a look at our output. So yeah, now we see it. If you're wondering why previously, even though we sent it previously, this data is no longer there, it's because every time we restart our server, this essentially gets reset. So because I've written something and I've saved, our server automatically restarted itself, this now gets reset and this data is no longer here. So that's why this is now empty. All right, but now we can also see that before and after the profile infos have been updated. And now if we try it out with user ID 1, there we go. So this is the data that we've now provided here. So we can see we're now able to add data and essentially extract it again. And taking a look at the definition that we had up here, providing this pydantic model as input, we can see here in our post users endpoint that we have a request body that was created for it. I'm just gonna refresh because I can't find it right now, but yeah, here it is. So we have a request body, and this is an example value, and this is the schema, but now we accept data of this format into this endpoint. Now, most definitely, we can create different models here. They don't have to be the same ones that we're using as in our response models here. It's just convenient because, right, we have to return the full data and we want to be able to write the full data. So in this case, it makes sense to use the same thing. But obviously, these don't need to be the same, and you can have different input and output data models depending on your needs. All right, so yeah, taking this in. Now, one small change that I would make here is if we actually think about our previous response, we only got a null response, but really what I would like to know is what is the user ID of the user that was just created, because that's pretty important usually for the application, because maybe they want to also do something with that user ID. And if I just say, yep, the user was created, but I don't tell them what key or what ID the user has, that obviously makes it a lot more difficult. So what I'm going to do is I'm going to create a new model, which is going to be very simple. I'm going to call that class user ID, which is just going to take in the base model, and I'm just going to define here user ID as an integer, and I'm going to or maybe I'll call this create user response, because this is actually more accurate to what it is. And our response model here is going to be the create user response. Now I'm going to return this, just this function call. I could either say, our user ID is this, and then return the user ID, or I could just return this directly. And now I just need to make sure that in this function, we're actually returning a user ID. So I'm going to say, just for our typing annotation, we're going to return an integer here. And at the end here, I'm going to return our new user ID. All right. So starting our server again, because it crashed because I had some syntax errors at some point, and refreshing. I wonder if I still have the data here. No, I do not. So I'm going to fill this in, some random name, and we'll say 0 and 1, short and long, just to make this a bit quicker. Hit execute. Has an internal server error. So, right. I am returning the user ID, but actually what I want is to return the create user response. So I am gonna do this a little bit differently. I'm gonna accept the user ID here. I'm gonna have our created user and create or initialize our Pydantic model like this, and then I'm gonna return this. So the reason that we had our internal server error is because I said we're returning with this model, but in fact I just returned an integer, and so I need to make sure I convert it to our Pydantic model. And the reason I chose to do this outside is because a create user should always just return the user ID, because we may not always want to use this create user response model. And then in here now, I can convert it into the proper format that we need for this endpoint in this case. Because if we want to use this in other places, maybe we don't want to create user response, but we just want the user ID to be able to do different things later on with it. Yeah, so I'm just allowing myself a little bit more flexibility by just returning the user ID here, and then here transforming instead into the Pydantic model that we need to return, because that's what we said, the model that we will return. So refreshing one more time, we can see here now our response will return information in this format, and this is the data that it accepts. And I'm going to fill this in again, so short, long, and there we go. We've now received our user ID here as the output. So we can see now, okay, user with ID 1 has been created. Now we can access it like this. We can see here the information we just inserted. If we do 2, it's not going to work because we haven't created 2 yet, but if we send another thing here, so some other name, some other short, some other long, and maybe just changing this just so that we can see it's actually different. Now we can see here we have user ID 2 created, and now if we try this with 2, it actually works. And we can also see, because we're still printing out our outputs, that this is being updated. And now we can actually also see here that in the before, now we do have that updated value. So yeah, this is how we can add users, and we've looked at the post. There's still other parameters that we're going to look at in following lessons, because there are still some other ones that are available to us. But now we're able to not only read, but actually also create new users and accept data into our endpoints here. And we can see we were able to do that by accepting a Pydantic model as input, and FastAPI being amazing as it is, we don't even need to deal with any path parameters here. If we have a Pydantic model as input, it's just going to say that this is the request body that is expected from this endpoint. Now, I know we've covered a lot in this lesson, so I would recommend playing around with this here, and maybe creating a new model as input, playing around with a create user function, taking a look at the documentation that's generated at every step, making sure to refresh if you make any changes, just to make sure that your documentation page here is updated, printing out some of the values to make sure that you're fully understanding the changes that we've made here and how our data gets sent in, how that is changed in the documentation. So for example, also seeing that when we take this out, and well, let's just do nothing here. So we can see here when we take this out and we refresh, and there's some error here because, oh, not running the application. We can see here now it no longer has a request body that it accepts, but when we enable all of this again, refresh, we can see here the request body is created. Here it has example values, like the schema that it accepts. And yeah, so definitely recommend, just taking some time with that, looking at the generator documentation, playing around with it a little bit, adding some print statements, and just, seeing what's going on both ends. All right, so we've seen how we can send different types of requests right now. We have the post as well as the get, and we've also looked at how we can actually take data in with us by using a request body here. So the first thing that I want to look at now is going to be one additional way that we can take in data, which is going to be through query parameters. So what I'm going to do is I'm going to create a new endpoint, and I'm going to call this get all users paginated. And we'll see in a second why. I'm going to put in here the user ID like I had previously. And yeah, we'll go ahead and work with that. And we're going to do here app.get. And we're going to have our endpoint just be /users. And our response model here is also going to be the full user profile, but actually we don't just want one profile here, but instead what we want is a list of user profiles. So what I'm going to do is I'm going to create a new class here. I'm going to say class full, well, maybe multiple users response. And this is going to inherit from base model. And it's just going to contain a single field, users, which is going to be a list of full user profiles. So every element in this user list is going to be of this type. And that way we can actually have multiple users here. All right, so we have this, and what did I call this again? I think I called this multiple users response. Okay, so this is going to be our output. All right, so now I'm going to create a new function here. I'm going to call this get all users, and I want to make sure it doesn't conflict with this name here with pagination, and we're going to have our start and our step size. So what we're going to do is we're going to take two inputs in here, which can be the current starting page and essentially how many users we want. So one way we can call that a start or a step, or the other one is going to be a start and a limit. And we're going to provide these as extra input parameters here. So we can say start is going to be an integer, and our limit here is also going to be an integer. And these values are going to default, our start should default to 0. And we'll say our limit for now, although something like 20 is more sensible, or even 50 or something like that, I'm just going to start with, I'll start with 2, and then I'm going to create some extra data. And that way, we don't have to experiment around too much with it to actually see the results. And what I'm going to do here now is I'm going to call this get all users with pagination. Since I used limit, I'm also going to use limit here, which is going to be an int. And our start here is also going to be an integer like this. And yeah, so we're just going to call this function for now. And
And once we have this, I'm just going to go over and explain what the purpose of this is and what we're trying to do. All right, so the point here is that we have an endpoint where we can get multiple responses. So rather than just getting a user by a single ID, maybe we just want to get like a list of users. We just want to be able to essentially scroll through all users if we wanted to. Actually, we don't even need the user ID as input here because we don't have it in our path parameter here. And so we want to be able to, yeah, essentially just scroll through our users, but because we don't want to return everything at once, because that could lead to really, really large requests, which could time out or the data never gets sent because there's just so much data to send, we want to be able to send these in increments. So for example, say 2 users at a time, 5 users at a time, 10, 50, whatever. But the important thing is that if we want to be able to scroll through everything, we have to be able to know where we left off. And so that's kind of what we're doing here with the start and limit. We can say, okay, we're just going to essentially start from the top and we're going to build up this list. And then over time, we can go through and over multiple requests. For example, if we had 6 users, if we do this request 3 times from start being 0, 2, and 4, then we will always be able to get 2 users at a time. And with that, we can then get all the users, but we'll have to do it in several segments. But this is generally good because otherwise your requests will get very large and things may start to fail. So yeah, and the point here is that these are not supposed to be path parameters because these are optional things that we can additionally query for, but they're not, they're not like specific entities like we put in here in the path. Whereas, for example, user ID will correspond to a specific entity, but these in that concept do not fit in the path. These are more filters that we can apply, which are extra query options. And so that's what we have right now, which is going to be query parameters. And we'll see also in a second how these query parameters look different compared to these path parameters that we have predefined. All right, so we need to return from here a multiple users response, which is just a list of users. So maybe what I'm going to say right now is, or I can even call this, our users are going to be returned from here, and we're just going to directly return our users maybe. Yep, like this. Or maybe what we want to do instead is maybe have some sort of step in between, like formatted users, where we're going to take our multiple users response, and then here we're going to set our users equal to the users. Oops, like this. And so what we're going to return from here, that means if we want to provide this as input, we're going to provide a list of full user profile as output. Now again, the reason I'm choosing not to return this directly is just because if we want to use this in any other way, then returning this, it just adds a little bit more headache in the sense that we have to convert to it and then convert from it, whereas we could have had the more granular format, which is what we'll have as output here. So we have the get all users with pagination, and we know because of how we're using it later that we want this to return a list, and each element is going to be of type full user profile, like this. All right, so how do we actually get our user info? Well, it's through this method here. So what I'm going to do for now, obviously this isn't going to be the best way to do it, but we're just going to do this in this way for now because we don't have database queries. So what I'm going to say is I'm going to take all of the keys from our profile infos because this currently, there we go. So this dictionary currently holds all of our user data. So I'm going to take all of the keys, and then I'm just going to start making a little loop, and I'm going to say for I in range, we'll start with I and we'll make this more specific. We're going to go from 0 to the number of keys that we have in step sizes of 1, and we're just going to say if I is less than
start, then we're going to just continue on. And here we can say our list of users is going to be an empty list like this. And at the bottom here we want if our list of users, if this length is greater than or equal to our limit, although it should never get greater than, but we have this here as a precaution, it's greater than or equal to our limit, then we're going to exit out of our loop. And now what we want to have here is we're going to get the user info taking the current key that we have. So our current key is equal to the keys that we have in the beginning, and we have an index here, like this. So we have our index of our keys, and we're going over them key index one by one, and then once we've passed the start, so that means if our start is 0, then we're going to take, in this case our limit would be 2, we'll take the first 2 keys, because this is never going to trigger, because this is never going to be less than 0. And then once our list of users is greater than or equal to our limit, then we're going to break out. At the end here we want to return our list of users, and now what we want to do here is we want to add this user to our list of users, and here we need to provide the current key because that's going to be the user ID. So I would recommend just taking some time looking at this function and understanding what it does, but again, let's go through it together. So all the way from the top, we have an endpoint where we want to be able to scroll through all users. We don't want to return all users at the same time because that could mean a ton of data, and that could mean that our request will fail because it's just trying to send so much data. So we want to be able to do this in increments with a starting position as well as defining how many entities we want, and that way we can scroll incrementally through it. Now we want to have a function that returns essentially the input that we need for our final response. So it's going to be a list of user profiles. So we're going to look into this function here. And because we're not using databases, but we have our kind of hard-coded values here, we're just going to do like a little hack, essentially. And this hack is going to be, well, we know all of the users because we can look at the keys in our profile infos, for example, or in our user content. It would be the same because the keys here should be the same since both of them together correspond to a full user. So we have the keys here, and we can loop over these keys. And if we start at 0, for example, then we want to take the first 2. In this case, if the limit is 2. If we start at 2, then we want to take keys 2 and 3. If we start at 4, we want to take keys 4 and 5, etc. So that's essentially what this does here, is to make sure that if we do start later on, we want to skip all of the earlier ones. Here we want to make sure that our limit is properly enforced, because if we have as many users as we need, we want to make sure that we stop adding more users. And here we're just kind of using the knowledge that the keys here correspond to individual users because we have these dictionaries rather than databases. And then we know that each key corresponds to user ID, so we can use our existing get user info, which will get the user info and format it for us, and then we're just going to add it to the list that we want to return. Now there is a slight nuance here, which is actually a dictionary is not ordered. So usually when you define a dictionary here, and you add new properties, for example, if I add like 5 more keys, there's no guarantee in what order they will be in. So, just kind of being aware of that. However, for our use case, this doesn't matter all too much because, again, this is not going to be a real implementation. Right now, because we haven't implemented the database side, this is kind of our little hack to get close to it. And yeah, we're not really concerned about dictionaries not being ordered. It doesn't really matter to us. All we want to do is just get the keys and then take out a subsection from them and skip over ones that we already have. So yeah, just kind of as a side note that this is not something that you should necessarily think about doing as like an ideal solution, but rather it's kind of just a little hack that we're going to use right now until we can actually use databases, in which case we can implement this more on the database side too, which will, make this a lot nicer. Okay, but from here we're going to get our list of users, and then we're just going to format that and return it. Okay, so let's go ahead and run our server, and I'm going to pull it up here. I'm going to refresh. All right, and let's try it out, see if it works. Oh, it takes in a request body, which we do not want. So why does it do that? Oh, I see. That is our post endpoint. We want to use our get endpoint. So we can see here we have one users that we post to where we can add a user, and one user's endpoint that we get from where the functionalities here are different. And these are okay to coexist because one is a post request, the other one is a get request. So because they're two different requests, they can have two different functionalities. All right, so let's try this out. We're going to start with 0 and 2, and we can already see here these are indicated as query parameters. So we're going to hit execute, and we've encountered an error, so we'll take a look at that in a second. But we can see here the way that our parameters are formatted, rather than being part of the URL itself, like we have here, where we do something like user ID 0, and this is part of the path here. Instead, here we can see that our query parameters are essentially indicated first by a question mark, which indicates we now have query parameters, and then we define them in key value pairs, just like we do when we unnest a dictionary or unpack a dictionary, for example. This is our first field, so the start value equals 0, and every query parameter is chained together by this ampersand sign. So our next value here is limit, which is set to 2. All right, so let's take a look at what went wrong. The key object is not subscriptable. So we have our keys here, and this is a slight nuance. What we have to do is we have to convert this to a list, because if you actually print out the keys here, and once my program unfreezes, there we go, we can try the same request, and let's take a look at the output. Scrolling up. So here we can see our keys is not actually a list, but it's this dict keys data structure. And so what I'm going to do is I'm just going to convert this to cast this to a list like this. And now our server should restart, and we're going to retry. There we go, it works. Taking a look at our output, we can see here now this was properly converted to a list, so this also works properly. Again, a small nuance of the .keys method that we've invoked on the dictionary here. And again, the best way, if something like this ever encounters you, the best thing to debug this is just to print things out and take a look at what are you even doing, because most of the time when you print things out, then you'll notice, oh, okay, that's what's weird, and this is how I can change it. So yeah, the best tip I have for these cases is always just even understand, what's going on, visualize it by printing it out, and then you can see, oh, okay, this is what it looks like. And in this case, for example, just converting it to a list will do the right thing for us, because sometimes we have formats that we don't want, but we can just cast them to the format that we do want, and then things should work properly. Yeah, so just kind of keeping that in mind. All right, so taking a look at our output, we can see here we have a list of users, and each user has this full user profile as expected. So right now we only have one user, because that's the default one that we've provided. So now we can use our post endpoint here, and well, I know we're not storing this name, but whatever, we'll just add some information here. We can say here, like this, and like this, and we're going to execute this, And oops, I think I did not mean to do this, but whatever. It's just the way it is. Well, so we're just going to create a couple users so that we can see this endpoint in action. So I'm going to do 3, 3. Oh my goodness. There we go. Now it's the right format. And let's also do 4. 4, 4, 4. Execute. All right, so now let's try this again. We have 0 and 2, so we're going to get the first 2 users. Okay, so we can see here the users that we have are going to be the default one, and we also have the one here, which is the first one that we've entered. And now if we start from 2, and again, don't change our limit because we still want to take 2, we should get 2 new results, which we can see here. So this is the second one that we've entered. This is the third one. And then if we start from 4 now, take 2 more, we're only getting 1 result because there's only 1 left, but this is the last one that we've entered. So we can see we can use this start and we can alternate with it to essentially change, or like be able to scroll through our users. Again, the implementation is far from ideal because we're using dictionaries to keep track of all this stuff. But as we can see, it does work, or it serves its purpose for now. Obviously, when we're replacing this with database requests, this will work a lot better, a lot more consistency, rather than hacking it together using dictionaries like this. But yeah, so this is, we're able to achieve this scrolling now, and if we want to, we can see if we start at 0 and we take here 3, for example, then we're going to get 3 at a time, and then we just need to make sure that we're also taking steps of 3. So we will go from 0, 3, 6, and that the limit again means this is how many we're taking, and this is our starting position. And so a user over endpoint here will be able to get all the users by just scrolling through, and then there are different indicators that we can have to tell them, when it's done. So let's implement some of these now. One way of doing that would, for example, be, so one way of doing it would be on their side to check when the length of the response is less than the limit, because then they know they've reached the end. And if it fits in perfectly, like 12 and 3, then they're going to see when they go above that, they'll just get an empty response. And we can also just quickly test this. If we go really high, this should just give us an empty response. Yep. So we can see if the length of the response is less than what we asked for in the limit, that means we've reached the end. But there are better ways that we can do this, which you'll also sometimes see in API responses. For example, we can include this is the wrong one. We can include a total, which is going to be an integer. And this one is going to be the same across requests. For example, we can return the total from here. So now we're going to return a tuple here, and our total is just going to be the length of the number of keys, since that's the total number of users that we have, like this. And so we can see, again, looking at this definition, this total is going to be the same across iterations, but our list of users is going to change. So if we try this out again, we go from 0 to 2, we can see here our total is 1. Oh, that's because we restarted, so need to add some stuff here in again. Okay. Just quickly filling in this stuff here, and one more. All right, there we go. And let's try that again. So now our total here is 5. This is our first 2 users. Get the next 2 users. Our total is still 5. These are our next 2 users. So now, for example, the consumer of our API knows what start and limit parameters they've sent. They know the total number, and so based on this, they know where they are, how many are left, and can format their requests like this. And they have a good amount of information, about where they currently are, as well as contextually how much there is in total. So yeah, this is the last kind of way to add extra parameters into our URL. So we've seen or to send data essentially, because we've seen the path parameters. Now we have the query parameters, and we can also see sending a request body. And we can combine all of this stuff together. So for example, we could have had something like this, where we take a user ID into the path, and then we can use this user ID. So this will be defined here. We have our query parameters, and we can also take data in like this. This would probably be something that we will do in a post request, because that's where we can actually accept data. In this case, we can actually see here that it's failing, mainly just because, as we can see from the error, that we have to provide this here instead, because we have default arguments which have default values, and this is a non-default argument. It doesn't have a default value, so we need to go in this order. But even if we tried to do something like this, and just taking a look here and trying this out with some random stuff, we're going to fail here too, because our get does not accept a body. So yeah, just taking this out because this is something that we'll have for the post requests. But yeah, just to be aware that it's not either or. We can do all of these together. And yeah. So now we have the different ways that we can send data. Again, the use cases are going to be here. We can filter for specific entities that we're looking, or we can select specific entities that we're looking for. This is our way to send full data, which we want to do over a request body, not over the URL. But then we can have optional additional filters that we can do by, making it part of our query. And this shouldn't be here anymore. But yeah, we can use query parameters to essentially have additional filters that we can use to, have specific behaviors. In this case, it's pagination, so that we can do some sort of scrolling, but also other filters. And that's kind of also where you can decide. Other filters can either be part of a request body, or they can be part of the query parameters. So we've seen a good amount of ways that we can send data to our API, different endpoints here using different methods. We've seen query parameters, path parameters, as well as request bodies. Now we still have two more request types that we can have. So one of them is going to be put, and the other one is going to be delete. So let's take a look at each of these now. We're going to start with the put. And we're going to have a new endpoint that we're going to call update user. We're going to take a user ID that is an integer as input. And our endpoint here is going to be an app.put. And we're going to go to /user and then user ID like this. And we'll keep our response essentially empty for now. So we're not really going to return anything. Okay, so what we're going to do here is, and notice how we have this endpoint multiple times now, and I'm actually going to group them together, I think, just to have a better overview. So we have a get user, and now we also have a put. So with the put, just like with the post, we can send information with it. So what is the difference between the two? So the way that we use the post usually is to create some sort of new entity. And we can see here we're going to a general /users endpoint, so we're not specifying any entity. Whereas for the put, what we're doing is we can either create or update. But notice how we're using it. We're going to a specific entity. So we already know where we're going. And so what this put is going to do is it's going to take in a request body. And this request body is going to be the same thing that we're going to take in for creating a new user, but we're going to use this information to instead update it. So we're going to take in a request body here, which is going to be the full profile info, and we're going to look at a specific user. And what we're going to do is, if the user exists, we're going to update their information, and if it does not exist, we're going to create a user with that ID with this information. All right, so let's go ahead and check on what we already have, and I'm going to take this away for now because we're not really using this anymore. But we have our create user function here. So let's see if we can already use this. We have a new user ID that we're creating, and essentially we're using all the information we have from our full user profile, and we're returning the new user ID. Now what we want to do though is we know our user ID. So what I'm going to do is I'm going to actually update this function signature here a little bit. And I'm going to say we're going to have a new user ID parameter that is going to be an optional integer, and it's going to default to none. And let me check if I spelled optional correctly. Looks fine, so we're going to import it from typing. From typing, import optional. All right. So we have our new user ID here, and in this case, right now, our old endpoints here will still work because we're not providing the new user ID, and so it's going to default to none, and anyway, we're overwriting it. Now I'm further going to update this, and I'm going to say if new user ID is none, then we're going to assign it like this. So that means if the new user ID is not provided in the function signature, which we don't provide here, then we're just going to carry on as per usual. However, if it is provided, then we're just going to not overwrite it, and we're just going to take whatever is given to us. We're going to do the same operation. So I'm going to also rename this from create user to create update user, because now it can both create as well as update, and I need to make sure that I also update the name that I have here. All right. So now I'm just going to use this function. I'm going to say create update user. I'm going to pass the full profile info, and I'm going to pass the user ID. And we're not returning anything, so I don't even necessarily need to do anything else. I'm just going to explicitly say here return none, but I don't also need to get the response from here because the user ID is already provided upon request. And yeah, essentially all that we need to do is apply the operation. Now, really the only thing that our consumer will care about, whoever uses this API, is whether the response or whether the request was successful or not. And that they can actually determine using the status code, which is something that we'll look at later. But if we want to, we can implement something that just says it was successful. Basically, it has some sort of response where the status is success or not, but that can actually be done using status codes themselves. So we don't actually need to return anything, because if the consumer sees that from the status code of the request it was successful, and again we'll look at status codes later on, then they know it was successful. And if it wasn't, then it wasn't successful. All right. So yeah, let's just take another look at this to make sure everything is proper. All right. And actually, I deleted it, but I probably want to take a look at it again now. We want to look at before, and we want to print out the user content before. Oops. As well as the profile info before, and then do the same thing after, just again so that we can actually see the changes in action, like this. All right. Now another thing to note is that when we have a put endpoint, if we send to the same put endpoint multiple times, it's not going to have any negative side effects. We're just going to re-update the same user multiple times. But be aware that when we send to the post endpoint multiple times, we're actually going to be creating a new user with each post request. So there's that extra difference that we have between the put and the post. So just kind of another small detail to be aware of. All right, so let's go ahead and run this. This is the wrong command, so we're going to go unicorn main app reload, and run this, and pulling up our API here. Still have the one from last time open. Refresh this. All right, so now we have a put endpoint here. And let's do a post first. So we're going to have here user1 like this, and it's going to be short one, and this is going to be long one like this. Execute. All right, successful. We've created user ID 1. If we look at our output here, we have before, which is this. I'm going to close this. Before, which is this. And now we can see we added in a new user. Now the interesting thing, again, with a post is, if I execute it again, we see we get a new user ID, and we see we get another entry. So now let's try something similar instead with our put. So we're going to try this out. Because this has the exact same input schema, I'm just going to copy all this over so I don't need to retype it. I'm going to put in here user, I'll say user 2, short 2, long 2, and I'm going to update user ID 2, which is the one, remember, that we've just actually created from this response here. So we already have user ID 2, which we can see here. So now I'm going to update this, and essentially the changes that I expect is everything here that's a 1 is going to change to a 2. All right, so let's execute. And we didn't get a response, but we see here we have a 200 code. Again, we'll look at this later. And now taking a look at the output, we can see here our user 2 has been updated. And now we can also use this to create user 3 if we wanted to. Something like this. Execute. And now user 3 will have also been created. And no matter how many times I execute this, we're still just updating. So this is a request that we can do over and over and over again, and it's not going to have any other negative side effects. Whereas for the post, that is not true. If we send it multiple times, we're going to get multiple users created with the same information. So yeah, this is how we can use our put. Finally, we also have a delete. So it's going to be app.delete, and here we're going to say remove or delete user, either one is fine, user ID integer, and I'm going to use the exact same path here. And now what we're going to do is we have the create update user, so I can take this away because now we really don't need it anymore, hopefully. And I'll say here def delete user, takes a user ID, and that's an integer, and it's not going to return anything. And let's take a look at this. So also we need to take in the profile infos and the user content, and we're just going to delete the keys. So I'm going to say delete profile infos user ID, and I'm also going to say delete user content user ID like this. And then we have to use this, so we're going to call delete user ID like that. All right, so starting our application up again, and if we just refresh our documentation, then we should get another delete endpoint here, which we have here. So notice we have the same signature 3 different times, but 3 different methods that we have. All right, so let's use our get users and check out all the users we have. So currently we have 1 user, which has the user ID 0, which actually is something we probably should return here, that we're not, but this is technically something that we should be returning. So actually, I'll probably want to change this in a second. We have 1 total user here. Now if we delete the user with user ID 0, return successfully, but no response, because we didn't set one. Re-execute this, now we have nothing here. So our deleting also works. Now the only thing here is this is going to fail when the user doesn't exist. But the thing is, it doesn't fail very nicely because it's not really clear. It just says internal server error. It's not really clear if the user was actually deleted or if they didn't exist in the first place. And there's some stuff that we can do about that. And the way that we can handle this is maybe instead of, just explicitly failing like or not even explicitly, just internally failing somehow, we can see here the error is a key error 0, which happens in this position here, which means the key 0 was not found in our dictionary, and so it does not work. So one thing that we could do is, if this fails, we just return a 404 response. Again, status code is something that we'll look at later, but essentially that means that rather than just failing, saying something went wrong, we'll say it failed, but we'll say 404, which you've probably seen before, which means it wasn't found. And so that way we can indicate, the user wasn't found, and therefore the request failed because the user wasn't found. But either way, there's some error handling that we should be implementing here, because we really don't want this to just fail if something, if it doesn't exist. And so we do want to use some sort of try and accept statement here so that we properly deal with the key error, in this case, that we've seen before. So yeah, that essentially covers our put and delete endpoints, and yeah, with that, we'll carry on with, more fun stuff in the next lessons.
So now that we've expanded upon our endpoints, and we can also see we have several different functions here that we're using, I want to take a quick detour and cover something called docstrings, which let us essentially write documentation for functions, classes, methods, and even whole modules just in code. So we're going to take a look at how we can do some of these. So for example, let's do it for the get user by ID endpoint that we have here. So to start a docstring, we're going to use 3 quotation marks like this. And you can see that in the completing 3 quotation marks get auto-generated already by my IDE here. And for most of the ones that you're using, I'll probably do the same. If I hit enter here, you can see it already gets filled in with some components. And so essentially what we have here is we want to have a description of what exactly is going on. Then we want to also have a description of our input parameters as well as our return parameters. And this way, and I'll show you also how we can do that, there are ways that we can actually access the documentation of a, in this case, function, for example, and it can help others get a better idea of, what is actually going on here, especially if the thing becomes a lot more complicated and reading it itself doesn't necessarily make sense and you have to do several takes. There, docstring can help a lot to really understand what's going on. All right. So in our get user by ID, here we have just the endpoint for retrieving a full user profile by the user's unique integer ID. So a very simple description. But yeah, this is essentially what it does, right? It doesn't do anything complicated. We just extract and return the data. Our input parameters is going to be a user ID, which is going to be an integer. And the description here for this is unique and monotonically increasing integer ID. So just a unique integer ID per user that monotonically increasing just means just continuously goes up. And what we return is full user profile. So pretty simple documentation here. Really not much to say about this endpoint either, because it's relatively simple. But this is one approach that we can take for it. And obviously, as things become more complicated and as you get more return parameters, etc., there are more stricter guides that you can go in and that you can follow. But I'll talk about in a second why I'm not going to go into too much depth for this. But let's just form another docstring first. So let's say, let's go here, create update user. And notice I'm always putting the docstring at the very top. So just after the definition. So we have our create update user. And what this does is create user if not exist, otherwise update user. Create user and new user and new unique user ID if not exists, otherwise update the user. Essentially what it is. Of course we can make this more descriptive, but at the same time, like, we want to be coding, we don't just want to be writing out essays here. So our full profile info is of type, I'm going to copy this over, full user profile, user information saved in database. Essentially, this new user ID is, and good thing we already do our typing, because then we can just take our types over. It's of type optional int, user ID if already exists. Now, just kind of reading this, actually, I would probably rename this parameter here to user ID, because if this is provided, that it's not a new user ID, then it's an existing user ID. So I think I'm just going to quickly do that. So one thing that we can do with our IDs too is we can actually right click, go to refactor, and we can do here rename, and then I'm going to take all of this out, and when I hit here refactor, you can see here everywhere where this was used was actually already renamed for us, which is really nice because it just, saves us a little bit of work. So, all right, so we have our user ID, and user ID if already exists, otherwise to be set. Okay, so yeah, again, what are we returning? We're returning the user ID, which is an integer, existing or new user ID. So this is essentially, what we're doing here. Let's put in enter here for readability. But yeah, we're creating a new unique user if it doesn't exist. Otherwise, we're updating the user. And maybe we can also say placeholder function later to be updated with database, or placeholder implementation, I'll rather say. Placeholder implementation later to be updated with database. So essentially this is not going to be our final implementation, we're going to change this later. And again, these are not like standards that I'm writing here. This is just kind of me trying to describe in succinctly, but still being descriptive enough, what exactly is going on here. Right, so let's talk about docstrings a little bit more. One of the dangers of using just comments in general in docstrings is it's very easy to forget to update them, because they're not going to be, docstrings are not going to fail, comments are not going to fail when you change your code, right? Like, I could change everything here, the full behavior, and I could just forget to update the docstring here. And, there's no real issues that I will get with this, because this is just comments, essentially, right? This is just a string over several lines. And that's kind of the first dangerous place. The other dangerous thing, or the other thing to be aware of about comments and doc strings like we have here, is usually if you're writing this internally in your own private code, be it completely for yourself or be it at a company, if it's only used by you internally, generally you're not going to be writing doc strings. It's only that you're going to be writing doc strings when you actually try to make modules public so that others can understand, what exactly you're doing or what exactly the purposes are. And even in those cases, most of the time, I think, and
when we go to different libraries and learn how to read documentation, you can also explore this to see what other conventions others use. But even in those cases, I found most of the time docstrings will only be in certain places, not everywhere. Most of the time, it's when things are not obvious. Because as having good coding syntax, like having proper function names, having proper class names, having proper variable names, if we have all of that proper, then it should be very obvious what our code is doing. And only in certain cases where, we use some algorithm that is not obvious, or some approach that, requires some sort of like background reading that, isn't just subject matter knowledge, but really has some extra components. In those cases, we can add docstrings or comments so that we can help other readers along, or hopefully our future selves, if we ever forget fully what is going on, to understand why this is done this way, why it works. Especially if an implementation may look wrong, but it needed to be done a certain way because maybe there's something weird going on in the database, and we actually found that issue, and so now we need to do this to kind of counteract that weird thing that happened when the data was stored, or something like that. So in those cases, it's good to add comments, it's good to add doc strings, depending on if it needs to annotate the whole function, or if it needs to just annotate a small section of it. So yeah, just kind of be aware of that for doc strings, is that they're generally, if you're writing code internally, not really going to be used. And also it's because, it's a pain to maintain them, because, if code changes, you need to just remind yourself to go back and update them, because there's nothing worse than having a function that does something A and a doc string that says something different B. And now you have a conflict, and the documentation that you're supposed to have written for it is no longer up to date and is no longer even accurate. And so you're just adding extra confusion. So yeah, again, follow good programming styles, have clear, succinct function names, clear variable names, and make it obvious what your functions are doing by using internal functions and stuff like that. And for example, even in this case, like we could break this up even more if we wanted to essentially have this sort of like updating process somewhere else. Although I wouldn't necessarily do it because our function is already so small. So this kind of length is okay. But my point being that if our functions grow longer, if they ever grow longer, there are small segments. And again, in this function, it doesn't really make sense to split anything out, in my opinion at least. But as our functions grow larger, we can actually take out smaller chunks that hold, have different responsibilities, and put those into separate functions. And with the function name and with the function input parameters and output parameters, it is extremely clear what is going on. And it's just, the details of what is going on are in the function. You can look at them if you want to, but otherwise the function name itself describes what is happening, right? So if we had a function that's like transform names or standardize usernames or something like that, and we get some updated names from it, then probably like what happens inside is like first names and last names are capitalized, and like weird characters are removed, or whatever. All of that is like implementation details that if we want to, we can look into the function. But what we'll know is the return parameters that we're going to continue using are going to be some cleaned up names that may or may not have been cleaned before they came in. So yeah, again, always like documentation, doc strings here, and comments are never going to replace good function names, good variable names, good succinct structure, using proper classes, and just having a general good programming style. Because if you do that, you're essentially already documenting your own code by being very clear and descriptive about what is going on, that most of the time comments and documentation are not even needed. So yeah, I just kind of wanted to make you aware that doc strings exist. This is how you can start doing them. If you ever need to write in-depth doc strings, I would definitely recommend just looking at some examples, looking at some trying to find a library that uses them. Try to just look up some examples online also, just Python doc strings, and see how different people format it, because even this format that's auto-generated for us, I've also seen different formats online. So yeah, just being aware of that. But yeah, so this is what we have about doc strings. And one thing that is kind of helpful though is if we have a doc string, for example here, the create update user, we're using it here. So one thing that we can do is we can access the doc string of, in this case, a function by just looking at our function, doing dot, and then underscore underscore doc underscore underscore like this. And this will actually print out doc string of like this. And I'll create a new line here so that we have better formatting. And then let me go ahead and pull up our endpoint here, and also go ahead and refresh here to update. All right, so yeah, one thing I also wanted to quickly show you is you can see here when we go to the get endpoint, the doc string that we've created is actually part of our documentation that's generated for us, which of course is very nice as long as we keep it up to date. But we can see here already like the parameter description is in terms of like the types is already in some sense duplicated here. But having some sort of description here may or may not be useful, especially if it's like, if you're using a string input, then you may want to define what exactly is the user ID in terms of string. Maybe it's some sort of hash that you're using, and then you're like, oh, okay. So in those cases, it can be helpful. But anyway, going back to, and now I need to check the user endpoint. Okay, so that's the one we added docstring. So, and this is the post endpoint. Yep. All right. So let's go ahead and try it out. And I'm just going to send it exactly like this. We get user ID 1 here, but let's take a look at the output. So we can see here the doc string. So this is what we printed out here. And this here is actually the doc string that we've written for it. And so we can access it like this to print it out, which is exactly what we have here. Nope, not there. Exactly what we have here. Yeah, so the documentation or the doc string here is actually a specific format that does become available in a special attribute of, in this case, the function, but we can do similar things also for classes, defining it at the very, very beginning after we have the class definition. So right after the class definition, we will then have it. We can also have it inside of the init method, the special method that we use for the class initialization, as well as within special methods that we write within our classes. So within each function, essentially within our classes, also at the top of program files to add documentation when we get to modules. And we've kind of used modules, for example, here by importing specific like libraries and modules. But we'll also see when we go over program structure, all of that will hopefully make a little bit more sense, the importing and referencing that we're doing and stuff. So yeah, this is, doc strings, and I just wanted to expose you to them so that you've seen them before and you can think about them and you know what their purpose is, and at the same time, give you some little notes about the usage of them, as well as comments, and just, always thinking about proper coding structure first. All right, so now I want to talk a little bit about how we can actually change some function signature here to, or not even signature, function definition, how we can change the definition of our function here based on different processes that we're running. And what we're going to talk about now is going to be asynchronous functions. Now, we're not going to go into too much depth because I have a whole nother several hour-long section about concurrent and parallel programming in Python that also covers asynchronous programming. And so obviously I'm not just going to repeat all of that, but I do want to give you the general idea because you'll see this very often in Fast API. But then obviously, when you do get to that, you'll have a more well-rounded understanding of concurrency and parallel programming in Python. But yeah, so let's get started with it. In Python, we have this very cool option to define functions as asynchronous functions. So what does that mean? Well, it means that essentially our functions have the time to do some work, and then when they're waiting, for example, they're sending data to a database or they're trying to get data from some other API or whatever, but our function is currently waiting, then it can actually give up control to other parts of the program that are running. And so the simplest example could be, let's say that we have a function that just sends a request to, a single API somewhere, maybe to look up a user, like this one. And let's say that we want to do this for 1,000 users at the same time, or as close to as at the same time as possible. One way that we could go about this is loop over the user IDs and do it one by one. But that's not going to be very efficient because most of the time that we're spending is actually the network time to send the request to the server and then waiting for it to come back because there's not much else that's going on. And so what we could do instead is we could start with the first user, send the request, and now that that function is waiting because it's just sent a request, so it's waiting for the response value, we can go on to the next function, and then we continue on until we hit a blockage, which is sending the request, and then there we check, okay, so nothing has come back yet, so we're going to go on to the next one, and 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 then ultimately we can just start sending out a bunch of requests, and as work comes back, we can then continue on with it. And so that way we dramatically reduce the wait time because we're not just sitting there waiting idly while we're waiting for a network response, but rather we continue on with other work. And so essentially in very, very short sequence, we send off all of the network requests and then we get them back and then we continue on doing all of the work and our whole execution goes a lot faster. And that's because in this case, in this example, there's a lot of idle time. Now, if we're writing APIs and if we're using outside services, be it an outside database, an outside cache, which we'll learn about later, don't worry about those terms, or even outside other APIs, we can have a lot of time where we sit around doing nothing. Not any computational work. And in those cases, it would be great if our API and our server can go on to do other things and is not blocked waiting for this one value to return. And so that's why asynchronous functions kind of play their role. And we can define asynchronous functions very easily by just putting the async keyword in front of the function that we want to define as asynchronous. So now this function is defined as asynchronous, but it's not really going to do anything yet because there's no component here that, once we hit a waiting point, we're essentially going to be waiting. Right now we've just have an asynchronous function, but we need to essentially further define the points where we want to have this waiting behavior implemented. So the next place to do this would then be in the get user info. And let's go to our function definition here. I can actually just control or command click on it. All right. So now if we want to use this as an async function and we want to have the async functionality within this, again, here also we need to define this as async. So now this is going to be defined an async function, which means we can use the async behaviors inside. So right now, obviously, we're just reading from our dictionaries. But later on, here, we could be instead reading for a database. So currently reading from dictionary, later read from database. And so what we'd be doing in this case, in the database, whoops, I didn't, supposed to be a comment. In the database case, is here we can wait, because here we would be sending a request to the database and then we would wait until the database finishes processing it and sends us back a response. And so here would be one of these points where we can do the waiting. But we can only do the waiting if we're inside an asynchronous function, so we need to define the whole thing as asynchronous. Now, one thing to note when having asynchronous functions is that when we use them, we can no longer just call them like this, because this here is now actually a coroutine. If we define our functions like this, we now get a coroutine, which is a task, or, well, you can think about it like something that we can, schedule to do work with, but essentially just, nothing is being run yet. So, yeah, we have this coroutine definition here, but coroutines in Python syntax can't just be called like this, but they actually need to be scheduled in essence. And we can do that by putting this await keyword in front of it. So whenever we have an async def, if we call it, we need to make sure we use await beforehand. Otherwise, we're not going to be calling it, we're just going to be referencing it without executing it. So if we want to call and execute it, we have to use this await keyword. And similarly, we can use await, or we have to use await here now, because we're using the get user info here. And I think we're also using it in one more place here. So here now, we also have to do await. And in each of these cases, if there is because we're awaiting here, and if we do have a database thing, we would also have something like await and then get user from DB. I don't know, something like that. We probably won't have like a separate function here because this function should already take care of that, but we can do something like, like DB read whatever. Just some like pseudocode here, not real code, but just, essentially the essence of what we want to do. So we're going to await this reading from the database. And so here we now have this breakpoint where we can go on to do other things. But this only works if we have asynchronous functions. So now in this endpoint here, this endpoint is defined as asynchronous. But this one, for example, is not. So if we call this endpoint here and we call this one, then this one is going to finish its work first, and then this one is going to go, because this one is not asynchronous. And so there's no point, there's no part of it where we do the waiting. If we call this one, what will likely happen, and this one, in that order, is we can start here, and we will start our work, and then we will call this one, we'll have to finish the whole thing, because there's no waiting component, and then we will have, by then, already long received the response, and we can continue with this one. So obviously, anytime we do anything non-computationally expensive, but anything that is bound by network I/O, we want to use asynchronous functions. And obviously, we want to make sure that we use them at the lowest level, where we actually have to do the network waiting, because this function in and of itself doesn't do any network waiting. The only network waiting component is really here. If we send the request to the database and wait for it to respond. That's where it happens. But to be able to use it, we have to essentially put it, to be able to use the waiting here, we need to have an async function here. And to be able to read from an async function, we need to be inside an async function. So that's kind of how it like trickles up. So yeah, just being aware of that. And obviously for all of these, essentially, we will want to implement them as async functions. So yeah, let me just go ahead and just put an async def in front of each of these, more so for, just like having that syntax there, although, everything that we do is not asynchronous because we're just reading from internal data structures, dictionary in this case, and converting things around. So everything we're doing is actually currently like CPU bound because everything is done on this machine, nothing is going out of here. But, let's just do it anyway. And all of these things we will essentially also want to have be defined, right? Because here we would send delete requests to our database. So this should be asynchronous. Should be asynchronous. Should be asynchronous because in all of these cases we'd likely be reading from a database. And yeah, so now that all of these are asynchronous, we now, when we use them, we have to make sure we use the await keywords. Otherwise, they won't be called. Like this. All right. And like that. And I hope that's all of them. Let me just go ahead and check. Let's see. Probably should have done this one by one actually, but oh well. Yeah, that's looking good. All right, so it looks like we have all of our conversions covered in this case. So we've switched them over to asynchronous. And yeah, so this is kind of the asynchronous portion. Obviously, unfortunately, we haven't done the database part yet, so we can't really get to, the asynchronous step in our database connections, the sending the updates, the sending the request to read from a specific user. But that's really where we'll see the performance benefit, because essentially our whole endpoint here is just communicating with the database and doing some logic beforehand, afterhand maybe, but communicating with the database. And so all of that database waiting time from the moment we send the request to the database does its work internally to the point where we get the response back to our server. All of that waiting time we could instead spend doing other stuff. And that's what this async def allows us to do. And I'm just going to run this to make sure that everything here at least starts up properly, which it does. We can test these endpoints, but I actually also just want to show you this in a separate file. I'm going to do some async test.py here, where I'm just going to quickly show you some of this stuff. All right, so let's have a very simple function. We're going to call this sleep a little, and we're just going to have some time to sleep here. I'm not going to do any typo notations or anything. And then we're going to have another function that I'm just going to say go do something. And this is just going to call this. And I just want to show you some of the syntax and why we need to have like certain things the way they are. Okay, so the first thing that's actually interesting is when we write an asynchronous program, and you'll see this when you do the asynchronous, the concurrent and parallel Python course, is we can't just call this, unfortunately, outside like this. Unfortunately, this actually isn't going to work, but I can show you Python async test. So it says here we're using await outside of the function. Okay, well, great. Now what? How do we call this? So to actually call this, we need to import the async IO library, and then we can do async IO.run, and we can run this coroutine here. And then I can hit enter. Now we're seeing we're going through the steps. So we're calling this, we're going in here, we're calling this, we're not actually doing anything in here. What we could do is we could do a time.sleep, but this is actually not asynchronous. So this time module allows, as the name suggests, control over certain time aspects. For example, we can get like the clock time, or in this case we can essentially have like a pause period where our program sleeps, so just pauses for a certain amount of time, in this case 1 second. But actually this is not asynchronous, and so if we called this, there would be no point where we can continue work. But if we use an async io.sleep, this is actually asynchronous. And in this case, we will have a pause time where when we reach this point, our program can go on to do other things. We have to await this because it's a coroutine. And if I'm going a little bit fast, again, this is more, the big picture to get from here is async functions if you have network bound IO. And right now I'm just trying to show you the syntax of why we need to use async def, why we need to use await here, and what happens when we don't use them. But for going into much more detail, there's a much longer course on this, which obviously there's no point in repeating all of this now. All right, so running this, we now run it, we sleep for a second, which is what we do here. And at this point, we essentially give back control to our program to go do other things. Right now we're not doing anything else, so there's nothing else to do, but at this point is where we would do it. So if we didn't have an async def here, then we're going to run into an issue because we can't use await when we're not in an async function, like this. And so that's kind of, and we can't call this here without using await. So you'll see, remember, it took about a second last time because our program essentially slept for a second. We run this, bam, instantly done, or I guess in this case even an error. Oh, okay, because we're calling await here. So let's put that back. And yeah, so we can see here we're getting a warning that our coroutine sleep, which is this one here, was never awaited. So we can see it went really fast because essentially no work was done. But if we await it, then we actually call it, we invoke the execution of it. Now it takes about a second to finish. So that's why we need the await here. Otherwise, we're not actually calling it. And so yeah, similarly, then we can see, okay, when we go up, so we need await here. Okay, so to have await here, we need async here. Okay, so now we have async here, so we need await here. Oh, okay, now we have await here, so we need async here. So that's kind of how it trickles up, and is also why these async def definitions have to be on the very outside, because we need to use await, because inside we need to use, because here we use an async, because inside, not here, although here too, but we left the comment here, we would want to await the actual reading of the database. And they're not just one point, there's not just like one line of code that we could await. Like if we do several database steps in here, like 1, 2, 3, with like split up, each of those steps we could await, and each of those could be potential or not potential, but actual pause points for our program to give control to other pieces of code that can run in the meantime while we wait for this piece of code to get the information that it needs to continue doing work. So yeah, that's kind of the async component, and if you're going to take anything away from this, just remember that async is used when you have network bound IOs, so when you're spending a lot of time just waiting on things. If you have CPU bound tasks where essentially you're doing a lot of CPU intensive work on your machine, async isn't going to help much, or really isn't going to help, because everything is based on the CPU, and there's no benefit from giving up control at some point and letting other things do the work, because this thing just needs to do a lot of work. But if we're just spending a lot of time sitting idly waiting for data to get passed around, then async can actually do wonders for us, because we can give back control and do other things in the meanwhile. So one final question that you may or may not have is, if we need to do this async io.run here, why don't we need to do it here? And for that is actually why we have Uvicorn. So Uvicorn actually takes care of this whole asynchronous process for us. So when we launch our application through, which we've defined here right now, it will actually start this whole asynchronous process for us, and it will take care, like get that whole thing started, and the triggering and scheduling and dealing with all of these asynchronous tasks, or coroutines that are now running that are awaiting different things. So Uvicorn is, in that sense, extremely awesome, and it takes care of everything for us. For that, if you want to read up a little bit more on what exactly it is, you can either look for Uvicorn, or you can also look for ASGI. That's going to be our asynchronous web server gateway interface, I think is what the acronym stands for. But yeah, if you're interested in like learning a little bit more about that, then I would just recommend either looking for Uvicorn or ASGI, and there you'll find more details about what exactly that is. But for all intents and purposes, for us, the async starting of the async process and handling the actual consumption of the event loop, which again, more details in the concurrent and parallel Python course. All of that is taken care of for us by Uvicorn. So it's an extremely awesome tool that we can use, that, here we can code our application, and Uvicorn can just take care of all of the other stuff that, is required of, getting data in and out, and making sure it goes to the right places, the right code is executed, and also, and now handling the asynchronous functions and making sure all that scheduling is done properly. So now that we've gone over a lot of the basis of our API structure here, it's time to take a little bit of a look at the whole structure of our project. And that's what we're going to focus on now, is just updating our structure so that our project here has a proper format. I'm also going to delete our async file that we've had previously. And yeah, let's get to it. So the first thing to note here, and the motivation here, is if we start looking at our file, this basically contains everything, right? Like it contains our models that we have defined here. It contains our routes that we have here. It contains some like helper functions that we have that do the work for us.
So yeah, basically it contains everything. Right now it still fits into like 150 lines of code, which is great. But obviously, this is a very, 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 very small application right now. And if we actually want to make it grow to be able to do a lot of stuff, then, having everything in a single file probably is not the best idea. So we're going to add some structure to all of this. So the first thing that we're going to do is create a new directory. And I'm going to call this app for our application. You can call this whatever you like, but generally I've seen app kind of be the standard here. All right, so within app, I'm now going to create several different files and directories, and I'll show you or explain to you what each of them does in a second. So I'm going to start out with creating a new directory that I'm going to call routes. Routes is going to ultimately hold all of these endpoints that we've defined here. I'm going to create another directory here called schemas. And schemas is going to hold all of these models that we've defined here. You could also call this models. You can kind of go between the two. I actually like to reserve models for database models, which is something that we'll look at later. But yeah, so schemas for this type of stuff here. Then I'm also going to have here services. And services is going to hold the code that kind of does like this helper functionality here, like this one. And then something that I like to have sometimes that we don't need right now is sometimes I like to create a helpers directory, and a helpers directory will contain a class that is essentially a helper class to make everything easier. For example, if there are certain things I always want to do with a database, then maybe I will write a special class, and every time I want to insert something to a database, but do something before and after, I will put that in a helper class that helps. It's like a database connection, and there, you can then use that class to do database operations, and it will basically always do the things that you want before and after, so you don't have to repeat it everywhere. In this case, right now, we don't need a helpers yet, but just be aware that sometimes if you do want to have something that you reuse, that you want to reuse across maybe multiple services that you have here, then putting that in helpers may be a good place to have it. In addition, here I'm also going to create a config.py. And here I'm going to define our config class. Right now we don't actually have a config, but nevertheless, this is where this will go. And finally, what I actually need to make all of this work is I need this underscore underscore init underscore underscore dot py file. And we don't actually need to put anything in here if we don't want to, but this is a special type of file that we can have within our directories here, within our folders here, and this is actually what makes right now our app here a package. And I'll show you in a second what exactly that means and why we need this one here. All right, so first of all, and I'm going to show, I'll show this to you in the sense that I'm not going to do it first in these three folders, and then I'll show you what happens when I don't have it there, and I'll show you what happens when we do have it there. So I'm going to start off with the routes, and here I'm going to create a user.py file because this is going to be all the routes for our user. So I'm going to go into our main, and essentially what I'm going to start off doing is I'm going to just take all of this, I'm going to cut it, and I'm just going to paste it in here for now. Now there's a lot of things that are underlined red here because they're missing right now. The create update user function, for example, that we have defined here is no longer available here. Similarly with all the models and all that stuff. So this is stuff that we'll fix in a second. Don't worry about that. But the first thing I'm actually going to do here is I'm going to say from fast API, I'm going to import an API router. And then I'm going to initialize a new variable called user router. I'm going to initialize it to be an API router. So what is this?
So previously, if we look at our main file here, we've just created an application. And then for each of our routes, we essentially used our app here and, we've added the routes to it. Now the thing is, it's not very good for us to just import the application everywhere and do this app.get, but instead it would be good for us to define different groups of routes that we have. And that's also why the name here is user.py. This already indicates that everything in here, all of these routes, are going to be specific to user endpoints. And so in this case, and we can define, and I'll show you in a second what that looks like, but in this case, we're going to have a special router where we can define a subset of routes that we can then add to our application. And if that sounds confusing, don't worry about it. Once we actually implement it, I'm sure seeing how it's used, it will make a lot more sense. But in this way, we're better able to separate the different functionalities that we have. For example, we may have users, and we may also have like a products route and maybe like a company's route, or whatever, like different types of features, spaces that we may want to serve. All right, so we have our user router here. Now, the thing that how we're going to use it is we're actually going to replace all of this like this. So instead of using our app here, we're just going to use our user router like this. All right, and now in our main here, in a second, we want to, and I'm going to put this note here, we want to add our user router to our application so that we can actually register all of these routes here that we've created with our application, because right now they're not connected to our application in any way. We want to be able to register them with them. But again, we'll get to that later on. So next up, and I'm just going to kind of do all of this and restructure it. And then with the restructuring, I think it will become a little bit more clear why we're restructuring it that way and how it works. So yeah, the next thing I'm going to do is I'm going to take all of our models that we defined here, all of our Pydantic models, and I'm going to put them in schemas. I'm also going to call this user.py because all of these models are specific to our user, like this. Now what we need to do here is import this. Now actually, I can just take this, like cut it, because we no longer need this in our main, because all of our base model and field usages have been moved into our schema's user.py file here. You'll actually see this because the import is gray, which means it's not used. So I'm going to cut this and paste this import here. And the nice thing is there's actually nothing else required of us here. So all of the dependencies that we have here are already imported, which is very nice, of course. So everything here is kind of good to go. All right, let's go back to our main file here. Now we have the remaining portion, which is essentially our helper functions. So I'm going to go into services, and I'm again here also going to create a user.py, and this is going to be our user service, and for this I'm going to create a class. For now I'm just going to call this user service. This name may actually change with time because I don't think user service is necessarily the best name, but that's how it is for now, and maybe once this functionality has a little bit more purpose, maybe we would update the name. But yeah, for now I'm just going to take all of this, including this stuff, because right now we kind of need this for the functionality, and I'm going to go into our user service here. I'm going to paste this over here. This, because these are supposed to be global variables, I'm just going to take out, and I'm going to put these over here. Again, these are not supposed to be real things. Right now we're just using them because we don't have any database connections. And so that's kind of like why I'm just putting them here. Okay, so let's see, what else do we need? All right, so we have a user service class here, but now it's a class. And so we can see already from the highlighting, it kind of assumes this when we have class methods, it will assume this to be, the class referencing itself. So one of the first things we need to do, obviously, is put self here. And obviously something that we also need, or usually have for classes, is some sort of initialization method where for now I'm just not going to do anything, so no initialization required at the moment. If we do want to have any sort of initialization, then obviously we will put that here like we've learned in the classes lesson. So I'm going to update this. I'm going to put self in front of here everywhere. And let's see. Actually, let's take a look at this because we don't actually need self everywhere because we may not always be referring to class attributes. So taking a look through this, this here can actually be a static method because we're not referencing any property of our class. Also going to remove these comments like this. And this here, to me, also looks like a static method because, again, we are, oh, no, we do have the get user info, let's see, which is this one here. So we are referencing this function here. So this cannot be a static method because we're referencing another class function. So I'm going to put self here, and to refer to that method, I'm going to do self.getUserInfo here. Let's take a look. This looks like it can also be a static method because we're not referencing any class properties. And finally here again, we can also have a static method. Now one thing that I'm going to do is I'm going to take this, get user info, and I'm going to paste this below here, just so that the function that we're referencing is kind of defined a little bit ways further down. That way we have a good sort of ordering because things that depend upon other things are going to be found a little bit further down in the file, and it just adds for some sort of consistent ordering so that it's easier when these things grow that you know where to find things. All right, so in terms of imports, first of all we need to import optional from typing. So we can see here, just take this over if we want to. From typing we need to import optional. And now the other thing that we need to do is we need to import all of these schemas that we have defined over here. So how can we do that? Well, ideally, what we want to do is we want to say from this file here, we want to import all of these things. Just like, we've imported this like base model and field from Pydantic. And at this point, actually, hopefully it will become a little bit more clear also how these import statements work. But what we want now is we're in our services here, and we want this full user profile from here. So the way that we can go about this is we can say from, and now we're going to define from our kind of top level downwards, we're going to say from app dot, and now you can see, because we have this init file, it actually has indexed all of these different directories and folders. So we can see here it already suggests the config file, which is this one, as well as the service routes and schemas directories that we've created here. So our interesting components lie in schemas. So we're going to say from app.schemas. However, when I try to import from here, well, my IDE has indexed it now, but we'll see in a second when I actually try to do this, it's not going to work. When I want to import from here, and I want to import the user, I want to import the full user profile, I want to import actually the multiple user response I don't think we use here, and I think the create user, no, we don't need that either. So these are the two I want to import. Or do we not even use the user here? Let's take a look. No, it seems like we don't. So actually we don't need to import this either. So then we can just do a simpler structure like this. The quotation mark, the parentheses structure that you've seen me use previously is just a way to make this look cleaner when we have multiple imports, but if we have a single import, we can just use it like this. So what we're saying is from our top application structure, from here, we want to go into schemas, we want to go into user. Now this could either be a directory or a file, and as we see looking at our import here, this is a directory, this is a directory, this is a file. Python will figure that out for us. We want to import this. So we're going in here and we are importing the full user profile like that. So that's what this syntax here means. And as a quick side note, when we do something like this, you can now see this has a very similar syntax. We're going into the Fast API folder, and there we're importing the Fast API class, which is available in there somewhere. Usually, I think in this case, it would probably be available or like done in this initialization file. I'll show you that later on too. But yeah, just as a quick side note there. And if we go into our routes, we have a similar thing from the Fast API folder. We're importing the API router. And now here we want to do the same thing too, because we're seeing we need this stuff. So we want to say from app.schemas.user, we want to import the full user profile. We also need to import the multiple user response. So now again, I'm going to use this parenthesis structure, open and close parentheses, put this on a new line, comma afterwards, multiple user response, have an index here, have an indent there. What we also need is, let's see, the create user response, and also, do we need the user? No, it looks like we're not using it because it's grayed out. And then we're also going to order this alphabetically, create, and then F, and then M, C, F, M. So we're going to order this alphabetically too. Later on, we're actually going to use a package for us that will do this whole cleaning up. But right now, just as a quick note, when we're doing these imports, this is a nice structure to have when we have multiple imports, parentheses around it, and then every import here indented and a comma afterwards. Makes it more readable rather than having everything on a line and just kind of all over the place. All right, so that's the one component we need. The other component we need is having access to this get user info. So what we need to do also is from app.services.user, we need to import the user service. Then we're going to initialize it, the user service, like this. And now to use this get user info, it's actually part of the user service. So we're always just going to, use our initialized version of the class, like this. Like that, and here too, like this. All right. So you may be wondering, okay, why make this a class? Why not just have this a bunch of like free floating functions? It's just because as a class, oh, we do need user here. As a class, it's a little bit more structured, and related things are grouped together when we all put them in a class rather than just having like individual components here. And if we ever need to share any attributes or share any like functions or something like that, it becomes a lot easier to manage it all within a class. And again, this just helps us also conceptually group that all of these things should be together. They're all part of like the same sort of responsibility that we're going for, which is handling users in our application. And so that's why they're all in the same class. And in addition, the other benefits that we get from using classes is if we ever need to expand this, then we can use class inheritance, and we can add new class properties if we need to, and reference them. So there's a lot of just benefits that we get from using classes here versus just using individual free floating functions that would otherwise just look like this, like we had it before in the main file. So yeah, okay. So let's see, we were in our routes. So we've imported the user service, which is this class that we've defined here, which holds all of the functions that we've used previously. And here, we initialized it, and now we're just referencing the initialized, we're just referencing the methods of this initialized class here, everywhere. Okay, so we have our imports settled here. And let's just go, our schemas should look okay. Yep. and our services. Is there anything else that needs to be done? Let's take a look. It looks to be okay. All right. So now we can go back to our main folder. Here we initialize our application, but one thing that we still need to do is we need to add our routes that we've defined here, because currently they're not linked to our application in any way. So what I'm going to do is I'm going to say from app.routes.user, I'm going to import the user router. And this is the router that has all of these apps associated to it. And then what I'm going to say here is I'm going to do app.include a router. I'm going to include the user router that we've imported here. All right, and I'm going to take out all these lines because there are a lot of new lines that we don't need here. And with this, now we are adding all of these routes to our application. So now let's also quickly talk about this init file here. So the init file initializes our here app directory as a package. And essentially what happens when we call, for example, from app.routes.user import, when we go into our app here, our init file here is executed when we do the first import. And similarly, if we were to just go into our apps.routes here, then we would, if there was an initialization file here, we would execute that and also execute this one. So what does that mean and how can we make use of it? So for example, if we try, or if we just look at this case actually, we can say here from fast API, we want to import the fast API class. But the thing is, the fast API class is very likely not defined somewhere on this top level and made so easily available, because right now we don't have this option to import our user routes in this way. So the way that we can use our initialization file, for example, is going into it, we can say from app.routes.user, we want to import the user router. And now what we can do here is instead from app, we can just import our user router because now it is actually available at this level. And so when we call this from app import, this here is actually executed for us, and this user router is directly available at this level. Or, and I'm going to put initialization files into all of these, we could do here, for example, from user, we want to import the user router. And then something that we could do here is we could say from app.routes, we want to import the user router. So as soon as we go into routes here, we're going to execute this initialization file as well as this one. And going to add a new line at the end of this file here. And so then our user routes here is available to us directly like this. And it can just help us with better organization and better structure and imports if we want that. And so generally, I would add initialization files to every directory that I create. So when you have a package, I'll put an initialization file at the top one, as well as ones within each subdirectory, or now when we have an initialization file here, a sub package that we have within our main application package here. So yeah, taking a look, if we want to actually into our fast API library, I can do this by just command clicking on fast API, and we can see here, looking at the top structure here, this fast API is actually included in the applications.py, and we can see here this definition is massive, just a very large class definition like we can see here. But if I actually click on here, go into the initialization file, expand this, we can see here at some point, fast API class is imported for us. And you can see here they actually use an alias, and this way, if you want to, you can assign a new name to whatever you're importing. So for example, what I can do, and I'm just going to close this up, going into our user here, I can change our name from user router instead to a router, like this. and use router in each of these places like this. And then when I do the import here, I can say, for example, from user import router as user router. So now I'm giving it a name. And that way, if we have a router defined in multiple places, for example, if we have another file here that we can call, I don't know, say we have companies here, we can say from companies import router as company router. So we can use the same variable name in different files, and when we do the import, then we can actually rename them if we'd like to, or actually just give it an alias. So give it a new name that we're going to use to reference it with. So I'm going to undo this because I like having my name explicitly here. And there we go. But yeah, just some notes of things to be aware of. I'm also going to remove this and just keep our initialization files empty. All right, so we have to go back here from apps.routes.user. We need to import the user router. All right, so let's go ahead and make sure this actually works. We're going to unicorn main app reload, refresh our documentation page here. All right, so everything is still running properly. I can run a test here using the default values, run a test here, make sure things are working properly. Maybe also run a test here, get user with ID 0. So yeah, everything is still running properly. So now we've just kind of reformatted everything into a much cleaner structure so that nothing gets exceptionally big, and it's much easier for us to keep an overview. Now, some small changes I'm still going to make is I'm actually going to, rather than leaving this as individual functions within the file, I'm actually going to make a function here that is called create user router. And what this is going to do is it's going to create, or using the typing, it's going to return the API router for us. So it's going to create this router and it's going to return this like that. And then what I'm going to do is in our main application here, I'm going to import create user router. And also what I'm going to do here is I'm going to create a function called create application, which is going to return a fast API class. And then I'm going to say our user router is equal to, and we'll call our create user router like this. And then we're going to return our app. And then I can say our app is equal to create application. So this is called an application factory pattern, where essentially we can use functions to create instances of our applications, of our routers, and later on when we have configuration files and services, well, with the services we actually already do a similar thing because we have our class here. So now you may be wondering, all right, so why would we do this? And I'm just going to fix the formatting here real quick. Generally, later on when we look at testing, it becomes really nice to have this option to be able to create routes and applications in this format, because that way we can also add mimicking to certain behaviors. So if we were to provide at some point configurations here, then when we actually create a application that we want to use for testing, maybe we want to use testing configurations that we can just easily pass in. And with that, we can then create a version of our application that has the specific parameters that we want. So yeah, for reusability and testing, having this sort of application factory pattern is what it's called, is just a lot more convenient. But yeah, so with this, and let me just run this one more time. Yeah, make sure it starts up properly, which it does. So with this is kind of the now refactoring of our order of our directory structure here to make it into a much more proper structure where things are properly separated. We can see each of our files is relatively small, which makes it easier to get an overview of what is actually going on. All related things are actually grouped into one location, and we have proper things being imported across, and we can reuse everything. And yeah, it just makes for a much nicer structure that is much easier to overview as your application grows, because different things live in different places, and whenever you need to make a change, you can just go into that specific folder in that file or that directory, make a change there without having to scroll through hundreds or thousands or tens of thousands of lines of code, depending on, how large your application actually gets. So now that we've restructured our whole application, I want to take another quick look at the routes that we've defined here, and specifically at the API router, because there's also some cool stuff that we can do. So currently, our documentation page looks like this, which is nice, right? We have our routes here, we have our schemas that we have defined, the response schemas. So that's really nice, as well as the input ones too. But there's actually some more cool stuff that we can do. So first of all, what I'm going to do is I'm going to remove this endpoint because we're not really using it. And the first thing I'm going to do is make everything here a lot more generic. So we can see here a very common trend is that we start with like /user, which we do in almost all cases except for here, where we start with /users. So what I'm going to do is I'm going to transform these to essentially also work with /users. So our paginated here, I'm just going to do this instead of /users, I'm going to do /user/all. And for our add user, I'm just going to do here /user, because if we look at the post, we actually don't have a user endpoint for post. So now we actually have this trend where everything starts with /user. So instead, what I'm going to do, rather than repeating this everywhere, is I'm going to define on the router level a prefix. And our prefix for all of our endpoints that are included in this router are going to be /user. So that means I can now take this away. I'm still going to have a slash here. But we'll see in a second the effect that this has. Taking this away, taking this away, and here I'm going to take /user. Technically it would be /user/, but I'm going to take /user away here. All right, so refreshing our documentation, we can now take a look at these are endpoints. So we can see each one in our user is actually prefixed by /user. But we don't need to include it in every single one here because we directly tie it to the router, and so the prefix is automatically added. You can see if I change this to something like this, all of our prefixes here are going to be updated. And again, this is really nice because obviously everything that's related to users will be, kind of grouped together. And so that way, if we use the same router, all of the connected endpoints will have the same prefix. And that way we can also more easily separate between different functionalities. And again, just making sure that some of the stuff works, we can execute this here. So this works, and this works. All right, nice. And we're not going to do this all the time. At some point, we're actually going to look at tests that we can write so that we can run the tests to make sure that changes that we do didn't break any existing functionality. But for now, the way to kind of go about it for us right now is just manual verification. But we can see here now, this again is a lot more clear because, we're able to, have all of these prefixes here together. Taking a quick look at this, it seems like there was a error response here. So let's see what's going on here, /user/all, execute this. So it's complaining that the user ID value here is not a valid integer, which is true. Because we should instead, we have a get somewhere up here, I believe, yeah. So we should put this on top here. So that way, if we have the /all, we evaluate this one first and this one second, because right now we will always try to match this one first. This is the same case that we looked at earlier with the /me. So let me retry this one more time and try it out. Okay, there we go. So it's working properly. So again, a similar thing that we talked about previously, where we always try to match in this order. And so because we want to match a specific case, which is the /all, we want to get that up here first, rather than having the general case here where it tries to put all in here as the user ID, and then it complains that the user ID is in fact, that all is in fact not an integer, which is obviously completely correct. All right, there's some more cool things that we can add here. Specifically, the thing I want to show you is tags. We can add a tag here, for example, user, and if I'm just gonna put this here on new lines to just have the formatting be more readable as we add more and more things. This is what we have now, and if we now refresh, we'll see here now we have the user tag instead for all of these. So this again is really nice because as our application grows and we may have different routes, we can group them into relevant tags. So we can have like users, we can have, I don't know, products, companies, whatever else, we want to have in this API service. We can group all of them together in tags, and that way it's much easier to see when you're using the documentation which things are in what group. And again, for organizational and reading legibility purposes, all of this just becomes a lot nicer. I'm going to add a comma here just to kind of make it nicer formatting so that we can always add a new line and comma afterwards. All right, so yeah, as we can see here with the router, again, it allows us to just be more structured about our approach, and it allows us to group relevant things together by putting them in the same router, and then we can further define properties about them by setting these properties on a router level, which again has the advantage over just including this all with the application, because if we put all of this directly onto the application, we would have to set these things on a route by route basis, whereas now if we use specific routers for specific subparts, we can define some of the stuff on the router level, and so that way we don't have to repeat it later on within each of our endpoints here. All right, so we've gotten to a pretty good place now, and I want to take a look at this config file. Although we haven't, and we're not really going to use it just yet, because again, we haven't looked at databases yet, I do want to take a look at environment variables, because in some cases you may already want to be using some of those, and then once we get to databases, we can kind of fill this stuff in, but already looking at environment variables now because they are kind of common in just a general kind of base application structure. So what I'm going to do in our config.py here is I'm going to make a class that I'm going to call config, like this, and I'm just going to define individual attributes here that are going to range across the whole class. So for example, what I'm going to define is going to be a database host, which can be whatever. Then we can have, for example, a database username, which can be whatever, a database password, which can be whatever, and then we can have like a database table, again, which can be whatever. Don't worry about these things so much right now, just, essentially just like a login credentials of where we can find this database, and then some login credentials, and then this we can actually take away and we'll probably add later. So just, think about this as some sort of like login information now. Now, generally, what you don't want to be doing is you don't want to hard code this stuff in here. This is generally bad for multiple reasons. One, it becomes much more difficult to change because if you hard code things, then you have to find it and update it, and you have to find first where it's even defined, and sometimes you forget that these things are defined, and so you kind of lose track of them. The other reason why you don't want to hard code them is because then everyone can just see it, right? Everyone, if you have your like your database URL here, mydatabase.com, whatever, and then your username and your password in here, then anyone who has access to your code can read all of this stuff, which is not always what you want. Generally, you want to have some sort of security where people who are authorized to see certain information are the ones who can see it. And so, again, you don't want to be hard coding the stuff because anyone who can see your code just knows all of this, secure information. And now, if you're going into a big company, there's actually going to be a lot of stuff specifically around like passing in the sensitive information, but we're not going to take a look at that because there are whole sets of tools just for that security. And instead, what we're going to focus on is we're going to have the option to be able to read this information in from what is called an environment variable. That means when we write our application, this is not going to be defined, but when we actually run our application, we can pass variables into the machine when we're starting it up, and then these variables will be defined. Now, I'm using them right now for the examples of, like some login credentials here, but you can use these for a large variety of things. And other examples where you may want to use this is, let's say you have like a rate limit that you want to define. It's much better to have this rate limit, which essentially means this is how many interactions, or rather requests, you can have from this API, per consumer, essentially, per second or per minute or per hour or whatever. You just want to be able to limit usage. All of these things that are configurable across the application should be defined as environment variables because it gives you so much flexibility to change them later. And so you want to stay away from hard coding any of these things that talk about configuring the application. Now, something else, and I'm going to remove this, something else that you may have also noticed is everything here is uppercase. So generally for environment variables, when we're naming them, the naming convention is very similar to variable names, except that everything is uppercase, which indicates again to the reader that these are environment variables. Okay, so again, how can we access these environment variables? And where can we even find them? Because these are not going to be defined in our application, but actually in the whole machine that runs them. So for example, I'm going to show you a test environment variable. And I'm going to do this on Mac, and this should work on Linux too. I don't think these commands will work on Windows, but don't worry, because later on we'll look at using Docker, and we'll run all this stuff inside Docker, and then all the commands will work the same because we'll all be using Linux essentially to run everything. But anyway, don't worry, we'll look at that later. Right now it's just more about understanding what they are and how we can access them. So in our Mac terminal here, there's this command called echo, which essentially you can think of just like the print statement we have in Python. And we can access a variable by using the $sign and then, for example, putting in the variable name, so test var. So if I try to print out the value of test var here, it's going to be empty because test var is not defined. But I can define our environment variable by using export, and then I can put the environment variable name, and then I can put in here the value, and var value, like this. And now if I run the same command, we can see here this variable now has a name, or now has a value to it. And so this is now, we've created an environment variable that is accessible on our machine outside of our running code here. And we can access this also in Python. I'm going to show you this first in the Python console. If we import the OS library to access features from our operating system, we can use this os.getEnv method. And here we can put in the name of the environment variable that we want to access. For example, test var. And if we hit enter here, we can see that we're able to get the environment variable that we've defined outside on our machine. And the nice thing about this getEnv method is if we use a variable that doesn't exist, we're just going to get a null value returned. So if we save this and we print out the type of v, then we can see here it's none. So this is really nice because if it fails, we essentially have a default value associated to it. We can also overwrite this default behavior by putting something here, fallback value. Now if we print out v, you can see if the environment variable test var2 is not defined, we fall back to our fallback value here. All right, so applying this to our conflict class here, first of all, what we're going to do is we're going to import OS to access these features from our operating system. I'm going to do a double new line here after our imports, and then I'm going to get our database host by doing os.getEnv db host, and I'm going to have this just be our fallback value for now, and then I'm going to have our username be os.getEnv user1. Oh, no, that's not what I want. db username, and similarly, I'm going to do this here, and I'm not going to provide any fallback values for these at the moment because I don't necessarily have any good fallback values for these. So now we are able to access environment variables, and our configuration values here are not actually defined within our code, but rather they will be defined once our application starts running because they will be read from the environment variables defined on the machine. And again, this is really nice because if or when we run our application on machines in the cloud, for example, then we can actually define the environment variables for that machine. And so once the machine spins up and the application starts running, we can easily read them. And just by looking at how the machine is set up, we can see all of the environment variables defined for them, and we can easily change them and update them without needing to change any of our code. And that's exactly what we want because it's the same code, it's just maybe a different username, a different password, a different database location, or any other types of configurations that you want to have for your application. All of those you should be able to set, and they should be very clear and visible on a higher level. So yeah, this is how we use environment variables. Again, right now we're not going to actually be using them anywhere because we don't have any database connections, but this is something that we'll get back to once we do implement some of the database stuff. As a quick side note, this OS library is extremely useful, and I want to show you a couple more things that kind of, going away from environment variables and everything, is just some cool things that you can do with the OS library. So, I want to import OS, and the first thing that's cool to do is using this get cwd command, which stands for get current working directory. And this way you can just know where exactly on your machine you are right now. Generally I use this, if you're kind of like prototyping and playing around and you're not exactly sure where you are right now or where parts of your code are being executed, you can just put this print statement there to understand your current absolute location on your file system. Something else that I also think is really useful is os.listdir, which lists all of the contents of your current directory. So we can see here all of these are things that are within our current directory. Some of them may not show up here, specifically with the ones with the dot in front of them, because these are hidden files, which, as the name kind of suggests, don't show up here unless they're special files like this git ignore, which is for GitHub stuff that we're not going to worry about now. But yeah, these hidden files may not show up in the visual component, but they are still there. We can see here we have our main file, we have our pip file, the pip file lock, and the pip file. We have the application directory. So this is really nice for one to kind of see, but sometimes also if you have files within a directory and those you don't know how many files you have there and you don't know what the file names are, you can actually do something, like this for file in os.lister, and then I'm just going to print out like the file like this, but obviously you can use this to then, for example, like read the file and do stuff on it. Which actually brings me to the next thing that I want to show you, which is obviously not everything is a file, right? So this app here is a directory. And so how can you differentiate between something being a directory and a file? Well, one thing that we can do is we can use the os.path subpackage, and we can say, for example, if sub os.path.is file, for example, and then we put in here the file, then we want to print out that it's a file. And if it's a directory, we can check that by doing elif os.path.isdir file. then we can print out here directory. And so now we can actually differentiate between files and directories, like we can see here. So we can see properly being able to differentiate between what is a file and what is a directory. And this is nice for one, if you want to process files and you want to do stuff with them, then obviously you want to make sure that something is a file first by checking if, it is a file by using this os.path.isFile. And otherwise, if it's a directory, one thing that I will sometimes do in my programs is if the directory does not exist, then I want to create a new one. So for example, I can do if not os.path.isdir my test directory, then for now I'm just going to print directory does not exist, just to show that it does not exist. But then actually what I would usually do is I would use os.makedir, so to create a new directory. And I mean, obviously you want to have this defined in the variable so I don't have to copy paste this, but then we can use this os.makedir to create a directory. And we can see if we go in here, now we are able to create a directory in code. And this is really nice if you have to download files from some online storage file system somewhere and there's like a structure to it. And as you're going through and scanning through that online file system, then you can check, okay, I want to have the same storage system on my, wherever I'm downloading it to on that disk. And so I want to see if the directory exists. I can just, save that file to that location. Otherwise, if the directory does not yet exist, I want to create that directory and then I can save the file to it. So yeah, a little bit sidetracked from the environment variables, but I think these are very useful things in the OS package that I really do use on a regular basis that, I think you'll find useful and hopefully will help you in, your development. So previously when we were developing and we were testing our application, which let me start that up again here real quick. When we made a request, for example here, and we tried it out, I said here we can also see that the response was successful because we have this 200 status code. But aside from that, we kind of skipped over it. And when things went wrong, then, we we had a 500 code, but again there we skipped over it too. And so now I want to take this lesson to look at HTTP response codes. And generally, and I've kind of opened the Wikipedia page for this, there are different types of response codes that we can see. The first one is so 100, so 1XX, so anything starting with a 1 and then 2 digits here, which you barely see these. These are just like informational things, but we're not really going to be concerned about these because as you can see, there are a good number of different response codes that you can get, but I'm going to go over, first of all, the main categories, but then also in each category talking specifically about the ones that I think are most common or that, I generally see. So the first thing is going to be the 200s. So anything that has some 2, starts with a 2 and then, in the 200s is considered a successful response. Now the most common one is this 200 one, which just means everything was okay. And we can see that in our API response here. When we executed this, here we have a response code 200. Everything is okay. Another common one is 201 created, which we're actually going to implement in a second. Usually you want to use this one when new entries are created. And a good place for us to use this would be, first of all, here in the add user. And we can also put it here in the update user, but definitely here in this one here. Because here we know that whenever something returns successfully, a new entity was created. And so we could return a 200, which is what we do now, but to be more specific, we could return a 201 to indicate that a new entity was created. Right, then going over to the 300s, this is generally, as we can see here by the title already, about redirections. I think the most common one here is the 301, which is just that this location was moved permanently, and then you get a redirect URL given with it about the location of the thing that you're now looking for. Going into the 400s, these ones, as we can see here, are client errors, so something went wrong. The common one here is 400, which is generally what happens in our case because we don't have anything specific. So this is just a general bad request, like something was wrong with the request. For example, and actually, I think this is actually going to be more specific already, or it doesn't even let me do it because it's not an integer, it already does the validation. And no, we'll get a 500 from that, but yeah, if I try to put in here something that doesn't exist, we'll get a 500, we'll get to these in a second, but generally a 400 will be any sort of bad request on the sender side. So 400 is going to be the general bad request without too much specific information. 401 is semi-common in the sense that you're not authorized to do these requests, so you're trying to do something that you're not authorized to do. For example, change a password, add a user. If you are not authorized to do these sorts of things, you'll get a 401, or you should get a 401 response. 403, forbidden, which is a similar thing. You're trying to access things that you don't have access to. 404 is probably something that you've all seen, which is the page was not found if you're trying to, or the entity was not found page if you're on a website and the website is not found, or a subpart of the website is not found, or also just generally, if you're trying to access some sort of entity and the entity itself was not found. And then another common one, I think, is the 429, which says here too many requests, but it also is essentially the rate limit exceeded. These are kind of go hand in hand. And you'll see this if you're using some sort of other service in your own service and you're sending them a bunch of requests and they only allow you to, for example, send them 500 requests per second or something like that. And once you go over that number, you'll likely get a 429 response, which means you've sent too many requests in too quick of a time, and you need to wait a little bit before you can send more requests because the server is not going to serve you anymore until this time period has passed. And generally, you'll also get information in the header about how long you need to wait. And if there are rate limits that a server has, generally within each header parameter, they will tell you the current status of your rate limit to make sure you don't exceed it, because sometimes if you exceed your rate limit too many times, you can actually get throttled or blacklisted or whatever from the server itself. And then we have the 500s, which are errors on the server side. And so this is what we're seeing here. For example, when we try to put in here -1, and what we try to do if we look at the code is we try to remove the user with the key -1, which doesn't exist, and our code actually crashes. And in this case, we have an error on our server side. In this case, we have a bug here. And rather than returning anything specific, right now we're just returning a general 500, and it just says internal server error. And now this is important that we say internal server error rather than passing on the error message, because if our application failed due to some sort of vulnerability that it has, if we pass on the error message, then we will actually be passing on this vulnerability of what caused the failure, and maybe someone on the outside can now use this information to have some sort of malicious attack. And so generally we're not going to be touching the 500 responses, and we're just going to actually let Fast API take care of that for us all on its own. When something fails inside, it will automatically return a 500 response, as we can see here, and we're not going to be transparent about what that error was because we don't want others to know about potential vulnerabilities within our application. So yeah, these are the large areas of status codes that we can return, and also that you may see when sending requests to other services. And these are useful because depending on which response you get, you may want to implement different behaviors in your application. For example, something that you could do is, let's say that you're interacting with, say, the Twitter API in your service, and you're building an API that lets users, I don't know, like send some information, and then you bundle it together and you like create tweets from it. And maybe you're using the Twitter API, and generally you get 200 responses, but at some point you get the 429 response. And so you can have a special case in your server where if you get the 429 response, you can have some sort of special logic where you can look at the rate limit that you have, for example, and see, oh, okay, if I exceeded my rate limit, now I'm going to wait this dedicated period of time, and then I'm going to retry again. Or, you can return to the user and say, you've exceeded your rate limit, please wait this amount of time until like sending again. So this is obviously an implementation detail that you can decide how to handle based on how long these rate limits usually are, but the status codes are useful because depending on the status code, we can actually already include that in our API or in our like code in general, and we can handle different status codes. Now, we haven't actually looked at how we can send requests internally in our services. That is something that we'll look at later when we get to the testing, because right now we don't really have much use of it. But yeah, in those cases, generally it's a good thing if you check the status codes, because you can do different behaviors based on the status response code that you're getting from the request that you're sending. And obviously, similarly, we want to be good about the status codes that we're sending, because the more specific that we are, the better it is for end users. And so right now, for example, something that I'm going to do is I'm just going to update our our post response here to return a 201 status code instead of a 200 status code. And the way that I'm going to do that is I'm going to add the status code, or I'm going to define the status code variable here. I'm just going to put in 201. And so whenever this endpoint here is called, we're going to actually return a 201 status code, because 201, if we go back to our list here, means created. And that's exactly what we're doing here in our post, as we're creating a new entity. So I'm going to just refresh this, and then we can actually see our documentation has already been updated, that the default or the responses that are available to it, and one of them is the 201 that will come with it, and then the 422 we actually get from Pydantic validation, which just means that the input information was not a valid format. So that's if we break the schema that we're sending. So we can try that out. If we just send this using like an example values, we can see here we get a 201 code, which means the entity was created, and we get information about the entity that was created, in this case the user ID. And to see the 422 response when there's a validation error, let's just, here we require a list of integers, and if we put in here a string, then we will get, a 422 response, because FastAPI with Pydantic under the hood actually takes care of this for us, and it's not even going to let this crash internally. It can already see when the request is coming in, it does the validation, and it says that this entity is not processable, and it gives the user information about it, that this like post's value is not an integer. And so there is a validation error, and we get a 422 response from it. So yeah, these are response status codes, and I hope you can appreciate them, because if used properly, obviously they can make things a lot clearer, because they're much more specific about the things that went right as well as the things that went wrong, and allow others who are using your services, or you when you're using other services, be able to more detailed adapt your code based on the status codes that you're getting, so that you can properly handle different responses that may occur based on if things are working properly or if they're not working properly. So as we were programming previously, we'd seen several cases where our code essentially was failing. There was some sort of error that was popping up that was causing us problems. And now we're going to look at how we can actually deal with some of these failures without having our whole program crash. And so what we're going to look at now is going to be exception handling. And I'm just going to start off by creating a new file here that I'm going to call exception examples, just to, have like clean space where we can go through some of this, and then we will also look at how we can implement this for our application. All right, so let's start with a very simple dictionary. We'll call this our sample dictionary, and it's going to have one value A, or one key A, and its value is going to be 1. So for example, let's just print this out. And what we can also do is we can print out our sample dictionary here with the key A. And so both of these should work. And if we run this, we can see here this is our dictionary, and this here is the value of the dictionary with the key A. But if we try something like this, then obviously we're going to get an error because the key B here does not exist in our dictionary. We can see here we get a key error. Now this is really nice, but this causes some problems. For example, if we say this, we've made it to the end, and if we encounter the exception here, you'll notice we never actually reach this point. As soon as we encounter an exception, our code crashes, and it doesn't continue on. And this can obviously be problematic because we don't want that. We want our code and our application to be able to deal with errors in a way that doesn't just cause the whole thing to crash. And that's where exception handling comes in. So something that we can do is we have access to this statement here called try. And just like within an if statement or something like that, we can say we want to try the following. Now, with every try, we also need to have an except statement that comes with it. And in this except statement, we can then catch exceptions that may be raised, and we'll explore what exactly that means now. But generally, if we want to catch just all exceptions, so any type of error that could occur, we can just catch the general exception keyword here. And we can see this is the specific Python term because of how it's highlighted in my IDE already. So we can print here, for example, oh no, we've encountered an exception or an error. And now the interesting thing is, when I run this, we can see here, when this is going to fail, we no longer get this error message here. But instead, we try out this statement in here, everything that's indented in here. And if anything indented in here encounters an error, then it raises an exception. And again, we'll look at also what that essentially means. And then we have these except statements. And in these except statements, we try to catch different exceptions. If we have here just an exception statement, this will catch all exceptions. And that's exactly what's happening now. We have here, oh no, we've encountered an exception or error. So we try this, we fail because the key B does not exist in this dictionary. It raises an exception, we catch it, and then we enter this statement here, we print it out, and then our code continues on. So nice, now our code did not crash. We were able to properly deal with an error that occurred. So let's try out some other things here. This will work. This will not work, just to show you what actually happens when a crash occurs. So if we try it like this, we can see here, this is where we reach the exception. And at this point, we exit out of here. We don't continue on with the rest of this statement, but rather this works. And like we can see this gets executed. Then we reach this statement, which does not work. And so at this point, we exit out of here and we raise an exception. The exception gets caught here. We enter this block, as we can see here. And then we can say we've made it to the end. So just be aware that we will go through these components here until we reach a point that fails. And if we never reach a point that fails, for example, if all of these are valid, then we will never throw an exception and we will never reach one of the exception caught statements, as we can see here. So something to be aware of is just because there may be an exception later on, previous code can still get executed. So just keeping that in mind. So one extra thing here is we can catch an exception and we can actually give it an alias like this. And now, if we want to, we can actually print out this exception to get more details about it. So we can see here, we're printing out this component here, and then we reach our exception, and then we say here, oh no, we've encountered an exception, and then essentially this is kind of the detail that comes with it, which is currently not that much information. But we can see that there's something wrong with B. All right, but generally what we want to do is we can actually expand upon this to make it a little bit more clear, because right now we're just catching all exceptions, which is just a good failsafe, but is also not the most ideal thing, because maybe based on the exception that we get, we want to try different things. So we know if we comment this out and run this again, we get a key error. And we can see here this is the text associated with it. So rather than caching all general exceptions, what we can actually do first is we can accept for specific exceptions. So in this case, we have a key error. That's the type of exception. So we can look for a key error here. And then we can say we've encountered a key error, like this. And here we will say we've encountered a general exception. And just like elif statements, the first one that we catch is the one that's going to get executed. So in this case, if we run this and we encounter the key error, we'll see here that we go into this statement. We've encountered a key error, and we no longer go into this one, because here we are catching the proper exception that occurs from here. However, there are also other exceptions that we can encounter, and you'll probably get familiar with them as you code more and you see different errors popping up. So for example, if we try something like this, and we take this out, then we can see here, in this case, we get something called a zero division error, which, as the name already says, is probably pretty clear about what goes on. And in this case, we're only trying to catch a key error. But this is not a key error, and so our program still fails, because we try this statement, and if it fails, we try to catch a key error, but we never deal with a zero division error in this case. And so because we never handle this exception, our program still fails. So if we wanted to deal with this properly, we could, for example, also look for zero division errors and say here, we've encountered a zero division error, something like that. And now if we run this, again, we're going to be successful. Something else that we could encounter is maybe an unnamed variable, something like this. Again, we're going to fail. We have here a name error. This is not defined. And so we can go on and on and on like this. Obviously, we're not going to be encountering all exceptions all the time, but we should be aware that different things have different exceptions associated to them. And it can generally be nice to, deal with these specifically, rather than just catching it as a general exception. Because something that we could do, for example, is if we have, let's say a equals 1 and b equals 0, and we try something like c equals a over b, if we just catch a general exception, there could be potentially other things that go wrong. But if we are looking specifically for a zero division error, then what we could do instead is we could say c equals a over 1. Because then we know we were dividing by 0, and maybe the fallback case that we want to have is something like this. So now if we print out c, not only did our code not fail, but we actually have a proper value that we can use to continue on, and we're able to deal with that properly because we have a special exception statement for specifically this case where we want to have some sort of specific use case or some specific way of handling it. So this gives us a lot of power to, depending on the possible things that could go wrong, we can act accordingly. So not only does our code not crash, but actually we fix it in a way that it can continue on working properly, which is obviously super, super nice because, errors will occur eventually, something will go wrong at some point, and just being able to deal with that properly is very important. Obviously, having a general exception statement, where essentially if something goes wrong, you just stop rather than just failing completely will already be a step up. But obviously the more specific you can get and the more you can try to understand and fix your problems if as they may occur, then this makes your program run even better. All right, so we've talked a little bit about raising exceptions. And this is generally what happens when something goes wrong. We raise an exception. But what really does that mean? So in Python, when we see something like this, this essentially happens because a raise keyword is used, which then raises a specific error. So for example, if I want to change this around a little bit and say if b is equal to 0, and then I want to raise a specific error, so right now we would get a 0 division error for here, but let's say I instead raise something that we've seen before, which is a key error. And so now, before we would even reach this, we would actually, comment this out. Before we would even reach this, we can see here, now we've raised a key error, and so we're actually entering this block rather than this one here, where instead we would have had a 0 division error raised. And this can be quite nice because in our code we can actually, and we'll look at that in a second, we can define custom exceptions. Because sometimes the exceptions that we have access to here may not be enough to cover, or may not be specific enough to cover all of the cases that we want to cover. So we can define custom exceptions if we'd like to, and then we can, based on certain conditions, we can raise these custom exceptions, and then we can catch them using except statements and handle them accordingly. So how do we define a custom exception? Well, it's actually quite simple. We can create a new class and, for example, just give it any name like you would a class. Let's say this is a custom exception like this, and then all we need to do is just inherit from the general exception class like this. And we don't even need to define anything here. We could just put in a pass statement like this, and we'd still have this exception defined. And now, for example, we could raise this exception, and we could try to catch it. We can print out, we've encountered our custom exception. And we can see here, this is the block that we've now triggered. And again, this can be really, really useful because in some cases you may be aware of potential things that could go wrong, but we don't have the necessary kind of default exceptions that are able to properly describe what is going on. So you can create your own exceptions and raise those, and then higher level up, catch them, and deal with them properly. So that not only does your code not crash, but again, you're actually expecting these things, and based on which ones occur, you can then actually adapt accordingly so that your code carries on in a valid way, rather than just interrupting it. All right, so this is kind of the basic stuff about exception. There's one thing that you can also do here. You can have a finally block, which will execute after all of this completes. So you can say here, let's just put in a print statement, we've reached the finally block, and let's just have a valid statement first. So here we can see where we're not going into any exceptions, or we can say here, C is C, so we can see that we execute this code block, C is 1.0, and then we reach the finally block, and then we've made it to the end. And if we encounter any exceptions, we will, as we previously know, we will go in this case into the 0 division error, and maybe we want to print this out too. Entered 0 division case, entered 0 division case, but we're still going into the finally block. So we try this code, regardless of if it succeeds or not, we always will also execute this finally thing. So this can be useful in certain situations. I don't necessarily end up using it that much, but just being aware that sometimes regardless of if things succeed or not, if you want to still be able to execute something, you can have a finally statement here, and that way, regardless of the outcome here, you can still do specific actions. Okay, so let's now go ahead and go into our application and actually implement some of this. So one thing that you can do when you want to add this sort of stuff, if you want to use custom exceptions, we could create a new exceptions.py file here where we can define custom exceptions if we want to use them. So for example, custom exception 2 that inherits from exception, and here you can then use it, you can import it like we do any other thing. So if we go into routes, for example, we could say here from app.exceptions, we can import custom exception 2, and then we can use it just like we do with any other thing. So just about this, because it's part of our structure, and obviously if this gets extremely big and very specific about across different things, then you could turn this into a directory and have different files for each of the different components that you're working towards. This is something I think that you can adapt a little bit based on how general these exceptions are. If you reuse them across different like routes, for example, or across different components, then maybe you want to put them in a general file like this. Otherwise, what you can do is you can create a directory that you could call exceptions like this, and then if you wanted to, you could also create a common.py where you have common exceptions that are shared, and then you could have user-specific exceptions in a user.py file. So yeah, these are also options, again, depending on your needs, depending on how this file would potentially look like, depending on how your application looks like, and what would best fit the program structure. So yeah, I'm going to take this away again, but just wanted to have like a little side note on that. Okay, so let's actually go into our routes, and we know in some cases we will get errors. So specifically, let's first look at the delete case, which is here. So we know sometimes we can fail here because here we can get a key error because right now we're just removing from a dictionary. So what we could do if we wanted to is we could put this statement here in a try and, oh dear, an except block, and where we try to specifically catch a key error, for example. And then in this case now, we know, okay, we've encountered a key error, so rather than returning a 500 response, which is what FastAPI would do if it encounters an unhandled exception, we could instead try to raise something more specific. For example, we've learned about status codes, so we could raise here a 404. And this is actually where we get to the second part, which is dealing with exceptions in FastAPI. And so what we can do here is from FastAPI, we can actually import this HTTP exception that we can use. And then in this specific case, where we would encounter a key error, which for us, we know this means that the user does not exist inside of the service, we can actually raise an HTTP exception. And here we can define the status code, which right now we want to have as 404 because the user was not found. And if we want to, we can also provide some details. This can be a string if we wanted to. So user no, or we go, let's see, user doesn't exist. It's probably a good description. Or maybe user with ID if we wanted to, although they would already know the ID. You can see here it automatically added the F string when I put these curly brackets here and let the code completion do its work, which is why this immediately worked, but otherwise, of course, you need to add the F in front of here to make it that formatted string. All right, so let's take a look at this. Unicorn app, oops, main app reload, and let's try to make this fail. So if we try to delete the same user twice, so first we're going to delete user 0, which returns a 200. And so this was successful. Now if we try to delete the user again, we can see here now we've got a 404 response. And here we have some description that the user with ID 0 does not exist. And again, like I mentioned, we don't need to return a string here. We can also return a list if we wanted to, or we could return a dictionary, for example, and say something like message user doesn't exist, and then we can say user ID like this, and retrying this. So now it'll work again in a second because our application was restarted, and so our dictionary is kind of back to the initial setup, so this will work. Trying again now, we can see here our response is now this formatted response that we have here. So we can put strings, dictionaries, lists here, depending on what we want it to be. And this is then the details that you can see here that are just described with the error that have occurred. So this is much nicer now, because what we had previously, if we look at this again, so this works again, and now we just get an internal server error. But actually the true error is that the user is not found. And so what would be much nicer, which is what we will have now with this custom exception, is raising a 404 exception. Because really, that's the problem, right? The user is not found and we cannot delete them. And obviously that's causing problems internally in our code. And in this case, we can deal with it like this and also make it more transparent so that the client doesn't try to retry later on and encounter the same error because they're not exactly sure what's going on. And yeah, one thing to also just note here is that we use the raise keyword rather than the return keyword, because right now we're going to be raising this HTTP exception that we were able to define. And yeah, with that, another note also about formatting. Generally, when we have code that does exception handling, we want all of that to be defined within one function. And just going back into the exception example here, let's say we have a function that is something like add 1, and we have some number here, and maybe here we do something like number plus, or we do something, let's say number equals 0, and then number plus equals 1, and then we try number plus equals 1, and then we do some exception, just some very silly things. But just the point here is that when we have try and except statements, we want this to be generally our whole function. We don't want to have any code before. We don't want to have anything before here. We don't want to have some sort of other function that we're calling beforehand. Generally, when we're dealing with try and except statements where things can go wrong, that in and of itself should just be the function like this. We should start with a try, then we should have the different exception cases, and yeah. So this is how, when we're using try and except statements, we want to structure our functions, which is just helps a lot with readability and it being clear that this function does this one thing, rather than it doing just multiple things. So yeah, just be aware that when you're programming and you're dealing with try and except statements, try to write things in such a way so that, and if you need to create a new function to do this, that's totally fine, but try to have it split up in such a way that, just like we've learned previously, when we're writing functions, we want to keep them small, and we can actually take snippets of code and put them into a function, and the function describes what is going on, and then we can use that function at a higher place. Similar things we also want to do here, just keeping that in mind, that our code stays clean and readable, and we're not trying to do too many things in one place, but rather every single function should have its specific purpose of things that it's doing. And that doesn't mean that a function can't execute multiple functions, but rather it should do exactly what it's doing, or what it's supposed to do and not try to do more than one thing. So for example, if we had a function that was like prepare user, and here we would have some like raw user data, a valid function structure could, for example, be like extract user data, raw user data, and then we can call this here, for example, like extracted user data, where we call this extract user data, whatever it may be. And then we can have, for example, like transform user data, where we take this as input, and then we have some like transformed user data, or maybe here we have like fix user data in between, where we fix the user data with like certain formatting like issues or general fixes that may occur. All of this is like a good valid structure because it's all doing what it says it is. It's preparing the user into some sort of format that we want to use later. So it's doing multiple steps, but this function is doing what it describes. And here, similarly, this function, we know, even though we haven't implemented it, this function will extract the user data from the raw data. This one will apply some sort of fixes that we know we need to do, and this one will apply some other sorts of like transformations or what else. And at the very end, we're going to have our prepared user data that should be in the valid format so that we can continue using it, for example, to insert into a database or whatever else we want to use it for. But what we want to avoid is having like prepare user data, and then all of a sudden here we have now a try and accept statement, and then we have something like check if users in database, something like this. So like now our function is trying to do multiple things, and then we have like an additional try and accept block down here, which isn't supposed to be there, and rather instead what we would want is maybe we would have a separate function that's like insert user into DB, where we take the user data, and then we would check if the user is in the database, and if they're not in the database, then we want to do like insert into DB, where we insert the user data, or something like that. And then we could, in some higher function, we could call like prepare users. Let me just, and insert users into DB. So again, like separate steps. So I know we went on a little bit of a tangent here, but I just wanted to like talk about this clearly because I think it's important, because you don't want to start writing messy, and as you start coding you want to make sure that you're always using proper formats and proper structure. And I just want you to already keep this in mind when you're writing code, because this is important. And if you don't do this and you work at a company, they will tell you to fix it so that it is in this format. And yeah, you're doing yourself a favor writing it like this, because it's much more clear to you what exactly is going on. When something goes wrong, you know exactly where to go. And when you reread your code weeks or months later, you still know what you're trying to do. And if others read your code, they understand what you're trying to do. Versus if you just have, functions that have hundreds of lines that are non-descriptive, it just becomes so difficult to read. And when things go wrong, it's very difficult to understand, like what exactly is going wrong and where is it, right? So you know where it's going wrong because the errors will tell you, but you still have to understand the whole context and what are you even trying to do in this statement. And so just keeping things separate, everything having its own purpose, will just make your life and everyone else's life a lot easier. All right, so that specific to why we should have try and accept statements just within a single function. And yeah, this is error handling that we can do in Python. And obviously, I think we can add error handling to different places. For example, we could also do an error handling here, where we do a similar thing at try and accept. If our user is actually not in here, we will instead raise an HTTP exception for because we can't get the user rather than failing. So this would also be another good place to insert it. And I can't think of any other places right now, but I'm sure if we encounter any other exceptions, then maybe we want to have special cases to, deal with those too. So far, when we've been going through our application, we've been using print statements for everything, which has been going well so far for us, right? We were able to add print statements to inspect certain things and see how things look like, which, is great. And useful, but there are limitations, and there's actually a better way that we can do this when we're writing our applications so that when they go out, we no longer have these print statements, but instead we actually have more specific information about events that happened. And yeah, that's what we're going to look at now, is we're going to look at how we can implement logging and the benefits that we can get from it. So I'm going to go ahead and just import logging here. Now, logging is a standard Python library that should come with your Python installation, so you don't need to install anything else from here. Now, what I'm going to do is I'm going to get a logger instance by going into logging.getLogger. And the name that I'm going to use here is going to be a special format. I'm going to use underscore underscore name underscore underscore, and I'm going to print this out and show you what exactly this prints out. But really the nice thing about using this, as you'll see in a second, is we're just able to get the name of essentially where we currently are in our project. And so we're able to properly separate all of the different logs that we have. So actually, just by restarting, we can already see here, this is the name, this is the value of this attribute that we get. So we can see this is our current location, right? App routes users. And so when we use this sort of format, we know exactly when this name is attached to any log, we know exactly where this log came from, which obviously helps us a lot because then we don't have to go out and find, oh, where potentially was this produced? No, we know exactly this is the there's a location where it was produced in, which obviously helps us because the whole point of logging and being able to keep track of things is so that when things go wrong, we can take a look at it and we're able to essentially trace backwards the steps to understand what went wrong so that we can then go about fixing it. And that's really something that we want to do, consistently, is we want to have good logging implemented where we write out certain things, keep track of certain things, so that these things we can then later on use if something goes wrong to help us understand what went wrong, or also if we want to search through specific logs to look for specific instances. All of the stuff is nicely done with proper output format. All right, so we have our logger here. Now, one thing that I'm going to do for this case right now is I'm actually going to go into our logging, and I'm going to do here, into basic config, and I'm just going to set this file name property to log.txt. And so what this does is, we'll see in a second, that whenever we produce logs, we will actually write them into a log.txt file. Now, this can be it's going to be nice for us now because then we can actually look at them, because our logs actually get outputted to the standard error, which we can't actually see right now. And so if we want to be able to see them while we're developing, we can put them into a file, for example. Alternatively, we can use like print statements, but that's not super nice because then either we have to remove those or we have to change them to logging later on. Or what is actually also quite nice, which we'll see later, is when we use Docker, we can actually see all of these logs directly, and then we can just do everything like that and we don't have to worry about this anymore. But for now, I'm just gonna, in this case, make it go into a text file. All right, so let's see an actual example of how we can use our logging. So first of all, there are different types of log levels that we can have. So we have this debug option. We can go logging.debug. We have logger.info. We have logger.warning. We have logger.error. And we have logger.critical. So these are different levels already that we can have with output text. And we're crashing right now because we obviously have to attach a message to this. Essentially, you can think of these kind of like print statements, but we also provide with it the information about how important these logs are. So we can see here debug is just for debugging purposes, things that we may want to log essentially for those. Info is not as severe or not as detailed as debugging, more informational. Warning is when it didn't crash, but something weird happened. Error is when it crashed, and critical is extremely important crashes that need to be very, very visible. All right, so for example, let's say we reach this exception case here. Rather than just raising a 404 status code, what we can also do is maybe here we could either do, we're using our logger. So in this case, we could do either a error if we wanted to, because we're entering an exception case, and so we can log an error for this. For example, invalid user ID, and then we just put the user ID as an F string in here, was requested, or something like that. Or maybe even better, non-existent user ID, and then the user ID here was requested. And a similar thing we could do here, which I'm not going to put here, and maybe one other log that we can put in just to try it out is maybe here we want to do logger.info about to delete user ID like this. So now we currently have two different logging messages that we're putting out. So let's just go ahead and run our program and just see what we get from here. So starting our application again and pulling up our page here. So the first one, where was the first one? Get user by ID. So this one fails. So let's put in here maybe ID1, which is going to fail. User doesn't exist. We have a 404 error that comes with it. And we can also see now we have this log.txt, and here we have a lot of logs attached to it. And so now we can see, for example, this is the severity that we have. So we have an error that we've encountered here. This is the name of the logger, where it was found. And then this is the message that was attached to it. So in this case, we already have a lot more information than we would with just a standard print statement, because now we also know how severe the issue is, as well as the location of it, which are things that we can look for. So that's already really nice. Let's take a look at the deleting. Try this out and delete the user with ID 0. Now, currently, we actually don't see our logs in here, and this is actually where we'll look at the next part, which is by default, our logging may be configured to not include all messages. And that is something that we can change in the configuration. So in this case, we're defaulting to just showing important messages, and the info messages that we have defined here are not actually outputted. But we can change that. We can go into our into our logger, and we can set the level here. Now we can define what sort of logging granularity we want. For example, we can go to the info level by going into logging dot and then uppercase info. Now this will set our logging level for this logger to the info level. So now if we try this again, we go here, we can see now we have info level granularity, and we can see this here. But if I try to make a debug log beforehand, logger.debug, this is a debug log, then if I try this out, we're still not going to see this because our granularity is set to info. And so again, the order that we have here is going to be debug, then info, then warning, error, and critical. So these are the different levels that are available, and these are all going to be upper caps, but these are the different levels that are available to us. And if we change this, for example, from info to warning, and I try this again, now in a second at the very bottom, we're no longer, so this is going to be the kind of starting up and that we also see here. But now we no longer see the info request that we have here because our logger here that we're using is no longer logging at that level. So it's no longer reaching this level. It's going at an info level, but we only want to log starting at the warning level. So with that, we're also able to very quickly, determine what sort of level we want to be logging at, because maybe if we have too low of a level, like debug, we may be logging too much and we're just going to be spamming our system wherever we store all of our logs, and that's going to make it very difficult to actually use it because there's just so much overwhelm. And so maybe, we want to start with a more severe logging level so that we actually only catch mistakes. And if at something points, things are going wrong, maybe we want to increase our logging level, so going from warning down to info. So there, then we can get more information if so required. So this is definitely something that we can tune based on, how we want to go about logging and what information we think is actually required, which may also change with time. And yeah, generally, I think thinking about logging, the best thing to always just keep in mind here is, when you would use a print statement like for yourself to just inform yourself about things, then unless you're using it for debugging, then maybe if you want to, you could put a logger.debug, but you don't want to clutter your code with a bunch of debug logs, so you could probably remove those. But otherwise, it's nice to just have like informational statements in some places, again, not littered everywhere. So generally, I wouldn't put an info statement here. Because we already have that info essentially, from our fast API, for example, for what endpoint is called. So I wouldn't put this info log here, but in some cases, if you want to monitor specific methods or specific classes, and you wanted some extra logging around that, then you can obviously put, info logs there, for example. Generally, what would be nice is when things are crashing or you encounter exceptions, making sure to log whatever caused that exception so that, when the time allows, you can go through those logs and you can investigate what caused certain things. And especially if it's, an unhandled exception, you can understand what caused this error, and then you can go and update your code and, fix it to make sure that those things are no longer going unhandled, or at least you have a better understanding of what's coming in and what some of the problems are, and maybe someone is misusing the service, and you can see that through the logs because they don't fully understand how to use it properly. And so maybe you want to, talk to those people and, clarify, hey, this is actually how it should be done, or you want to update your documentation or your descriptions or whatever. So yeah, logging, very, very useful and very commonly used. Again, for this, do not overuse it. You will not be doing yourself a favor if you add logging everywhere because it's just going to clutter your code. It's going to clutter the output. Use it sparingly and wisely. Think about what are things that I will actually come back and look at. What are things that are actually useful and informational? Saying something like, if you put in a logging.info or logging. Yeah, debug or info about to create a multiple user response object, like that's not particularly useful. So just keep in mind, like, what are the things I actually want to be having in our output? What are the things that, if I go back and look at this, will actually help me and are not just things that are there that will just clutter the output, and with that also, of course, clutter the code. Because all of these add extra lines, which if there's too much of it, it can also hurt readability. But yeah, so just keeping that in mind, I would, when developing, you can either do it halfway in between, or maybe sometimes like at the end of the project when you're getting ready to, finish up a big task or even a small task or something, think about, is there any place that I want to add logging? Is there any place that I should add logging? Or also, on the other hand, did I add logging somewhere maybe where it's not absolutely necessary and I was just doing it more for my local testing? But now that things are working and I've confirmed things are working, I can actually take these print statements or these logs away so that I don't unnecessarily spam my output and make it harder for me to find information later on that I'm actually interested in using.
Now, before we move on from logging, there's two more things that I want to show you. So one of them is going to be how we can actually format our output strings so that these things can actually look different. And then the other thing I want to show you is how we can actually log to different places. So let's start with the second one first because it's going to be well, a little bit more straightforward, or rather a little less like variations and explanations. So I'm going to create another logger, which is going to log to our output console here. So if I start my server again, we know that currently we are just logging to our txt file here. But what if for, I don't know, say debugging purposes, or, or also just in general, we want to be able to view our log outputs here too in our console directly. So to do that, I'm going to go back to our file here, and I'm going to create a new logger, and that is going to be a stream handler. And this is actually going to enable us to stream our logs to the output that we're seeing in our console here. So I'm going to save this as console, because that's essentially where we're streaming to. And now if we want to, and I'll just show you what we have before. If we remember our get here, if we get a user by the ID and it doesn't exist, we'll get an error message. So if we go in here and try user ID 1, we're going to fail, but currently we don't see it here. So if we want to add that too, then we can just take our logger, for example, and then we can say here add handler, and then we can add our console logger here if we'd like to. And now, if we try this again, we can now see that we're able to also see these logs directly in our console here too. And now the interesting thing here is that because we used logger, which is the logger for this specific location, we're only logging the stuff that comes from here, essentially. But if we change that, for example, let's use a different name. So we'll do logger, logging dot get logger, and then we're just going to have no name here. And if we put this here, now we'll see we have basically all of our output also logged here. And depending on what name we use here, we'll have different things logged based on what module is being logged from this. So, or rather directly what file is being logged from this. So yeah, this is something that we can change if we want to. In this case, if we only want the console logs for this specific route here for testing it, then we can just directly use the logger that we've already defined above that we're using just for this file, and that way we'll make sure that all of that is going to be specific to just this file here. The other really nice thing that I want to show you is how we can actually format this output here. So we have the file name here, but there's actually another parameter here called format. And I just want to cover this now. There are, depending on the format that you need, I would probably just recommend quickly doing a quick Google search to see like how can I add this field, because likely you won't be using it enough to just remember it. There are many things that you probably won't be using enough to remember it. So most of the time, having seen this and then knowing what you're looking for and doing a quick Google search will get you the answer very quickly. So we're going to add formatting things kind of similar to what we've seen when we looked at formatting all the way back when we had strings. But you'll notice this syntax is again going to be a little bit different, but in here we can define our format based on the variables or based on the components that we want to log by providing specific names inside of these inside of these parentheses that are that have this percentage sign in front of them. So for example, if we want to first log the message here that we have, so what we have here is the level name. That's what this variable here is called that we want to log. And I need to add here commas. And then let's say we want to add the name of our current location, or the name of our logger, which we can have here. And let's say we then also want to know what time this occurred. Pretty useful thing to log. The way that we can do that is by using the ASC time like this. And finally, of course, we want to know the message
And oops, to do that, we're just going to put our message here, and we're going to put S behind each of these as they are all going to be strings. All right, so reloading this, and let's try that again. Execute. And now we can see when we actually go into our logging file here, scrolling all the way down, that you can see here our output format has changed. So in this case, our logging to the file, we can see here we're now using this new format. We have the message, then we have the logger name, we have the date and time, and then we also have the message. So level name, logger name, date and time, and message that comes with it. So yeah, definitely very, very useful to have that. And essentially you can kind of play around with this and change the order. One nice thing here is to always add formatting, so having kind of like consistent spacing. So maybe something that we want to do is have this be what do we have here, like 10 characters or something like that. So the way that we can do that is just do -10 s, maybe the name we want to give like 15 characters of space, and that way we're going to have most of our stuff here in the front aligned, as we can see here. Okay, that's probably too much with -10, so we're going to do like -6, and let's see if it refreshes. So yeah, so we can see we can also play with the formatting here and just kind of give consistent spacing for everything. When this amount is not filled up, then we're going to have extra spaces, and if the amount is filled up, then we're just going to use the actual amount required for each string, as we can see here. And then we have extra spaces as we have them between here. Okay, so let me change this back to something like this. All right, now the other cool thing about, or the other nice thing that we can do about formatting is we can define the date format that we want to have. And let me just use double quotes for all of these to be consistent. So the date format, essentially we can define the year, month, day, hour, minute, second, millisecond, as we see we're having it here. So to define, let's say, year, month, day format, then the year is going to be indicated by a %y. So this indicates that we want a year. %m indicates the month, and %d will indicate the day. So if we have this date format, then it's going to be in year, and then there's going to be a dash, month, dash, day, and that's it. So rerunning this, and just looking at our output logs again here, we can see we no longer have the time information. If we want to now add the time information, if we want to do year, month, day, and then space, and then if we want hour is going to be %H, minute is going to be %M, and second is going to be %S. This is going to give us year dash month dash day space hour dash minute dash second. And looking at this, again, this is exactly what we have. Probably want to do this something like this maybe. I think that's, yeah, more common. Year, month, day, hour, minute, second. And so to add the millisecond, I'm actually going to go up here. I'm going to add a dot, and then I'm going to do %m6 like this. And let's take a look here. What error is complaining about? Oh yeah, we need to define what type we want. So we can do a just string type for now if we'd like to, and we can see it here, but this is actually a ton of stuff. And so instead, what would be something more reasonable is say to 3 digits as an integer. And bam, there we go. We have the milliseconds too. Now one thing I noticed, our year is actually off here, and this should be an uppercase Y, which will fix that. So there we go. So yeah, with this, we can change the output formatting, which can be especially nice because you can arrange it in the order that you like, as well as have the information that you want, and also change some formatting here. There's definitely some more stuff that you could put in here if you'd like to. So if there's something that you need to look up or that you want specifically outputted, then I would say just a quick Google will get you that. For example, if you ever have to deal with threads, you can actually also output like threads names and stuff like that. But yeah, this is how we go about formatting, and actually datetime formatting is pretty similar even if we use different datetime libraries. For example, the main datetime library, which is just called datetime, there also you will see this datetime format repeated, where you're able to indicate the datetime format that you want or that you want to get parsed. And so this is actually a pretty common thing that you'll see in many different places when you're talking about datetime formats. So now I want to take another look at how we can handle exceptions differently and generally be able to see how we can, when we have a specific exception that we're encountering and we want to handle it the same way across our whole application, how we can implement that versus having specific try and except statements here that always do the same thing. So what we're going to do is we're actually going to change this try and except for the key errors, and we're instead going to handle this on a global level across our application. Now, also something I'm going to do is I'm just going to remove all this logging stuff and just kind of leave our default logger like this. And I'm also just going to take this log.txt away so that it's not always there, just taking up space. Okay, so we've also previously looked at custom exceptions. Although we didn't actually end up using them, that's what we're going to do now. We're going to create a custom exception that's going to, well, we can see we're going to have here class user not found, which is going to be a custom exception that for now is just not going to have anything extra to it. And now going back to our users here, so in this case, we get a key error. And going back into the method that we've defined, we get a key error because we're trying to access a key that does not exist in the dictionary. So what we're going to do here instead is we're going to import our custom exception. So we're going to say from app.exceptions, import user not found. And let me just go back to where we're catching this. So here. So now we're going to say if the user ID is not in profile infos, then we're going to raise our custom exception like this. And oop, that's not where I wanted to go. So I'm going to comment this out for now because this is going to be handled across the application. And let's see, we also had this in the delete case, right? So here we're going to do the same thing. If the user ID is not in, not in profile infos, we're going to raise this user not found exception. And going back to our delete endpoint here, I'm going to remove this. All right. So now in both of these cases, we're going to be raising a user not found exception. So if we just start up our application now, on the front, or kind of on the consumer side of it, if we try something that doesn't exist, like 2 here, we're going to see this 500 error because we're no longer handling the exception. Oops. But if we look internally here, we can see that we've raised a user not found exception here. So we are getting this custom exception that we've defined. All right, cool. So now let's go ahead and add a handler for it. So we can see here, this is kind of where we're defining our application with this factory pattern. And if we want to add a custom exception handler, then we need to define that for the application. So what I'm going to do here is I'm going to define a new function or a new coroutine, and this is going to be handle user not found exception, like this. And so for this, we of course need to import our user not found exception, but actually also what we need is we need to import the request object from Fast API, because that's one of the import parameters that we need here. We also need to actually accept the exception that we want to handle, which is going to be this user not found exception. This is just kind of the function signature that we need here. We'll put a pass here and do nothing here for a second. Now we're going to define this for our application, and we're going to add here in exception handlers like this, should be singular though, exception handler. And we're going to put in here the exception that we want to add this handler for, which is going to be the user not found exception. And now in here we can put the logic of what we want to do. Now going back to this case here, I'm just going to uncomment this, copy this for now, and bring it over, although we need to change it actually. But essentially this is what we want to do. So we have two issues right now. One is going to be that we have this user ID that we currently can't access. So I'm going to uncomment this for now, but we'll fix that in a second. The other thing here is we're actually raising an HTTP exception, which is what we were to do previously, but we can't do this inside of an exception handler, and I'll show you why. If we have our HTTP exception here, and I just relaunch our application here, and I try this again, we're still going to get an internal server error. And we can see here right now we're raising an HTTP exception, which is no longer caught because we've already handled this exception. So what we need to do instead is we need to take the JSON, oh, it's not where it is, it's going to be in fastapi.responses. We're going to import the JSON response that we've looked at, one of the first responses we've seen, and we're going to update this. Instead of raising an HTTP exception, we're going to return a JSON response, and the status code is still going to be 404, and our content is just going to be the user doesn't exist, which is the detail that we had previously. So now if we try this and we execute, we can see here we get the 404, we get the message that the user does not exist. And yeah, so with this we can see now we no longer have to, if we have many of these cases, we can just raise the error, and rather than having to catch and handle each of these in each of our endpoints here that we've defined, we can just define a global handler for that exception that will, essentially do that work for us. Now there's still some things I want to change. The first thing I want to do is actually want to move this out of here into its own file, just to keep things clean, because imagine you have 5 or 10 exception handlers. This is going to be extremely long, and we don't want this clogging up what we have here. So I'm going to create not here, and here in our application, I'm going to create a new file that I'm going to call exception handlers, like this. And I'm going to cut this, and I'm going to create a new function here that I'm going to call add exception handlers, and this is going to accept an application of type FastAPI, and it's not going to return anything. And what it's going to do is it's going to register this with our application. So now we just need to import all of these things that we're missing. So I'm just going to take all of these imports over and then delete the ones we don't need, like this. So we can just delete this. So there we go, all of our import errors should be fixed. And now here I'm going to delete all of the imports we're no longer using. So we have our custom exception handler function defined here, as well as an add exception handler function, and we're just going to return none from here. So now we just need to register this exception handler with our application, because right now, if we try this again, we're going to get a 500 response again because our exception handler is no longer registered. So I'm going to say here from app.exception handlers, I'm going to import this add exception handler function. And I'm just going to pass our application in, and we don't actually need to return it and overwrite it like this, and then here return our application, because, well, we're just going to be registering it directly because we're passing a reference to the object. And so with that, it's just going to be added into our application. We don't actually need to return and overwrite it, although you could if you wanted to. So yeah, we're going to be calling this add exception handlers function, and we're going to pass in our FastAPI class, FastAPI instance that we have here. And this is just going to add this exception handler that we've defined to our application. And so with this, we just made this a little bit cleaner because now we can put a bunch of extra exception handlers here, and it's not going to clog up any of the stuff here. It's still going to be very readable. All right, so trying this again, we now have the same response that we had earlier. Nice. So some more things to add though. First of all, I'm going to import logging again here. And just like we did here, I'm also going to, again, define a logger here. So I'm going to say logger equals logging.getLogger, and we're going to use this special name variable to give us the name of our current location for the specific logger. And now we want to log this error. The thing is, we still don't have the user ID. So how can we get this? Well, the way that we're going to do this is we're going to change our custom exception, and we're actually going to add an initialization component to it. And here we're going to pass the user ID, and we're going to set the attribute here for this exception, and we're going to give it a user ID attribute. So this is going to work just like any other class. So that means when we raise our custom exception, which I think if we go here, when we raise our custom exception here, now we can pass in the initialization parameter, and we can say that the user ID is this user ID component, and I'm going to do the same thing in the other place where we raise it like this. And so now with our exception, we actually have access to this user ID attribute. So if we go into our exception handler, we can access this attribute. Oops, no, it's going to be here in the exception because that's going to be the variable that has this user not found exception. And so here we can access this user ID attribute. Again, very similar or basically identical to what we've done when we've used classes in the past. All right, so, and actually let's add a print statement here too, just so that we can see this in our console directly. Like this. Okay, so starting our application again, going to make a request. So again, we can see here user not found, and we can see here non-existent user ID 2 was requested, which is exactly the output that we have from here. So nice. I can take this away, and it looks like actually this time it was showing up in our console. Yeah, so we don't even need the print statement. Cool. So yeah, this is how we can add custom exception handlers for specific exceptions. And yeah, you can put any exception here that you want. In our cases, we defined a custom exception that we specifically want to catch for a specific purpose because this means something to us. And we know exactly when to raise this rather than catching something like a value error or a key error, which could be more ambiguous and it may be harder to write, a general statement, and it may be better to fail with just a 500. But we know in this case that we have instances where the user is not found, and rather than adding the same exception handling to every single one of our endpoints here, we're just going to add a custom exception handler to our application that every time this exception is raised, we can just deal with it properly in the same manner. And that's just going to save us some work so that we don't have to repeat the same code in each of these places, but rather we're just going to add it once, handle it once, and if we want to make changes, we can do that here. And yeah, just going to keep things clean and structured and prevent us from writing and repeating more code than we have to. All right, so in this lesson, we're going to look at headers, and we're also going to look at how we can define some dependencies for our application. We'll see what that means in a second. But first, let's take a look at headers. So let's go ahead and start our application here. Pull up the documentation. Just going to refresh this to get this live, and then we're just going to issue a very basic request here. So we've seen the response body. Right? In this case, when we have our user ID endpoint, it is this form. We've seen the status code, which tells us about how the status of the request, and in this case 200, everything went okay. And now we also have this extra field here called the response headers. Now the response headers give us extra information about the response that, for one, it doesn't even necessarily need to depend on whether the request succeeded or not, but also it doesn't matter what the response is here. For example, if we take a look at this, we can see here there's a content length, which presumably tells us something about the length of or the amount of data that was returned, the content type, what format this data is in. Right now we have a JSON format. We've seen a different format previously, which was the plain text format. There are also other formats available, like multimedia formats, for example, for like images and stuff like that. So this is something that can also change. And we have the date that the request was made, and we also have information about the server that handled the request. Right now it's just our Unicorn server. So the response headers, or in general, the headers contain information about the request that again does not necessarily depend on what exactly was returned. And this can provide extra information. For one, like the content type can, tell the consumer how they maybe want to process this or what format this data is actually in. This can be just interesting, for like general logging purposes as well as the server. If something went wrong, maybe you want to like log the server, and you can see that whenever it goes to this server, there are some sort of issues. So yeah, just general information that may or may not be useful to the consumer of the endpoint that actually doesn't include any of the data that they're asking for. And so what we're going to do now is we're going to add an extra parameter to this header, which is going to be a rate limit for our application. So what is a rate limit? A rate limit is essentially when you think about having a server and you have your endpoints available. Right now, I could just click execute over and over and over and over and over again, and it's always going to accept my request and do something with it. Now, I can't hit execute fast enough, but you can probably think about writing a very simple program that just sends a request to our server here over and over and over again in an infinite loop. And then you can think about maybe running 10 of those programs or 100 of those programs or whatever. The point being that at some point our server will be receiving so many requests that it can't deal with the load. In addition, we also don't want clients to be able to send so many requests because the use cases may not require it. And so what we can do is, if we want to limit the amount of load that our server can accept, we can introduce rate limits. Now, there are different places where we can introduce this. We're going to look at introducing it in our application because obviously we're building an application. So we're going to look at how we can do that from that side. And the idea essentially is that we'll have a predefined time frame. And we'll also have, in this, our very simple case, we'll have a predefined limit of the total number of requests that our server can accept. Generally, you probably want to do this per consumer. So for example, if you have 2 different users, each of them is allowed to do 5 requests so that they don't interfere with each other. Obviously, that number is probably going to be higher, but you get the idea. So what our rate limit is going to do is we're going to say, okay, our server can accept 5 requests, let's say per 10 seconds. And when it's accepted 5 requests, then it's just going to raise an error code, and it's not going to respond to anything else. It's just always going to return an error until those 10 seconds have passed, at which point we're going to accept 5 more requests. And that, for example, is a very easy way for us to limit the load on our server. Although the request will still be coming in, we can very quickly just raise an error rather than having to do any CPU intensive work or going to any database or anything like that. We can just see, nope, we've reached the maximum number of requests that we're going to serve. We're going to protect ourselves against being overloaded, and we're just going to return an error until this timeout window has passed. So obviously, for consumers to be able to work with this, they need to have some sort of understanding as to where they currently are within this rate limit. Because otherwise, they're just going to guess like, oh, is it going to work? Is it going to work? Is it going to work? No, they need to be able to know that, okay, I've reached 4 out of 5 requests. I can send 1 more request, and then they send it, and now they know, oh, okay, I've reached, my 5 requests or something like that, and now I need to wait a little bit. Okay, so yeah, let's go ahead and implement providing that information through the header, and we're also going to implement the rate limit into our application. So I'm going to go back to our code here, and I'm just going to start adding the function here, and then we'll change it at the very end and move it around to have it be a little bit more clean. So I'm going to add some spaces here, a new function I'm going to call rate limit. And right now it's not going to do anything. This is just going to be a placeholder reminder for us in a second. Now the first thing that we need to do is, how do we get access to our header? And how can we manipulate that? So the way that we're going to go about that is we're going to import this response object from FastAPI. And then wherever we want to have this rate limiting, or this adding of the header, which we'll do first, and then we'll implement the rate limiting, we can add that as a path parameter into our endpoint. So for example, we can say here, we're also going to, should be a comma, we're going to accept a new input, which is going to be called response, and it's going to be of type this response object that we've imported here from FastAPI. And now, if we want to add a header, we can go either before or after. I'm going to do it after. Into this response value, I'm going to go into headers here. And now I can essentially provide a key value mapping where our value should be a string. So for example, I can say test additional header value. This is just something I'm adding. All right, so let's try out this new endpoint with the header added. Now we can see here, this actually shows up in our response header. So this is how we can add information into our header. Obviously, this is not very useful, so let's go ahead and make this a little bit more useful. And to do that, again, we're going to have this rate limit function here. Okay, so we're going to do this very simply. We're going to define some global parameters. I'm going to have a global count, which I'm going to set to 0. I'm also going to have a start time. For this, I'm going to use the time module. I'm going to import time. And there I'm going to call the time.time function, which is just going to give us the current time in Unix epoch time. So it's just going to essentially give us a very large integer that gives us the time from, I think it's the 1st of January 1970 in seconds. So yeah, it's called the epoch time, and if you want to learn a little bit more about that, I would just recommend a quick Google search, and you'll get a lot of information. But essentially, we just have a monotonically increasing time value here that we can use for timing. I don't want to get too much into timing because there are a lot of weird things that can happen here, because essentially it's very likely that the time on every machine is going to be slightly different because they're not all perfectly calibrated, or they're all kind of having this time drift. But for right now, on this single application, we're not going to worry about any of these time constraints, and we're just going to take our current time in seconds. It's just actually going to be a float, so we're going to have an integer plus some decimal numbers to it, and just kind of treat it as an ever-increasing time amount. Then we're also going to have a reset interval. And I'm going to set this to 10 seconds. So I'm just going to call it 10, but we'll use it in the sense of seconds. And we also want to have a limit to the number of requests that we can accept. So I'm going to set this limit to be 5. So looking at this, we're going to accept 5 requests per 10 seconds. And these variables are going to help us keep track of how many requests we've served and when we've started this counting, so that we can reset it properly. All right, so let's go ahead and implement this. So the first thing that we're going to do is we're going to implement a check to see if our rate limit has been exceeded, and if it has, then we're going to return an error. So we're going to say if count is greater than or equal to limit, then we want to raise an HTTP exception. Now the status code that we're going to use here is going to be 429, which means that the rate limit has been reached. And the response details that we're going to give is, I'm going to format it like this, but there are different ways of formatting it. I'm going to provide an error key, and here it's going to be the message. So rate limit exceeded, and I'm also going to provide some information about the timeout. So how long they need to wait until they can try again. And so our timeout here is going to be our start time plus the reset interval. So that's going to be essentially when our rate limit resets. But the time until then, so how long they should wait, from here we have to subtract the current time. So for example, if we started 9 seconds ago and our rate limit resets every 10 seconds, so if we started 9 seconds ago, then we only have to wait 1 second. So it's going to be 9 seconds ago plus 10 seconds, which will be 1 second from now if we subtract our current time. Now we're going to format this a little bit differently so that we don't return a super long floating point number, so I'm just going to use this built-in Python round function that we have access to, which allows us to round to a certain number of decimal places. I'm going to round to 2 decimal places, and then I'm going to increment this by 0.01 just to make sure that in the case where we round down, we're always going to be a little bit above that timeout rather than below. So yeah, I'm going to provide this information in the response, essentially saying, hey, please wait this long until you try again. Okay. So the other thing that we need to implement is some sort of rate limit reset. And we're going to implement that actually before we raise our exception. Because if the rate limit has been reached, but it's been reached 20 seconds ago, we don't want to return an error. We want to reset our rate limit, and then no error will be returned. Because if we did 5 requests between 10 and 20 seconds ago, and now we're 20 seconds after, but no requests have come in, again, we're back at 0, so we can serve more. So I'm going to implement this reset, and I'm going to say, if our current time is greater than our start time plus the reset interval, then I'm going to set our start time to be our current time. So resetting our start time, and I'm also going to reset our count to 0. And now, okay, so because we want to manipulate global variables currently, remember if we think back to our global variables, to manipulate this, we can access them just by accessing them. But if we want to manipulate them, then we actually have to import them as global. So we want to overwrite our start time. The other thing that we're going to change is going to be our count. So we're going to also implement the global count variable here. All right, so now we have a rate limit reset as well as raising of the exception. Now another thing, or now we actually can implement the other logic, which is going to be if, regardless of if a reset has occurred or not, and if no exception has been raised, then what we want to do is just increment our count here by 1, and we want to add some information into our header to provide details essentially of where we currently are. So for that, we obviously need to pass in our response object. And so what we're going to do is we're going to go into our response here, response.headers, and now we're going to provide some information in the header about where we currently are in the rate limit. Now generally if you add custom headers, you would do this by adding an uppercase X, and then when you have, so for example, if we look at our Python variables, the way we do our naming is by separating it by underscores. And our headers, the way that we would do that is instead separating it by dashes. So what I'm going to do here is I'm going to call this header app rate limit, which stands for application rate limit. So the rate limit across the whole application. That means regardless of what endpoint you hit, this rate limit is counted just how many times you go to this application, regardless of what method you're using. We can also have method-specific rate limits, for example, where you can use each of these a different number of times. So here you can go 3 times, here you can go once, here you can go 5 times, whatever. Or obviously these numbers can be higher too, just giving some examples. But our app rate limit here is going to be across the whole application. And now I want to give a value in here. So the way that I'm going to format this, and again, there are different ways of approaching this. The way that I'm going to format this is I'm going to provide the current count and then separated by a colon, and I'm going to provide the limit. So now they have information about where they currently are, as well as the total number that is available to them. So they know, for example, if they've made 3 requests, okay, I'm at 3 out of 5. And then I'm just going to return nothing from here. Okay, so we have our rate limit logic implemented. Now we just need to be able to use it. I'm also going to just add a typing here to say that we're not returning anything. All right. So how can we add this into our endpoints here? So one way that we could think about this is we could just, call this function here. So we could call rate limit with the response like this. I'm going to take this out because this was just for example, we no longer need it. So we could just add this colon directly like this. Let's go ahead and try that out. And just refreshing this, although we actually don't need to because our documentation will stay the same. So this is the endpoint where we've implemented this. So let's go ahead and try this out. And we can see here we do have our information included in our response. Nice. And if I do it a couple of times, you can see here it's incrementing. And now, well, looks like we just hit a reset. So there we go. Now we have an error response. And we have a timeout here too for this rate limit being exceeded. All right, so not bad. There was a small bug in there that you may or may not have already noticed, which is that our timer actually starts when the application starts up, not when the first request comes in. So yeah, it's a little bit of an iffy thing, because technically if we start up and then 5 seconds later the first request comes in, then after 5 seconds it will be resetting, but we're not going to worry about that now. So yeah, a small little logical bug here, but we'll just ignore that for now. All right, so this works, but there are better ways that we can actually implement this. And so this is where we're going to look at dependencies. Now we're not going to go through all of dependencies because there's a lot of cool stuff that we can do with it, but we'll look at just one small example. So we're going to import depends from FastAPI. And now in our input parameters here, we're going to say this response value depends on the rate limit function. And so what this means is that this response value will be set to the return value of this here. And because our response value is where we set our header, we're actually able to set our header like this, and we can actually handle this directly without, needing to add this in here. So as soon as the request comes in, to set the response value, we need to execute this function here, because this value here depends on whatever is returned by this function here. Now, we can actually just update our header. We don't need to return and overwrite it, although I'll show you in a second that we can do that too, and it will work too. But let's just, well, I guess we don't need to refresh it, but let's try that again. So we can see here now we still have our rate limit information contained here, and when we execute this, we can see it's going up until we reach our rate limit, and we have our timeout here telling us how long we need to wait, as well as our status code here. And then once we've passed our timeout window, we can once again continue issuing requests. And so now we're able to handle this rate limit before anything else in our function actually gets executed, because it's part of setting this variable here. Now this is already quite nice, and this here is already extremely powerful because we're able to initialize these values here, based on the return value of a function, which is pretty cool. And just to show you that we can also return this object, because really this value here is set as the response value of this one here. It's just when we have this value, we are updating some of its properties. And so even if we don't set it, we're still updating values from it. And so it's not going to make a difference in this case, but we can actually return this response object to here. And generally you'll want to return stuff when you use this depends here. So let's try that again. And we can see it is still working just as before. All right, this is still not ideal though, because if we want to add this rate limiting to everything, we essentially have to add this to every single function, or to every single like endpoint. Here, we just have to add it in as a parameter, which again is not great. So what we can do instead is we can actually add this to our whole API router here. So we can define the dependencies parameter here, and then we're going to provide a list of dependencies. And the first of these is just going to be depends on the rate limit function here. And then we can take this out. And actually, before I do this, I just want to show you that this right now does not work across our different endpoints. So it's just at this endpoint. When I execute this, we have the rate limit. But when I go to this one, for example, and I execute, we do not have the rate limit. But now, if I put it in as a dependency across our whole router, and again, the syntax here is we have to put it in as a list, and then we can provide the different dependencies if we want to have multiple as depends, and then the function that it depends on. And I can take this out like such. And now when I execute this one, for example, we can see here in our response, we also have it. And if I increment it again, we're going to have it. Now if I go to our different endpoint, we're actually going to reach our timeout. So we have 2, 3, and now we're going to execute here. We have 4, and now I'm going to execute here. We have 5, and now let's see if I can do this quickly enough. No, not with this one, not with this one either, because I need to provide input data. So let's try to get this break. 1, 2, 3, 3, and then we'll do 4, 5, and now it should break if I was fast enough. Yep, there we go. So we can see that our rate limit works across all of our endpoints. And yeah, we're able to provide that by providing this as a dependency across our whole router. So yeah, that's how we can add headers to our responses, and as well as how we can actually use this dependencies in this case to implement a very simple rate limiting thing. Now I'm just going to move this into a new file to clean this up a little bit called dependencies.py. And I'm going to take this, cut, paste, and now we need to import all of the appropriate things. So we're going to say from fast API, import response. We need the HTTP exception. We also need to import time. And we should probably add logging here, but I'm not going to add it now. All right. And now we need to go back to our users, and we're going to say here from app.dependencies, we want to import this rate limit. Now we can take this out because we are no longer using that here, and start up our application again. And everything should work just as it did before, which we can see here, all working as intended. Very good. One more thing that, well, if we want to, we could clean this up a little bit. This is actually relatively short that we maybe even don't need to, but yeah, we could. This is relatively short, so very readable, even just without any scrolling, so we can leave this as is for now. Obviously, this implementation is not super ideal because we're using global parameters and we're just kind of incrementing these, and it'll probably be much better to have a class deal with all of this. However, we're just going to leave this as now, just as kind of like a proof of concept. So yeah, this is how we can go, again, about adding the rate limits, about adding the dependencies. There's, again, a lot more cool stuff that you can do with dependencies. This is just like the tip of the iceberg, but hopefully you can already appreciate and see the value of this. And also, thinking about when you have similar use cases, maybe, dependencies is the right way to go to help you deal with the specific use case that you're trying to solve.